Hey guys, I hope you're doing great today. Well, this is our chapter number 35 in which we are going to talk about what is Kubernetes. Guys, this would be our fifth DevOps tool on DevOps Molvi channel. So make sure that you subscribe DevOps Molvi because we are going to learn a lot about DevOps tools and DevOps technologies. So today I am really feeling super excited and honestly saying that it would be a big day for me because we are going to learn about what is Kubernetes in today's lecture. And honestly saying that Kubernetes is a whole world. There are tons of concepts that we need to learn in Kubernetes. So this would be our introductory lecture on Kubernetes. Why should we use Kubernetes? And there would be separate lectures on each Kubernetes concept because I want you to learn Kubernetes from the very beginning, from scratch, and we should learn every Kubernetes concept, every components of Kubernetes, and how Kubernetes works, what are master and worker nodes, and the architecture of Kubernetes. So you must be thinking that why Kubernetes is known as Kubernetes. By the way, for your information, Kubernetes means captain, okay? It means a captain who drives the ship. Now, in Docker, we saw that there was a ship and that ship was containing hundreds or thousands of containers. And that ship is driven by a captain. Now, each container contains our application. So we can say that when we have thousands of containers running applications and they are now shift or managed, they must need a captain, right? So Kubernetes is the captain. When we have millions of containers, when we have millions, I'm talking about billions. By the way, Google runs billions of containers each week to power their search engine. So now when we have billions of containers, we must need a tool to manage all those containers. And that's what Kubernetes does. So the proper definition or the main concept of Kubernetes is to scale your applications, to scale or manage your containerized application. That is the core purpose of Kubernetes. So if someone asks you, what is Kubernetes? You can say that it is the DevOps tool that is used to scale, to manage all the applications that are running inside containers. So Kubernetes is a tool to manage containerized application. So that's why we have to learn Docker first, because our applications run inside Docker containers, right? Or we can use other containerization platforms like Containerd. It is also for running applications into containers. But let's suppose we are using Docker for our applications to run inside containers. And when we have hundreds or thousands or millions or even billions of containers, we need a tool to manage, to scale, to watch out all those containers at one time. And that is actually the purpose of Kubernetes. Kubernetes is the captain. It watches all the containers. It watches all the applications running inside those containers. Whether if any container is healthy or it is crashing, every responsibility that is owned by Kubernetes. So you can say that Kubernetes is a tool to manage our applications running inside the containers. That is actually the most simplest definition you would find. So back in 2014, Kubernetes was developed inside Google. So we can say that Google is the birthplace of Kubernetes. So it's been a decade. Kubernetes has reshaped how our applications run inside the containers. And believe me, you can search on Google that Google runs billions of containers each week to power its search engine. We know that there are billions of queries searched on Google each day. That is why I'm telling you the use case of Google, that when we have containers at that amount, billions of containers, you can imagine. So definitely we need Kubernetes to manage all those applications. So it's been a decade how Kubernetes has reshaped how we can deploy, manage, or scale our applications running inside the containers. And not only that, guys, Kubernetes also automates all the operational tasks of container management, and Kubernetes has built-in commands to deploy applications. With the help of Kubernetes, we can roll out changes to our applications. We can scale up or scale down our applications according to the desired workload. We can also monitor our applications with the help of Kubernetes. And the most important, we can watch all our containers that are running on our nodes. So for your information, guys, Kubernetes is also known as K8s. That is actually the short form of Kubernetes, K8s. And why it is known as K8s? It is because the alphabet K and S, there are actually 8 alphabets, 1, 2, 3, 4, 5, 6, 7, and 8. So that is why K and S, the number of alphabets between K and S are actually 8, and that's why it is known as K8s. So K8s is also the short form of Kubernetes. So finally, I would like to repeat, what is Kubernetes? Kubernetes is an open source tool to deploy, manage, provision, scale up or scale down, and monitor our applications. Alright guys, now you must be having some confusion between Kubernetes and Docker. After all, we know that Docker is a platform that is used to run our applications inside the container. Then what is the difference between Kubernetes and Docker? First of all, we must understand that both tools are different. Kubernetes is different and Docker is different. Yet they serve the same purpose, to run applications in a containerized environment. So we can say that they are interlinked with each other. They have the strongest bonding. Kubernetes and Docker have the strongest bonding with each other. Now we have learned almost every important concept of Docker containers. We have a full course on Docker. So we know that Docker helps us to run our applications into a box, which is known as a container. And we can ship that container and we can run that container anywhere in the world. So that is actually the core purpose of Docker, to containerize our application, to run our application inside a container. When we have that container, we can have the image of the container. We can ship it anywhere in the world and we can run our application into a container. But when we have those containers or those containerized applications in a large number, I mean in millions or even in billions, now we need a responsible guy. We need a responsible tool that should safely ship or manage all those containers. And that's what K8s or Kubernetes does. So you must not be confused. Docker to run applications, apps inside containers. Okay, these are my containers, 1, 2, 3. And now if these containers are in millions, 1 million, so definitely I will need a tool to manage all those millions of containers. And that's what Kubernetes comes in, and Kubernetes actually helps to manage, to deploy, to scale all those containers. And this is why Kubernetes is also known as the captain. So it is a captain who is the manager, who is responsible for all the applications that are running inside our Docker containers. And that's why, guys, I have prepared the Docker course first, because we know that Docker is strongly linked with Kubernetes. since Kubernetes is the captain of all the containers. So you can watch my Docker course, which is a 6 hours of Docker video, so that you have strong containerization concepts. And in my opinion, guys, I would like to say that Kubernetes is just like a whole new operating system with a lot of concepts. And I have decided to prepare a separate lecture on each Kubernetes terminology, like what is a pod, what is a stateful set, what is a replica set, what is a namespace. So you can say that there are tons of Kubernetes concepts that we have to learn. And in the next chapter, we are going to learn about what is Kubernetes used for. So make sure that you subscribe DevOps Molvi. We are going to learn every Kubernetes concept in this course. And I will see you in our next chapter, what is Kubernetes used for. So that's it for today's lecture. Have a good one and bye. Hey guys, I hope you're doing great today. This is our chapter number 36 in which we are going to discuss what is K8s, Kubernetes used for. Guys, since I told you that it would be a complete Kubernetes course, and I will try my best to cover each and every Kubernetes concept. So in the previous chapter, we discussed what is Kubernetes. Kubernetes is an open source orchestration tool which is used to automate, scale, and manage containerized applications. So this is actually the definition of Kubernetes. Kubernetes is also known as the captain, and it is responsible to handle all the complexities of running applications, those applications that are running inside the containers. And those containers actually reside or run on the cluster of several servers. Each cluster can have multiple servers. And on those servers, we run containers, and we have millions of containers. And we definitely need a captain to watch out all those containers. That is actually the example that I told you in my previous What is Kubernetes lecture. So I gave you the example of a ship with hundreds or thousands of containers. And that ship is actually run by a captain. So we can say that Kubernetes is the captain who runs the ship, and that ship contains thousands or millions of containers. So now we should know that what is Kubernetes used for. But before proceeding to the lecture, make sure that you have subscribed DevOps Molvi, because I want you to learn every concept of Kubernetes from the very beginning. Alright guys, number one, the Kubernetes is used for container orchestration, which is our number 1 point. Container orchestration. You might have heard about orchestration, but what is orchestration? First of all, we should know what is orchestration. It is also included in the definition of Kubernetes that it is an open source orchestration platform. But what is actually orchestration? So guys, listen to it carefully. Orchestration is the process to automate. Okay? Automate what? So orchestration is the process to automate provisioning. Number one, provisioning, scaling, deploying, and deleting applications inside the containers. Okay, so I can say that orchestration is a process which automates the provisioning, the scaling, the deployment, and deleting of applications running inside the containers. Now that would be actually the simplest concept, or you can say the simplest definition of orchestration. So you can say that orchestration is a process which automates the provisioning, scaling, deploying, and deleting of containerized applications. And that's what actually Kubernetes does. It orchestrates, it automates the process of provisioning new applications, scaling up or down the applications, deploying or updating applications, or deleting applications that are no longer needed. So this is actually the first, you can say, feature, or that is actually the key concept. What is Kubernetes used for? It is used for container orchestration. Now, what is orchestration? Orchestration is a process which automates these features. So it is actually the fully automated process, and Kubernetes does it without any issues. So whenever you are searching on Google about the best container orchestration platform, you will find Kubernetes at the top. Kubernetes is the number one container orchestration platform because it automates the process of deployment, scaling, provisioning, and deleting of applications running inside the container. Now, additionally, there are three more benefits or advantages of container orchestration. After all, when all these processes are automated, then we can save a lot of time by deploying applications manually. The time that is required to deploy any application manually is reduced when we deploy the application automatically. And number two, it also increases the productivity of DevOps engineers. And number three, it also reduces the resources and costs required for our applications. So you don't have to worry about orchestration anymore. I hope that you are now clear with the orchestration concept. It just automates the process of provisioning and deploying, scaling, or deleting containerized application. Alright guys, second feature, or you can say the second advantage of using Kubernetes is to scaling applications. Okay, scaling applications using Kubernetes. So that is actually the second feature or the second goal of what is Kubernetes used for. So what would be the simplest definition of scaling applications? The simplest concept of scaling application is to scale applications up or down based on demand. Alright guys, now you can see this simple concept of scaling application. When I have a high demand, it means that my application should have the ability to scale up the resources when there is huge amount of traffic, or when there is a large number of users accessing the application. So all my resources should scale up because more users mean more resources are required to avoid any downtime and to provide the best customer or user experience. So this is actually scaling up. The resources are automatically scaled up according to the users, according to the load, according to the traffic. And when there are no peak times, there are no users, my resources, extra resources that are no longer needed should scale down. And there would be less resources, mean that there would be cost reduction. So this is actually an automated process. More users mean the application should scale up and it should have the ability to handle all those users. Less users, it means that my application should scale down and all the extra resources should be deleted to avoid the cost. And now this should be an automated process, and that's what Kubernetes does. It scales up or scales down applications according to the users, according to the traffic, or according to the load. So that would be our second feature of what is Kubernetes used for. It automatically scales up and scales down applications according to the user's demand. I hope that now this concept is clear. Alright guys, number third point of what is Kubernetes used for. Kubernetes is used for load balancing our traffic. We all know that load balancing, as the name says, is a technique that equally distributes the traffic among servers. So for instance, if we have 5 or 10 servers and I want to equally distribute traffic on all those servers, I would have to use a load balancer. But what is load balancing in Kubernetes? in Kubernetes, the traffic is equally distributed among multiple pods. Okay, we know that in load balancing, we distribute traffic equally on the servers. And in Kubernetes, those servers are actually replaced by pods. Okay, that is actually the simplest concept. Now I have this pod 1, pod. Don't worry, we are going to discuss pod in detail. A pod contains a number of multiple containers. Okay, a pod contains containers. So this is actually pod 2, and this is my pod 3 on worker nodes. So all these pods contain applications running inside the containers. So load balancing equally distributes the traffic in these, this is pod 2. So load balancing in Kubernetes equally distributes the traffic in these pods. Now, for instance, due to some issues, this pod has been crashed. It is also our fourth feature, which is known as self-healing. So that pod is, for instance, no longer working. Now our traffic should be routed in these two pods because they are in good health. So that's how load balancing works. Load balancing equally distributes the traffic among multiple pods, and that's what Kubernetes does. So in general term, load balancing actually distributes traffic among multiple servers on the same network, and in Kubernetes, load balancing means to distribute traffic among multiple pods on the same network. That is how load balancing works in Kubernetes. Alright guys, the number 4th feature of Kubernetes, what is Kubernetes is used for? It is used for self-healing. And now what is self-healing? Self-healing means if a container in any pod, you can see these are actually containers, okay? Container 1, 2, this is also container 1, container 2, and container, there are 3 containers in pod 3, okay? So these are containers running inside the pods. If any of the container in any pod is failed, Kubernetes will automatically detect the failure of any container, and Kubernetes will redeploy to its original or working state. And that is known as self-healing. For instance, let me explain it with an example. If in pod 3, number 2 container has been failed, so Kubernetes will automatically detect that there is number 2 container that has been failed for some reasons. So we have to understand that Kubernetes monitors all the containers at every time, and Kubernetes compares the containers inside pods to their desired state. Now, in that case, Kubernetes will find that, oh, number 2 container has been failed. So Kubernetes will restart the container, and once that container is ready to be deployed, it will be deployed inside that pod. So that stuff is automatically done by Kubernetes, and that is why it is known as self-healing. And also guys, for your information, self-healing is not just limited to the containers inside the pod. Self-healing also detects and watches out the worker nodes. And we have these pods running on the worker nodes. So Kubernetes also checks out and watches the worker nodes. It also watches the containers inside the pods. And for any reason, if any worker node or container inside a pod is failing, Kubernetes will restart or fix the issues, and it will redeploy the container to its desired state when everything is all good. So that is actually known as, this whole process is known as self-healing. So guys, you must be thinking how we can write the Kubernetes configuration. And the good news is that we already have worked on YAML. YAML is used in CI/CD, YAML is used in Docker Compose, and luckily we have the YAML configurations in Kubernetes as well. So if you have watched my Docker Compose or CI/CD, GitHub Actions or GitLab lecture, you must be aware of a YAML configuration file. So guys, Kubernetes also uses YAML configuration files for provisioning, scaling, and deploying applications in containers. But don't worry, we are going to learn YAML configurations of Kubernetes in our upcoming labs. Alright guys, number 6 and the last point of our today's lecture. What is Kubernetes used for? It is used for rollouts and rollbacks. Rollouts and rollbacks. Guys, we know that in software development, our developers work and they introduce new features in any application. And when that feature is tested by the QA team, it is ready to be deployed on our QA or sandbox environments before deploying it to the production environment. So rolling out means to update your application or to launch new features without any downtime. And Kubernetes rolls out updates without any downtime or with very minimum downtime. And in case of any issues, if those changes are not meeting the client's requirement, then we can roll back all those updates or we can revert all those changes. So rollouts means to roll out new updates, new changes in your application. And in case of any issues, we can easily roll back all those updates or changes without any downtime. So that's what rollouts and rollbacks in Kubernetes automatically roll out your changes in your application. And if those changes are not as per expectation, you can roll back all those changes or you can revert those changes automatically in Kubernetes. So let me repeat what is Kubernetes used for quickly. Kubernetes is used for container orchestration, self-healing, scaling applications, load balancing, networking, automatically rolling out or rolling back changes, and with YAML configurations. So that's it for today's lecture, guys. What is Kubernetes used for? In the next lecture, we are going to learn how Kubernetes works. So we are going to discuss the architecture of Kubernetes, pods, containers, worker nodes, master nodes. So the next chapter would be really knowledgeable. Make sure that you stay tuned to DevOps Molvi. I will watch you in the next lecture. Have a good one and bye. Hey guys, I hope you're doing great today. This is our chapter number 37 of our DevOps Roadmap 2024, in which we are going to discuss and we are going to learn about the Kubernetes architecture. So you can say that it would be our third chapter of our Kubernetes course, and we are going to cover a lot of Kubernetes tutorials for beginners. Guys, in the previous 2 chapters, we discussed what is Kubernetes and what is Kubernetes used for. And I'm not sure how do you pronounce it, but I used to say it as Kubernetes while I was just checking Google and it was saying as Kubernetes. So that is up to you. How do you pronounce it? It is Kubernetes or Kubernetes. So in the shortest form is K8s. So it is better to say it as K8s. So today, this chapter is one of the most important chapters for DevOps engineers. As a DevOps engineer who are working on Kubernetes, we must know how the architecture of Kubernetes looks like. We have to see the deep inside of Kubernetes and we have to explore all the components that Kubernetes has. So make sure that you subscribe DevOps Molvi. We are going to learn tons of Kubernetes concepts. As I told you, let's get started. Alright guys, so in the beginning, we must know a general or a very basic overview of Kubernetes architecture. And that's what we are going to do in today's lecture. We are going to have a quick look on how the general overview or how generally the Kubernetes architecture looks like. So there are, by the way, a lot of Kubernetes components and we have to discuss them each one by one, and I don't want to overwhelm you. That's why I have a plan to take you gradually, and from the very beginning we are going to discuss, we are going to learn how generally the Kubernetes architecture looks like. So guys, in general, there is a master node in Kubernetes. So that would be our master node. In Kubernetes, there can be one or more than one master nodes. But for the sake of today's lecture, I'm assuming that we have only one master node. Okay, this is my master and master node, and it is running Linux. So you can say that it is a Linux box and we are going to treat it as our master node. Now, in Kubernetes architecture, we can have one or more worker nodes. So this would be my first worker node, okay? Worker node 1, and that would be my worker node 2, worker node 2, and this would be my worker node 3, okay? Worker node 3. So in this simple, and that is actually my cluster, okay? Now that whole thing is known as a Kubernetes cluster. So this cluster contains one master node and 3 worker nodes. So this is my K8s cluster, and this cluster contains one master node and 3 worker nodes. You don't have to worry about node. Node means a Linux machine, a Linux server. So this is also a Linux server, and these are also my Linux boxes, Linux machines. Every node or every VM should have Linux installed, and worker nodes communicate with the master node. Now there must be a question in your mind. So you understand the Kubernetes cluster. This is the very beginning, or you can say the very general overview of how a Kubernetes cluster look like. This would be the Kubernetes cluster architecture, where we have one master node and we have 3 worker nodes. All these nodes are Linux boxes, Linux virtual machines, and they are running on the cloud or on your on-prem data center. So now we know that we have 3 worker nodes and 1 master node, but the question must come up in our minds that how these nodes communicate with the master node, and how the actions that are triggered from this master node are executed on these worker nodes. How the commands, okay? Master node is the bigger guy. It should send commands to these small guys, okay? And how these commands are executed on these worker nodes, there is something behind the scene, and we have to understand it. But first, we must know that master node, there are, by the way, more components. We are going to gradually discuss each component. We have components on master node, we have different components are on worker nodes. But to make it more simple so that you can quickly get the general concept of how K8s work, we have this API server. This is one of the core components of master node. Which one? API server. Every action that is triggered, every command you can say that is triggered, that is executed on these worker nodes, it is sent via using this API. So we have this API that is used to trigger actions, to trigger commands, and those commands should run on these worker nodes. And those commands are used to manage pods or containers inside those pods, okay? And that would be actually our next step, to understand about pods and containers running inside those pods. But for now, we must know that we have this API server, and this API server on the master nodes triggers actions, triggers commands. So how worker nodes know which command do we have to run, or what do we have to do? So we have a kubelet service, okay? So kubelet service comes with a kubelet agent. So I have to install this kubelet agent on each worker node, okay? Because API server on master node communicates with these worker nodes using kubelet service, and we have kubelet agent should be installed on each worker node. So I will use Kubelet. Okay, this is an agent. Okay, Kubelet agent, and this is also Kubelet agent. So we have, if we are going to expand our cluster, for instance, if I am going to add 5 more worker nodes, then I have to install the Kubelet agent on all these worker nodes so that they should communicate with the master node. Otherwise, master node should not know how many worker nodes should I have to manage. And using this Kubelet agent, those worker nodes talk with the Kubelet, the master node's API using the Kubelet service. We have this Kubelet service. I hope that now you are getting my point. And this Kubelet service using the Kubelet agent, we have to install Kubelet agent. Once Kubelet agent is installed on all these worker nodes, it uses the Kubelet service. And that Kubelet service from each worker node talks or communicates with the API on the master node, and that's how the actions are triggered between master and worker nodes, and that's how master node watches and runs commands, actions on all these worker nodes. So let me repeat it again. We have this API server on the master node. Okay, the master node is the cockpit, just like we have in any aeroplane. So we are going to discuss control plane as well, and what are the components of a control plane. But for now, we have this API service, and this API service using the API server triggers actions or commands, and those commands are executed on these worker nodes using the Kubelet service. And Kubelet agent uses this Kubelet service to communicate with the API. That's how worker nodes communicate with the master node, and that's how master nodes communicates with these worker nodes. I hope that now you understand the concept. So in short, I would say that without this API server on the master node, there would be no communication between the master and the worker nodes. Alright guys, now let's explore worker nodes and master nodes more. We need to understand that these worker nodes are responsible for running the containers. Okay, your containers are running inside the pods, and your pods reside on these worker nodes. Okay, so worker nodes are responsible to run all these containers inside those pods, and also additionally they are also responsible to run every command or every action that is executed from the master node. So in simple words, the master node is the big guy. It is your proctor, it is your monitor. It is used to manage these worker nodes. And worker nodes are the small guys, the responsible guys that have to execute, have to run the commands that are actually triggered from this master node. And also the master node, being the big guy, it is responsible for maintaining the cluster's state. So it has more responsibilities as compared to these worker nodes. Not only that guys, master node is used to deploy the applications, scale the applications, and manage all these containerized applications that are running on these worker nodes. Now you understand the responsibilities of the worker nodes and the master nodes, because being the big guy, master node has higher responsibilities. It has to maintain the cluster's state, it has to schedule, scale, and manage the applications, and worker nodes run all those commands and actions that are triggered from this master node. So guys, this was the simplest possible Kubernetes architecture, but now we have to expand it. We have to know more what's happening inside this master node and what's going on with these worker nodes. So let's have a deep dive again. Alright guys, now let's draw a cluster with one master node and two worker nodes. I'm going to draw a Kubernetes cluster. That would be our cluster with one master node. Okay, this is my master node. And I have these two worker nodes. Okay, now I have two worker nodes. This is worker node 1 and this would be my worker node 2. So master node is also known as control plane in Kubernetes. Okay, this is my K8s cluster, K8s cluster, and this cluster has one master node. And I told you that there can be one or more master nodes, but for today's lecture I am assuming only one master node. So we can say master node as control plane. And I have shared the example of the cockpit of any aeroplane. From cockpit, the whole plane is managed and run, okay? And in Kubernetes cluster, this is actually the control plane which manages the whole cluster's state. It watches out for any issues, and we have this master node also known as control plane, okay? Master node. So you don't have to confuse between master node and control plane. This is the Linux server, the big guy, okay? And it manages the whole cluster's state. Now there are a number of components inside this master node, or we can say control plane. We have discussed only one, which is the API server, okay? But we have other components as well. And also API is actually the central point, and using this API server, the whole communication is carried out using the APIs, and that's what API server handles. So I have this API server, and I have other components of the control plane like Kube-Scheduler, okay? Kube-Scheduler. And don't worry guys, we are going to discuss each term in our upcoming lecture one by one. Every terminology of Kubernetes would be explained in detail, but for today's lecture, you must know what are the core components of a Kubernetes cluster. And in master node, we have control plane, and in control plane, this would be our main component API server. We have Kube-Scheduler, we have Controller-Manager. This is my Controller-Manager. And I have a database which is etcd, etcd. Okay, now these are actually the four major components of a control plane, or I can say the master node. The first is API, Kube-API server. Okay, this would be, so the first one is Kube-API server. Now I would control plane components. Okay, number one, Kube-API server. The Kube-API server plays the most critical role of listening to every request, whether it is coming from the worker nodes or from the components inside the master node. Alright, so Kube-API server not only communicates with these worker nodes, but it also controls the other components like Kube-Scheduler, Controller-Manager, and etcd. So we can say that it is an initial gateway to the cluster. Every request that is coming from the worker nodes should come to first the API server. So API server is the core component that listens to each request coming from the worker nodes. And if we are going to create more new pods or delete the existing pods, Kube-API server is responsible to do that. So the first important component of control plane or the master node is API server, Kube-API server. Now the second is Kube-Scheduler. Kube-Scheduler is used to schedule the pods on these worker nodes. As the name says, it is used to schedule pods on these worker nodes. But if we are getting any request of scheduling pods, it should go through this API server. So I would say that this Kube-Scheduler will talk or will communicate with the API server, and then API server will allow this Kube-Scheduler component to schedule pods on each worker node. So after the Kube-Scheduler gets a go ahead from this Kube-API server, the Kube-Scheduler decides on which node should I schedule the pods. Alright guys, the third component is Controller-Manager. This is our Kube-Controller-Manager. Kube-Controller-Manager. Guys, since we know that this master node or the control plane is responsible for the whole cluster, it has to maintain the cluster stable. So it is responsible for cluster's health and stability. And that's what Kube-Controller-Manager does. With the help of this API server, Kube-Controller-Manager or Kubernetes Controller-Manager actually maintains the cluster's health, maintains the current state of the cluster with the help of API server. So there are multiple controllers inside this Kube-Controller-Manager, and with the help of those controllers, the current state of the Kubernetes cluster is maintained. But since I told you that this Kube-Controller-Manager also communicates with the API server to maintain the cluster's current state. And the fourth component is etcd. Fourth is etcd. And guys, it is actually a database which stores all of the cluster's data. So guys, I have tried to explain all these master node or control plane components in simple words in order to simply understand what is a Kube-API server. Kube-API server is the gateway. Every request from these worker nodes comes towards this API server, and API server is responsible to create and manage or delete pods on these worker nodes. Okay. The second is Kube-Scheduler, which communicates with API server to schedule the pods on these worker nodes. Then Kube-Scheduler finds a good or healthy worker nodes to schedule new pods. So it is known as Kube-Scheduler. The third is Kube-Controller-Manager, and this Kubernetes Controller-Manager actually monitors the current state of the cluster with the help of API server, and we have every data, important data of the whole cluster stored, and this component is known as etcd. This is actually the storage of the whole data of the Kubernetes cluster. So these are actually the four major and important components of any control plane or master node: API server, Kube-Scheduler, Kube-Controller-Manager, and etcd. API server is the gateway. It is responsible for the whole cluster, to create new pods, to delete the existing pods, and with the help of Kube-Scheduler, which is used to schedule the pods on the worker nodes, and Kube-Controller-Manager maintains and monitors the cluster's current state, and etcd contains the whole data of the cluster. So I hope that now you have a better and clear understanding of these four components of the control plane or the master node inside a Kubernetes cluster. Now let's quickly talk about the components of a worker node. What are the components that our worker nodes have? So this is actually more simple as compared to the master node. So in a worker node, we have the three major components. The first one is Kubelet. Okay, this is Kubelet, and this is actually Kube-Proxy. And similarly in worker node 2, we will have a Kubelet, which is an agent Kubelet, and we have Kube-Proxy. So we have Kubelet and we have Kube-Proxy, and along with that, our third component is Docker. okay, or container runtime. But for this lecture, I am going to use Docker as our container runtime. This is my Docker, and we have this Docker runtime here as well, Docker. Okay, and now I have this pod 1 and I have these 2 pods in our worker node 2. 1, 2 pods. Okay, these are pods, and this is 1 pod. So what is a kubelet? A kubelet is the worker node's component that is used to manage the pods and the containers running inside that pod. And as I told you that kubelet is also responsible to communicate with the API server on the master node. So we have to install kubelet agent on these worker nodes, and this kubelet agent uses the kubelet service, communicates with the master node's API server, and API server which actually creates and deletes the pods using kubelet service on these worker nodes. And at the same time, this kubelet agent also communicates with the container runtime. It also communicates with Docker. Okay, so I would say that in worker nodes, kubelet has more responsibilities. At the same time, it communicates with the API server on the master node, and it also communicates with the container runtime like Docker to create the containers inside the pod. In order to communicate with the master node, it uses the kubelet service. So we have to install the kubelet agent on these worker nodes. Now the last component is Kube-Proxy. Now the Kube-Proxy is a Kubernetes network proxy that runs on each worker node to route the traffic. So guys, I hope that now you know the core components of worker nodes. We have Kubelet, we have Kube-Proxy, and we have a container runtime like Docker or Podman or container. And in these components, Kubelet is the most responsible component of worker nodes, because at the same time Kubelet communicates with Docker, which is our container runtime. It also communicates with the master node's API server with Kubelet service, and it is also responsible for creating containers inside the pods. So it is not necessary that we must use Docker as the container runtime. As I told you that we can use Podman, we can use Containered, or we can use the Kubernetes CLI, container runtime interface. And Kube-Proxy is the network proxy which is used to route the traffic, and it also forwards requests coming from different services like the API service or kubelet service to the respective pods. So these are actually the 3 core components of the worker nodes, and we have these 4 core components of the master node or the control plane. So finally, what are the 4 core components of the master node or control plane? We have the Kube-API server. It is the most responsible components in any Kubernetes cluster. So the first component of control plane is Kube-API server, and it works as the gatekeeper. Every request has to pass through the API server, and it is responsible to create and manage and delete the pods on these worker nodes. The second component is Kube-Scheduler. It is used to schedule the pods on the worker nodes with the help of API server. The third component is Kube-Controller-Manager, which controls the state of the cluster. It monitors the state of the cluster with the help of API server and the controllers that are built in this Kube-Controller-Manager. And the fourth component of Kubernetes control plane is etcd, which is the database of our cluster, and it contains every information, every data of our Kubernetes cluster. And now, as far as the components of worker nodes are concerned, we have 3 major components of worker nodes. Kubelet. Kubelet agent is installed on all these worker nodes, and it uses the Kubelet service to communicate with the API server, and it is also at the same time communicating with the container runtime like Docker to create the containers inside the pod. And finally, we have this Kube-Proxy, which is used as network proxy to route the traffic among different nodes in a cluster. So my apologies guys, I hope that every concept is clear, and it looks like overwhelming, and it looks like that there is a lot of stuff that is going on within a Kubernetes cluster. But to be honest, if we focus on each component for a couple of moments, we can get our concepts cleared. But don't worry, because these components, these terminologies are being used extensively in our upcoming lectures. So for now, that's it for today's lecture, and we have discussed this simple Kubernetes cluster with one master node and two worker nodes. So this is actually a simple Kubernetes architecture, and it is a simple Kubernetes cluster. And in the next lecture, we are going to have some more details about these components. And after that, we are going to install Kubernetes, and we are going to create a minimal Kubernetes cluster of our own. So stay tuned. Make sure to subscribe DevOps Molvi. I will watch you in the next lecture. Have a good one. Bye. Hey guys, I hope you're doing great today. This is our chapter number 38 of our DevOps Roadmap 2024, and we are going to have a deep dive of a Kubernetes cluster. Guys, by the way, this is our fourth chapter of our Kubernetes course, and it is one of the most important Kubernetes cluster deep dive, and we are going to discuss each and every component of the master and the worker nodes in a bit detail. So as I promised that I will cover each and every concept of Kubernetes in detail. And as promised, let's have a deep dive into each and every component of the master node and the worker nodes in a Kubernetes cluster in this video. So before getting started, make sure that you have subscribed DevOps Molvi on YouTube. Let's learn the core components of the Kubernetes cluster in detail. Let's get started. Alright guys, before proceeding to the deep dive of the Kubernetes cluster, let's have a look and revise what is a Kubernetes cluster. Though we have already discussed a Kubernetes cluster in our previous chapter. So let's revise what is a Kubernetes cluster again so that our concepts are more stronger. And a Kubernetes cluster is a group of nodes that run containerized application. That is actually the simplest ever definition of a Kubernetes cluster. And guys, by the way, my goal is to simplify the definitions, and I actually rewrite those definitions so that you can better and quickly understand what is that concept or what is that thing in software or in Kubernetes. There is another definition of a Kubernetes cluster. It is a group of one or more nodes with running pods. Okay, we have pods on the master node and we have pods on the worker nodes as well. So it is actually a group of nodes that run pod. That is the simplest definition of a Kubernetes cluster. Now there can be one master node and a one worker node. That would be the simplest cluster that we can have. And we can have 3 master nodes and dozens of worker nodes as well. So that would be also a Kubernetes cluster. So Kubernetes clusters allow applications to be developed, moved, and managed more easily. That is actually the core purpose of a Kubernetes cluster. We have our applications that run on the worker nodes, those applications in pods, and in pods we have containers are directly managed by the master node. So it forms a Kubernetes cluster, and the goal is to have our applications developed, scaled, and monitored more easily. So containers can run across multiple machines and environments, including virtual, physical, cloud-based, and on-premises servers. Okay, so we can have our containers run on all types of these machines. It can be a physical machine, it can be a physical server, it can be a virtual machine, it can be a VM or instance over the cloud. So we have containers inside those pods. And Kubernetes clusters are comprised of one master node and a number of worker nodes. So guys, this is now obvious that we must have at least one master node and we must have at least one worker node. And the ideal, I was going through some literature survey and I found that the ideal Kubernetes cluster should have at least, by the way, this depends on your application's workload, but the ideal situation or the ideal Kubernetes cluster must have at least 3 master nodes and 12 worker nodes. That would be our ideal Kubernetes cluster. But of course, it depends on our application's workload. Otherwise, we don't need 3 master nodes and that amount of worker nodes. If our applications need only 1 master node and 2 worker nodes, then obviously we can have this kind of cluster. But I'm just sharing the knowledge that according to the IT experts, we must have at least 3 master nodes for high availability, for scaling our applications, and we must have at least 12 worker nodes in a Kubernetes cluster to have our applications highly available, scalable, and there must be a load balancing mechanism in the master nodes and as well as in the worker nodes. So in case of, for instance, if one master node gets failed, now we must have a backup of the master node and our application should not go down because of the failure of a master node or a worker node. So that's why I'm telling you this is an ideal Kubernetes cluster with 3 master nodes and 12 worker nodes so that our applications are available without any downtime. These nodes can either be physical computers or virtual machines depending on the cluster. We can have virtual machines on the cloud and we can use the managed Kubernetes as well as provided by Google or Google Cloud Platform or AWS or Azure Kubernetes service as well. So that was actually a quick overview of a Kubernetes cluster. Again, now I hope that you will never forget about a Kubernetes cluster. Now, what is a master node? We know that a Kubernetes cluster consists of a master node and worker nodes. What is actually a master node? By the way, guys, in Kubernetes, a master node is actually known as control plane. So it is also termed, most of the times people will say it as control plane. So you don't have to confuse with the control plane and with the master node. These are 2 terms used for one purpose, and this is actually the master node, also known as the control plane, and it manages the whole cluster. It is the big guy. As I told you in the previous chapter, it is the big and it is the most responsible person or a physical server, the most responsible server that manages our whole Kubernetes cluster. It is also known as control plane, right? And the master node is responsible for cluster management and for providing the API that is used to configure and manage resources within the Kubernetes cluster. There is one of the more core component and important part of the Kubernetes control plane components. It is known as Kube-API server. If you watched my previous lecture, I have also shared the details of the Kube-API server's responsibility. That is actually where it is actually the gateway of a Kubernetes cluster. Every request, whether it is coming in or going out, it is handled by the Kubernetes API server, Kube-API server. And it is also responsible for the management of worker nodes. Kubernetes has a master node. Master node manages all the worker nodes. And the control plane or the master node acts as the brain of the Kubernetes cluster. Now, this is more simple. It is just like we have a brain in our body. That brain controls all the actions of our body, right? So similarly, we have master node in a Kubernetes cluster that manages all the actions performed by that cluster. The Kubernetes cluster typically has 3 master nodes. I have already shared with you guys, and 3 dedicated master nodes. The recommended number provides 2 backup nodes in the event of a master node failure, and the necessary quorum to elect a new master node. Now, this is a more explanation. Why do we need 3 master nodes? One goes down, we should have 2 master nodes, and among one would be selected as the master node, and that master node will manage all these worker nodes. So this is why we must have 3 master nodes in a Kubernetes cluster, so our application should be available all the time. So this is actually the master node, or also known as the control plane. It is the brain of a Kubernetes cluster, and it manages every action inside a Kubernetes cluster. Now, what is a worker node? We should have at least 1 worker nodes, and the good amount is 12 worker nodes for high availability and scalability. A worker node in Kubernetes is a machine that runs containerized applications and handles networking for a cluster. After all, we must have our applications running somewhere. We must have our applications running inside the containers. Those containers reside inside the pods, and we have those pods run on worker nodes. So that is why worker nodes are actually where our workload exists, where our applications run. And worker nodes run applications, process data, and handle networking. These are the core responsibilities of a worker node. Every data of a Kubernetes cluster and configurations and applications that we develop, they run on the worker nodes. Kubernetes runs our workload by placing containers into pods on the worker nodes, right? The main responsibilities of a worker node is to process data stored in the cluster and handle networking to ensure traffic between the applications across the cluster and outside of the cluster are properly facilitated. So these are the core responsibilities of a Kubernetes worker node inside a cluster, and it handles every networking, it handles and processes data of our applications, and it also handles the traffic between the applications that run on those worker nodes. We can have 1 worker node in a Kubernetes cluster as the minimum number, but for high availability, as I told you, that we must have 2, 3 or more worker nodes, so that if one fails, if we have load balancing enabled, our applications must route to the healthy and running worker nodes. So I hope now that you understand what is a worker node. It is where our applications or our workload exist and run. Those applications run inside the containers, and we have those containers inside the pods, and we have those pods on worker nodes. So there is an important announcement that I would like to share, that the total number of nodes required for a cluster varies. Okay, this depends on your applications, depending on the organization's needs. However, as a basic and general guideline, we must have at least 12 worker nodes and 2 master nodes for any cluster where availability is a priority. So we must have these number of nodes. By the way, I have written here 2 master nodes, and some people recommend that we must have 3 master nodes, that if one goes down, the other 2 must decide which should act as the master node. So this is important, and you can be asked about it in any Kubernetes interview questions. Alright guys, now this is actually the most basic structure or layout of a Kubernetes cluster with 1 master node and 2 worker nodes. Now you can see this is actually a master node, and these are also the control plane, and these are actually the core components of the master node that we have already discussed: Kube-API server, Controller-Manager, Kube-Controller-Manager, Kube-Scheduler, and etcd. And we have two worker nodes, and these are the components of a worker node like Kubelet service, pods, and a container runtime like container or Docker. And you can see that we have load balancing enabled in these worker nodes. So now let's discuss each component one by one in more detail, that what is a Kube-API server, what is etcd, what is a Kube-Controller-Manager, and what is a Kube-Scheduler. And similarly, we have this Kubelet service, we have a container runtime, we have pod, and we have this cloud provider network edge, and it is, by the way, Kube-Proxy, which is the networking proxy which is used to route the traffic between the nodes. And this is me or users like you who are accessing the application. So this is actually the most general overview of a Kubernetes cluster architecture with one master node and two worker nodes. So let's discuss each and every component in more detail. The control plane components. The control plane consists of 4 components. The master node, okay? And what are those 4 components? I hope that you know if you have watched my previous lecture, as we have already discussed. Generally, the brief discussion has been done, and we have actually 4 components. The Kube-API server, the major, the showstopper, and the most important Kubernetes cluster's control plane component, which allows users to interact with Kubernetes cluster. We have Kube-Scheduler, schedules pods on the worker nodes. And number 3 is Kube-Controller-Manager, which monitors and controls the cluster's current state. And number 4 is the etcd. It is pronounced as etcd, or if you can say it etcd, that is your choice, but professionally it is pronounced as etcd, and it stores Kubernetes clusters everything. All the data is stored, it acts as the database. So these are the 4 core components of a control plane or a master node inside a Kubernetes cluster. Now, simply put, K8s is the container orchestrator platform capable of running different workloads in different environments with great flexibility. So it is from the DevOps Molvi, and I have combined different terms together to share the core purpose of a Kubernetes cluster. It is a container orchestration platform which is capable of running different workloads in different environments with great flexibility. Alright guys, number 1 component, Kube-API server, the cluster's gateway. This is our first important control plane component, and Kubernetes Kube-API server, or Kube-API server, the short form, is a core component of the Kubernetes control plane, which allows users to interact with their Kubernetes cluster. After all, it is the gateway. Every request is forwarded to the Kube, because we know that every request is forwarded to the Kube-API server, whether if it is from the other components of the Kubernetes cluster, whether it is from the Kubelet service or from the worker nodes, it will be forwarded to the Kube-API server. Kube-Scheduler is, if it has any request, it will be processed through the Kube-API server. If it is Kube-Controller-Manager or etcd, so it means that it acts as the brain inside the Kubernetes cluster. Every request has to pass through the Kube-API server, and it validates and configures data for API objects such as pods, services, and replication controllers. So you must have a question in your mind that how that requests are processed or handled, or how these requests are forwarded to the Kube-API server. We have a RESTful HTTP endpoint. It handles all the incoming requests to the Kube-API server. and the Kube-API server determines if a request is valid, and then this request would be processed. So it means that every request we put through kube control command, kubectl, it would be forwarded, it would go to the API server. API server will check whether this request is valid. It would be processed by the Kube-API server. And the Kube-API server is designed to scale horizontally, deploying more instances as required by the cluster. So all of these are the core responsibilities of a Kube-API server. It processes, it handles each and every request that is forwarded to it via, for instance, if we have Kube-Scheduler, we have Kube-Controller-Manager, we have etcd. All these components forward the request to the Kube-API server, and the Kube-API server handles all these requests accordingly. So guys, since it is a deep dive of all the Kubernetes core components, we must know how the Kube-API server works and what are the other responsibilities of a Kube-API server. And before proceeding, I just want to share a common example of a Gmail account. When you log in, you want to log into your Gmail account. What do? You put your username, your abc@gmail.com, and then your password. So after that, this username and password are actually, they are checked from the database whether these credentials are valid and correct, and then you're authenticated to log in to your Gmail account. So if you want to log in, if you want to access the Kubernetes cluster, you are going to be authenticated, you are going to be authorized using the Kube-API server. So first of all, if you are trying to access, you are going to log in to your master node, it will verify the identity of the requester using methods like client certificates, bearer tokens, or username and password. So if you have any of these credentials like certificates or tokens or username password, then what Kube-API server will do, it will check the requester has the necessary permissions to perform the requested operation. So if you have those permissions, then your request would be validated, and Kube-API server will ensure that the resource included in a request is valid. So first, you have to give the certificate or token or username and password. And to make it more simple, let's assume we have a username and password. We put the username, we put the password, and after that, this request would be processed, would be authorized whether this user has the necessary permissions, and if this request is valid, the user has the necessary permissions, then it will validate and configures data for API objects like pods, services, and replication controllers. So you would be able to see the pods running, the services, the deployments, the namespaces, and replication controllers. All these are actually the Kubernetes terminologies and Kubernetes services. After that, retrieves and updates data, and just like logs, okay, that information is retrieved and the data is updated in the etcd, which is the database of a Kubernetes cluster. So guys, that's how a request is authenticated, authorized, it is validated, and then that user with the necessary permissions, and Kubernetes API server validates every information. We put username, password, we put token or certificates, and we must have the required permissions that are set by the administrator or the cluster manager. And after that, if everything is valid, our request is processed by the Kube-API server, and then we can access the pods, we can access the namespaces or deployments, and at the end, every information, every log is stored in the etcd database. So this is how the core functionality of a Kube-API server. I hope that now you know how Kube-API server works. Alright guys, number 2, the second core component of a Kubernetes cluster is Kube-Scheduler, and it is actually the default scheduler of a Kubernetes cluster. And what is a Kubernetes scheduler, Kube-Scheduler? It is the default scheduler in Kubernetes that assigns pods to the nodes in a cluster. By the way, it schedules pods on the worker nodes, and the Kube-Scheduler considers various criteria. We are going to check which are those criteria in how Kube-Scheduler works in the next slide. When making decisions, it checks for resource requirements, hardware constraints, and the node selector. So everything is automatic in the Kube-Scheduler. For scheduling new pods, it is actually the responsibility of Kube-Scheduler. Now we have to check how Kube-Scheduler works, and these are the 4 core steps how a Kube-Scheduler works. So first of all, the Kube-Scheduler selects a node, a worker node for a pod. Okay, I want to scale up my application. I need a new pod for more new containers. So this is now the responsibility of Kube-Scheduler, and I have, for instance, 12 worker nodes. It will select the most healthy worker nodes, and it will find the most feasible node that meets the pod's scheduling requirements. Now this is actually the responsibility of Kube-Scheduler. It has to find the most feasible node. Number 2, it scores the feasible nodes using a set of functions. Those functions are already and automatically configured in the Kube-Scheduler. So to find the most suitable worker node for a new pod, and it will select the node with the highest score. It is just like if a worker node has 9 out of 10, then Kube-Scheduler will definitely select that node. And after that, the pod is bound to that worker node. So this is actually if we consider it in more simple terms, it is just like that the most healthy worker node is selected, but after all, it is the responsibility of the Kube-Scheduler to find, to score which ranks 9 out of 10 or 10 out of 10, and then this feasible, the most healthy, or the worker node with the lowest amount of traffic, that feasible node is selected for the new pod, and this is actually controlled and done by the Kube-Scheduler. Okay. Number 3, the third component is Kube-Controller-Manager, and it is actually the cluster's daemon, Kubernetes cluster daemon. Now, what is a Kube-Controller-Manager? It is actually a daemon in Kubernetes that manages a cluster's controllers and keeps the cluster in the desired state. It never goes our cluster down. It has to maintain the cluster's health. It has to monitor the cluster's current state. That is why it is known as the controller. It has to control the current cluster's state. And the Kube-Controller-Manager runs in the form of a container within a pod. So it means that we have pods on the master node as well. And this Kube-Controller-Manager runs in as a container inside a pod on the master node, and it ensures that there are enough healthy pods on the worker nodes and the master node as well. And we have inside this Kube-Controller-Manager, we have more controllers like replication controller, endpoint controller, namespace controller, service accounts controller. These are all the types of controllers inside a Kube-Controller-Manager, and these are all the parts of a controller, this Kube-Controller-Manager. So that is why, guys, it is known as Kube-Controller-Manager, because it is the responsible controller that manages other controllers. I'm sorry, this would be a little overwhelming, but you have to understand that we have more controllers inside the Kube-Controller-Manager. and the Kube-Controller-Manager actually controls the other controllers like replication controller, endpoint controller, namespace controller, and so on. So this is actually the responsibility of controller manager, but for your knowledge or for your easy remembering, you must know that it is responsible to maintain the cluster's current state, to maintain the cluster desired state or the healthy state. This Kube-Controller-Manager is responsible for that. And now, how Kube-Controller-Manager works? It works as it monitors the cluster state through the API server. So we know that every request is forwarded to or processed to the Kube-API server. So it also communicates with the API server, and the Kube-Controller-Manager makes changes to move the cluster's current state towards the desired state. And number 3 is it manages multiple controllers that are responsible for specific activities. So that's how a Kubernetes controller manager works. It processes the monitoring request, the current cluster's state to the API server, and that's how the communication is done. And that controller manager tries, or it has the responsibilities to maintain the cluster's desired state. Alright guys, number 4 is etcd. It is more simple and straightforward component. It is actually the database of the cluster. And what is etcd? Etcd as pronounced as etcd, and it means that distributed etc directory. The name of etcd is actually, the abbreviation of etcd is actually distributed etc directory. And number 2, etcd is where Kubernetes stores all of the information about a cluster's state. Every data of Kubernetes cluster is actually stored in the database, and that database is known as etcd. So if you want to have a proper definition, I have also mentioned the definition of an etcd or etcd component. Etcd is an open source distributed key value store, and it manages critical information for distributed systems. This is the definition of etcd, and it stores and manages configuration data, state data, and metadata for distributed systems. And it is also used as the backing store for all the cluster data in Kubernetes. So for instance, if you're asked in any DevOps interview about the data storage point in Kubernetes cluster, the answer is etcd. Etcd is where every data of Kubernetes cluster is stored. And how etcd works, we must know that as well. Etcd uses a watch function to monitor data and reconfigure itself when the changes occur. So there is a function that watches, that monitors every change happening inside the cluster. Since etcd is the core component of the master node, so it watches every request being processed, being forwarded to the Kube-API server. It monitors the processes coming in or out from the other components like Kube-Scheduler or Kube-Controller-Manager, and all of that is happening with the help of watch function, and that function actually works inside etcd. And since it is a distributed system, etcd replicates data across multiple nodes in the Kubernetes cluster. And as a distributed system, etcd replicates data across multiple nodes in the Kubernetes cluster. Now what does this mean? It means that if a single master node fails, the data should never be lost. So that is why it is known as distributed etcd directory. So the data is replicated on all the master nodes, and if one of these master nodes gets failed, our data will never be lost. And etcd saves the data in key value format like name and its value, age and its value. So that is how the data is stored in etcd, and each piece of data, the value is accessed by a specific key. Kubernetes stores the cluster state and the configuration of its resources as key value pairs in etcd. And the number fourth is how etcd works. The state of the Kubernetes cluster, including which nodes are part of the cluster, what pods are running, what volumes are attached, all are stored in etcd etcd. Okay, so how many pods do we have? How many worker nodes do we have? How many containers inside those pods are running? Which are healthy? Which are failing? So every data is stored in etcd. So this is actually the database of a Kubernetes cluster. So these are the four core components of the master node or the control plane: Kube-API server, Kube-Scheduler, Kube-Controller-Manager, and etcd. I hope that you will now never forget. So guys, I have tried to make every concept simple as much as possible, but still, if you are having any confusion about any control plane component, you can comment and I will try to explain it more detail if you are facing any confusion or if you want to have more answers of any control plane component. Now let's start with the worker node components. And one worker node, each worker node has three components. It consists of three components, and it means that there would be three components on each worker node. What are those components? Let's explore on the worker nodes. So the number one component is Kubelet, and it is a Kubernetes agent on each worker node. Number two is Kube-Proxy. It is the network proxy for the communication. And number three is Container Runtime, and it is for running containers like Docker or Containered. Now let's explore each component one by one. And number one is Kubelet, which is the worker node agent. Now what is actually a kubelet? Kubelet is a node agent that runs on each worker node in a cluster to manage containers and pods. Okay, so we have to install and configure Kubelet agent on each worker node. Okay, now that should be clear. There must be a Kubelet agent on each worker node, and with the help of this agent, each worker node will have to manage the containers and pods. Now, there should be a question in your mind that how worker nodes communicate with the master node, and it is because of the kubelet. Kubelet makes it possible and it facilitates communication between the Kubernetes control plane and the worker nodes. And Kubelet also ensures that containers are running and healthy and that they are in the desired state on each worker node. And Kubelet registers the node with the Kubernetes master components such as the API server. Kubelet also ensures that the containers are running and they are in the healthy state, and also they are also in the desired state. And Kubelet registers the node with the master node. Okay, for instance, if we have to add more worker nodes, after all, we have to add them to the master node so that master node can manage and watch all these worker nodes. So that is how Kubelet will do. It will register the new worker nodes. So this is actually the responsibility of Kubelet to add or to register the new or the current worker nodes with the Kubernetes master node, such as with the API server, and it allows the node to join the cluster. If we have to add more new nodes, we have to register them, and Kubelet will register, and those new worker nodes would be added to the cluster, and then our master nodes will definitely watch and manage all these newly added worker nodes. And Kubelet works with the container runtime, which could be Docker and container for spinning up, for deploying new containers inside the pods. And this is actually the core component of a worker node. Now it is important to understand that how Kubelet works. First of all, Kubelet receives a pod spec from the Kubernetes API server, and what is in that request? This pod spec request contains the information about the containers that should run on that node. And after that, Kubelet will ensure that these containers are running and they are in the healthiest state by monitoring their status, and then Kubelet will respond appropriately to any issues that arise. So it means that pod spec request will come from the master node. After all, master node is the big guy. It has to watch all the worker nodes, and from that API server, that request is forwarded to the Kubelet service, and Kubelet will ensure that every container, every pod is running and in the healthiest state. Kubelet also interacts with the container runtime at the same time with Docker or container, which is responsible for starting and stopping containers. That container runtime actually starts and stops the containers inside the pods. Kubelet communicates with the master node and the container runtime at the same time. So as I told you that Kubelet is more responsible, and it is the most responsible agent on the worker nodes. It has to communicate with the master node, with the API server. It has to monitor the containers running inside the pods, and it has to monitor the communication happening between the master node and the worker nodes. And it also communicates with the container runtime like Docker or container at the same time. Everything is happening, and it is all possible with the Kubelet that we have on the worker nodes. It should be configured, it should be installed on each and every worker node. So number 2 is Kube-Proxy. Now you must be thinking that we have 12 worker nodes, and how all these worker nodes talk to each other, and how these worker nodes handle traffic that comes from the external resources. And this is actually the Kube-Proxy, also the network proxy on each worker node. And the Kube-Proxy is a Kubernetes component, worker node component by the way, which manages traffic routing for services within a cluster. And Kube-Proxy routes traffic between nodes in a cluster. Okay, every communication, every traffic routed among the nodes in a cluster, Kube-Proxy is responsible for that. It is the network proxy. And Kube-Proxy acts as a load balancer as well for services with multiple pods. If we have one or more pods, it will act as the load balancer on that worker node as well. It distributes incoming traffic among the pods to ensure balanced workloads and efficient resource utilization. All the traffic that is coming from the external resources is not directed to a single worker node or to a single pod. That is actually the responsibility of Kube-Proxy, to balance the traffic, to distribute the traffic to all the worker nodes, to all the pods on these worker nodes. How beautiful is that? And now you must be surprised that Kube-Proxy works just like IP tables. We have used IP tables as a system administrator to route traffic on our Linux systems, right? So Kube-Proxy actually uses IP tables, and this is the default backend of Kube-Proxy. So you can say that at the backend, IP tables is used, and that IP tables is used to route the traffic and it distributes the traffic among the worker nodes, among the pods on those worker nodes. So this is actually the network proxy, and it is responsible for communication in among the worker nodes, and also it handles the traffic coming from the external resources. And we have to know that how Kube-Proxy works. It watches the Kube-API server for changes to the services and pods. Now guys, the conclusion is, let me tell you honestly that Kube-API server is the most responsible component of a Kubernetes cluster. Now it is obvious every component, whether it is from the master node or from the worker node, has to forward its request to the Kube-API server. And Kube-API server is the brain, and it will process each and every request if it is valid, of course. So if there is any change happening with the service or the pod from the Kube-API server, Kube-Proxy will watch, it will monitor this change, and it subscribes to the updates to the etcd, which stores IP addresses collected by the endpoint controller when a service is created. And it also updates the IP table rules on each node to allow access to the new service. And it also configures the node to capture traffic to the service cluster IP and port, and it redirects all the traffic to one of the service endpoints. That's how Kube-Proxy works. If there is any change happening with any service, with any pod, Kube-Proxy watches, manages that change, and it updates the IP address in the etcd etcd database, and it also updates the IP table rules so that pod or that service is accessible. It also configures the node to capture traffic to the cluster's IP address, and it redirects that traffic to one of the service accounts endpoints. So this is actually the core responsibility of the Kube-Proxy component, which is also known as the network proxy. And also one thing that we must know, that our IP table rules, our IP addresses, cluster IP address, or the worker nodes IP addresses, all of these are stored inside the etcd database. So etcd, since it is the database of the cluster, so every network related information is also stored on it, on the etcd database of the Kubernetes cluster. Alright guys, the last and number third component of a Kubernetes cluster's worker node is container runtime, the containered guy. And why do I have used containered as the container runtime? Because now containered is preferred over Docker. It is the most used container runtime in the Kubernetes clusters these days, and containered is used as the default container runtime. It is now the default container runtime to spin up containers in a pod in the latest versions of Kubernetes. And containered is an industry standard core container runtime, and it is designed to be lightweight and focused on container execution, image distribution, and storage. So instead of using Docker, now the latest versions of Kubernetes now use containered as the container runtime to run containers in the pods. So now we must know that what is the chemistry between the containered and Kubelet, how they work together. And I have tried to explain it here. So first of all, we must know that we have to create a new container. So the master node notifies the Kubelet service to create a new container. This is the request, okay, from the master node to the worker node via Kubelet service. And what is the goal? To create a new container. Number two, how Kubelet will use. The kubelet will uses the container runtime interface CRI to interact with the container runtime, to interact with containered and create the container. So it means that kubelet is the man in the middle. It communicates with the master node. Master node asks kubelet to create a new container. Kubelet communicates with the container runtime on the worker node, and it helps container runtime to so that we have a new container. The container runtime, like Docker or the container, pulls the latest image from the container registry and extracts it and saves it to the disk of the worker node. And after that, the container runtime is notified and goes to the disk to get the container image, and that container runtime executes a series of commands to create a container. So that's how, guys, kubelet communicates with container, and that's how we run a new container in each pod on the worker node. So this is just like normally we pull a Docker image using the Docker pull command, and that image is actually stored on the Docker Hub registry. So similarly, that situation is just similar, and container pulls the image from the registry and it runs a series of commands to run a container. So containered is the container runtime, and it communicates with the kubelet to spin up new containers. Alright guys, now let's wind up this lecture, and I am saying it again that we have a master node and we have a worker node in a Kubernetes cluster, and in total there are 4 components on the master node: Kube-API server, Kube-Scheduler, Kube-Controller-Manager, and etcd. And on the worker node we have Kubelet, we have Kube-Proxy, and we have container runtime as the container. So that's it guys for today's lecture. This was a much needed deep dive of each component of the cluster. Now we know that each Kubernetes master node and worker node has these components, and we will have more knowledge and we will have more functionality when we are going to practically see their functions, their manifest on our Kubernetes cluster. So I'm sorry that if it was a little boring lecture, but we have to clarify these concepts of the components of a Kubernetes cluster. So I hope that this deep dive will definitely benefit you, and it will help you to build your Kubernetes clusters concepts. Make sure that you subscribe DevOps Molvi. We are going to talk about the Kubernetes terminology in our next lecture, like what is a pod, what is a config map, what is a replica set, what is a daemon set, what is a deployment. So these Kubernetes terminologies are coming in our next lecture. As promised, I will try my best to not leave any Kubernetes concept behind. So I'm trying my best to make it the best free Kubernetes course on YouTube. So make sure that you subscribe DevOps Molvi and follow me on TikTok and Instagram as well. I will watch you in the next video. Have a good one. Bye. Hey guys, I hope you're doing great today. In today's lecture, we are going to discuss about the Kubernetes terminology. And guys, I have shortlisted around 17 important and most frequently used Kubernetes terms that we must know as a DevOps engineer. So that would be our 5th Kubernetes lecture in our Kubernetes course series. First, we discussed about what is Kubernetes, how Kubernetes works, what is the architecture of Kubernetes, and in the last lecture, we had a deep dive of a Kubernetes cluster in which we discussed and we learned each and every component of Kubernetes in master node and in worker nodes as well. So if I quickly repeat, we discussed the components of master node like Kube-API server, Kube-Scheduler, Kube-Controller-Manager, and etcd. Also, we discussed the core components of a worker node like Kubelet, Kube-Proxy, and container runtime interface like Container or Docker. So there would be a lot of Kubernetes terms that would be used in our upcoming lectures, like what is a daemon set, what is a replica set, what is a stateful set, what is a config map, what is RBAC, rollback access, what is a deployment, what is a NodePort. So these are actually the most important Kubernetes terminologies, or we can say Kubernetes terms that we must know as a DevOps engineer. And that would be our last theoretical lecture, I would say. And then we are going to proceed with our practical sessions and practical labs, in which we are going to install Minikube and Kubernetes cluster as well. And we will see each and everything in practical, how practically each component of the Kubernetes cluster works. So make sure that you subscribe DevOps Molvi on YouTube. Let's get started with Kubernetes terminology, Kubernetes terms we must know as a DevOps engineer. So that is one of my favorite illustration, you can say, how we can quickly learn by watching this picture that this is the most superior deployment into replica set, and pod contains a container. So that is actually a funny thing, but literally it is the core concept. So that's why in this lecture we are going to discuss each term, like what is deployment, what is a replica set, what is a pod, what is a container. After all, we know container while we had a complete Docker course. So rest of the Kubernetes terminologies we must know. So let's begin with our first Kubernetes term, which is pretty easy and really simple. What is a Kubernetes cluster? Which is number one Kubernetes terminology in today's lecture. Kubernetes cluster is a set of nodes managed by Kubernetes. That can be one master node and one worker node, which would be the simplest Kubernetes cluster, or 3 master nodes and 12 worker nodes, which would be the best cluster for high availability and scalability of our applications. A cluster consists of master and worker nodes. A node is like a Linux machine. A node can be a virtual machine on your cloud provider, on AWS or Google Cloud Platform. So the set of nodes form a Kubernetes cluster. It is simple and really basic, we know that. And number two, node. A node in Kubernetes is a physical or virtual machine that provides the computing power to run workloads. A node is a virtual machine, a physical server with Linux running on it. It is a node. If a node fails, it's automatically removed from the cluster and other nodes take over. That is when we have multiple master nodes and multiple worker nodes. That's what I have told you, that in a highly available cluster, we must have more than one master node and we must have more than one worker node. So in case of any failure, the rest of the nodes take responsibility and our applications must not go down at any cost. So a node is a physical Linux server, or it can be a Linux virtual machine. Number three, what is a pod? And the pod is the smallest unit of execution in the Kubernetes system. Okay, and it is made up of one or more containers. We have pods running on the master node, and we definitely have pods running on the worker nodes. And it is the smallest part, you can say, or unit of a Kubernetes cluster which contains containers. So a pod can have one container or multiple containers running in it, and a pod is the collection of containers that work together to serve a common purpose. What is that common purpose? It is to host, it is to run our applications in containers. Our applications are containerized and those applications run inside a pod, and pod consists of one or more containers, and it is actually the smallest unit of a Kubernetes cluster. We have pods on all the worker nodes, and those pods are actually managed by the Kubernetes master node API server, and Kube-Scheduler is used to schedule new pods. So pod is actually, you can say, it is the smallest unit of a Kubernetes cluster which contains containers. Alright, so number 4 is namespace. Just like you remember, we have discussed workspace in Terraform, okay? While we use workspace to isolate our environments. Our dev environment is isolated with staging, with prod. Each environment is isolated. And when our environments are isolated, dev cannot sneak into prod. Prod cannot sneak into staging. They don't interfere with each other. That's what isolation means. And similarly, just like we discussed workspace in Terraform, we have namespace in Kubernetes. And Kubernetes namespace is an isolated environment in a cluster. The resources belonging to different namespaces cannot directly interact with one another. So we will have different namespaces. So for instance, if I want to host my applications using Kubernetes, I can create a separate namespace for my website data. I can create a separate namespace for all the secrets and sensitive information in the vault namespace. Similarly, I can have a different namespace for the deployment. So that's how namespaces work. Namespaces isolate the resources, and the resources cannot directly interact with each other. So if I want to make it more simple for you guys, for instance, if I have two namespaces, namespace A and namespace B. So when I create pods or resources in namespace A, these resources or these pods cannot be accessed by the namespace B. If I am using namespace B, I would not be able to see the pods, the resources of namespace A. And similarly, I cannot see the resources, the pods of namespace B in namespace A. So namespace B will have its own pods, it will have its own deployment, it will have its own service or ingress. So that's how we use namespaces to isolate the resources. I hope that now this concept is clear. Number 5, deployment. What is a deployment? A deployment manages a set of pods to run an application workload. The deployment is a way to automate the process of creating and managing multiple replicas of the application, making it easier to manage, update, and scale our application without worrying about the underlying infrastructure. So guys, in simple words, a Kubernetes deployment is the blueprint for running our applications on Kubernetes. So deployment is responsible for our application's deployment, how our applications should be deployed, what should be the replicas or the copies of our application to make it highly available. And not only that, a deployment actually manages all the set of pods, and we can also roll out our changes using the deployment. And one more thing that we must know, that deployment is used to create and manage multiple replicas of the application. Now, if we have multiple replicas or multiple copies of the application, if one copy fails, the deployment will replace it with a new one, which is healthy and running, so that our application runs all the time. So that is how a deployment is used in Kubernetes. In short, it is actually the blueprint of all our applications that run on Kubernetes. These are actually the additional benefits of a deployment. It also manages, updates, and scale our applications without worrying about the underlying infrastructure. And number 6 is service. A service groups pods and exposes them for external traffic as a single entity. In Kubernetes, services are commonly used to expose pods to external or internal traffic. That is actually the definition, the proper definition of a service. But in order to understand a service in Kubernetes, I am the user and my application run on the pods. Okay, now the bridge between me and the pods is actually service. A service lets users to interact with the applications that run on pod, and that's why, guys, I have shared the simplest code of a service. That's how a service looks like. Like you can see, the kind is service and the metadata, and it is my node application, you can see, and it runs on port 80. So a service will help me to access, to reach out my application, node application, which is running on the pods in my Kubernetes cluster. So we can say that service is a bridge, and it helps users to interact with the applications that are running on the pods. So that is why a service is a common way to expose pods to external or internal traffic. So that's how a service is used in Kubernetes. And number 7 is replica set. A replica set is a group of identical pods, the same pods running for a specific workload is a replica set. A replica set's purpose is to keep a specified number of identical pods running at all times. This helps to ensure that an application is available and reliable even if some parts of it fail. Now, this is actually how a replica set's code looks like in Kubernetes. You can see we have a deployment. This is a kind in which we have the applications replicas as 3. So there would be actually 3 copies of this application, and this will make our application more highly available and scalable. So if any of the replica fails, there would be another one, and our applications will never go down. So that is actually the purpose of creating replica sets. So let me share a really common example of photocopying a document. I have one original document, and I will go to a shop and ask him that, please, I want to have 2 more copies of this document. So in total, I will have 3 copies of that document that are almost the same, that look like the same. That is actually what a replica set does. So we will have the 3 copies of all pods that are running the same workload. So from this replica set, I can say that there would be 3 pods that would be running all the time. So that is why we use replica set, and I will have 3 copies of my pods that will run every time, and my application will be accessible without any interruption. So that is actually the most basic code of how a replica sets look like in Kubernetes. Now, what is a config map? A config map is a type of native API object designed to store environment-specific configuration data and share it with pods. A config map is a Kubernetes object used to store non-confidential data in key value pairs. Config maps can be created using kubectl commands or the YAML files. Also, I have given this example of config map in which I have this metadata, and there are 2 values like key 1 and its value is value 1, and key 2 its value is value 2. That's how we can store non-confidential data of pods using the config maps. And it is up to you if you want to use config maps in your configuration, and it will just name the pods and their characteristics or their detailed information. And number 9, Ingress. Ingress means how external users access the application or services. In order to understand Ingress on Kubernetes, you can relate it with as our web proxy. After all, our applications run in containers on the Kubernetes cluster. But how I can access those applications in my web browser? Like if I want to have a blog on my Kubernetes cluster and it runs on DevOpsMolvi.com, I want to type DevOpsMolvi.com, how it can be accessed. And that's where we use Ingress. Ingress actually, it is the mechanism used to present services and applications externally from within a cluster. So external users will access the applications that run on the pods using Ingress. So I will definitely use kind as Ingress. Now this is the metadata. This is my blog, DevOps Molvi blog. This is just a label, and the specification is that I'm using Nginx as my Ingress controller, and this would be my website name, devopsmolvi.com. So if I have a website, a blog that is running on my Kubernetes cluster, it can be accessed publicly on the web browser using the Ingress controller. So Ingress can use Nginx or Traffic as well. Number 10, daemon set. So guys, you must be worried about the differences between a replica set, a daemon set, or a stateful set. And they have differences. Replica set ensures that identical number of pods run on each worker node. A daemon set ensures that at least one pod should run on each worker node. So that is how we can use daemon set, which ensures that all or same nodes run a copy of a pod. So if I have a dozen of worker nodes, daemon set will ensure that at least one copy of pod should run on each worker node. As nodes are added to the cluster, pods are added to them. And this is obvious that we know that when nodes are added to the cluster, we will definitely have pods on each node. And daemon set is a Kubernetes feature that lets you run a Kubernetes pod on all these cluster nodes, which meet the certain criteria. Every time a new node is added to a cluster, the pod is added to it. And that's what daemon set does. Daemon set has the responsibility to run a pod on each node. And when a node is removed from the cluster, the pod is removed from that node. And when a daemon set is deleted, Kubernetes removes all the pods created by it. So these are actually interchangeable terms. Replica set ensures that same number of pods run on each worker node. Daemon set ensures that at least one copy of a pod should run on each worker node. And after that, we will have a stateful set as well that I'm going to discuss in the next slide. And this is number 11, NodePort. A NodePort is a Kubernetes service which allows external clients to access applications by opening a port on every node in a cluster. This service opens a port on every node in a cluster and forwards traffic to the service. So NodePort is actually a Kubernetes service. It is a service so that our external clients can access our applications. And the port range of NodePort is from 30,000 to 32,767, but it is also customizable. In short, NodePorts are a basic way to expose services to external traffic. And number 12, which is easy, a secret. A secret is just like the sensitive information. It is simple, and you all know that a secret can be a username, password, or token, or SSH key. Just like we have secrets in other DevOps tools, a secret in Kubernetes can be your password, your SSH key, or your token. And number 13, and the most important one, RBAC, which stands for Role-Based Access Control. RBAC. And it is a security feature in Kubernetes which controls access to resources based on the roles of users and service accounts. Just like we have IAM, Identity and Access Management, on AWS or on Google Cloud Platform to use to grant permissions, certain permissions to the users, to the service accounts. RBAC, role-based access, does the same job. It actually defines permissions that are specified, which user must have what kind of permission and which service account should have that permission. It is all decided by RBAC, role-based access control, and we can grant permissions such as to create, update, and delete resources. And RBAC helps secure our environment and reduce the risk of unauthorized access. So it is just like we have identity and access management, in which we grant the read-only access or permissions to the users. If you have gone through the IAM lectures on Google Cloud Platform, you must have a better idea how permissions work on Google Cloud Platform. Similarly, we have RBAC on Kubernetes, which is used to grant permissions to the users and service accounts so that they can create, update, or delete the resources on worker nodes, or they can deploy workloads on the worker nodes. Number 14, annotation. Annotation is just like a label. It is an advanced type of a label. A label is just like we name certain resources. Okay, so you don't have to worry about annotation. You can say that it is an advanced version of labeling. And since we know that a label attaches metadata to the Kubernetes object, each object will definitely have a label. Annotations simply considered as the advanced form of labels with more features, with more characteristic. Annotations can contain more characters than labels. That is actually the difference. Annotations will have more features. It will have more characteristics as compared to the labels, and can be structured or unstructured. So that is actually known as annotation. Number 15, cluster IP. So guys, in Kubernetes, a cluster IP is a fixed internal IP address of the Kubernetes cluster. A cluster IP is an internal IP address of the Kubernetes cluster, and it is used to facilitate communication within the Kubernetes cluster. And for internal communication of the pods or the replica set, it is actually the cluster IP which assigns internal IP addresses to all those pods or replica sets. It also defines one or more ports to listen on, and it uses a target port to forward TCP and UDP traffic to the containers. Now, this is my cluster IP and this is my port. So every traffic coming on this IP address and this port will be routed to the pods running on that cluster. So that's what a cluster IP is used. It is for, you can say that cluster IP is used for the internal communication of the pods or replica sets within a Kubernetes cluster. And number 16, and an easy one, which we all know, a load balancer. A load balancer is also used in Kubernetes to distribute traffic equally to all the worker nodes. Just like we know that a load balancer equally distributes the traffic, but how a load balancer works in Kubernetes, it distributes the request, the traffic coming from the external resources to the multiple worker nodes within a Kubernetes cluster. So that's how a load balancer is used in Kubernetes. And guys, the last one is stateful set. We know the replica set, which is a set of identical pods. We know daemon set. A daemon set ensures that one copy of the pod should run on each worker node. Now, what is a stateful set? It is one of the most important interview questions regarding Kubernetes. Differentiate a replica set, daemon set, and a stateful set. So now the most important one is stateful set. A stateful set is a set of pods with a unique, persistent host name and ID. Stateful sets are designed to run stateful applications in Kubernetes with dedicated persistent storage. And when pods run as a part of a stateful set, Kubernetes keeps state data in the persistent storage volumes of the stateful set, even if the pods goes down. So we can say that a stateful set is the most organized form of pods. Each pod will have a fixed name. The pods will run in a specific order. I'm telling you the features of a stateful set, where each pod will have a fixed name. All the pods in a stateful set will run according to a specific order or in a specific manner. In a stateful set, pod A cannot replace pod B or vice versa. And the last feature of a stateful set is that each pod will have a persistent data volume, persistent storage, and each pod's data will be stored in that storage. So that is why I have also mentioned here that if any pod goes down, its data will be saved in the persistent storage volume. So guys, let's revise each and every term quickly. A cluster is a set of nodes. Node is a Linux server or a virtual machine. A pod, it is a collection of containers. One pod can have one or more containers. A namespace, the isolated workspace for resources. A deployment, it is used to create and modify pods in a Kubernetes cluster. And a service, in a service, multiple pods act as a single resource. What is a replica set? The stable set of pods. Identical set of pods is a replica set. One replica set can have 3 pods. If I'm defining replicas as 3, so it means that there would be 3 identical pods. A daemon set ensures there is a copy of pod on each node, runs copy of pods on each node. A stateful set manages a group of pods. The pods are more organized, they have fixed names, they have storage, they run in a specific order. A config map is a non-sensitive data metadata of the pods. Ingress is external access to the services. A secret can be a password or a token. A NodePort is also a Kubernetes service which is used to allow external accessibility of your applications. Role-based access control is just like identity and access management so that users and services can be granted specific permissions. Annotation to label the objects, more advanced form of labeling. A cluster IP is a cluster's internal IP address for internal communication between the pods and replicas, etc. And lastly, we have load balancer, which is used to distribute the traffic among the worker nodes. So that's it guys for today's lecture. Make sure that you subscribe DevOps Molvi. We have discussed each and every important Kubernetes terminology, and now we are going to see every terminology in action in our practical sessions. We are going to learn a lot in our practical labs, and therefore we have covered a lot of theoretical stuff. Now we should learn Kubernetes, all components and terminologies in practical. Make sure that you subscribe DevOps Molvi. I will watch you in our next lecture of our Kubernetes course. Have a good one and bye. Hey guys, I hope you're doing great today, and I would like to welcome you on my free Kubernetes course for beginners. Guys, you must be thinking that if I want to learn about Kubernetes, I want to practically perform Kubernetes cluster commands, and I want to see how Kubernetes works, do I have to have master node and couple of worker nodes and that kind of infrastructure? The answer is no. You can have even your local virtual machine to have a Kubernetes cluster which is fully functional. You can run all the Kubernetes commands, kube control commands on that Kubernetes cluster, and it is known as Minikube, the small Kubernetes cluster that can be installed on your virtual machine. If you have a virtual machine, you can install Minikube, and honestly guys, it is pretty simple and straightforward. Just like you install Docker, there are a couple of commands that we have to execute, and you can see I have this GitHub repository with Kubernetes, and I would be uploading every command, every tutorial regarding Kubernetes that we cover practically on my YouTube session, and you will have this tutorial on GitHub. I will definitely share the repository link in the description, so make sure that you check out the description of each video, because I used to share the links, the important links to the repositories or my Google Slides in the description of each video. So before we start installing Minikube, make sure that you subscribe DevOps Molvi. Let's get started and see how we can have a fully functional mini Kubernetes cluster, which is known as Minikube, on our virtual machine. And by the way, guys, if you want to know about Minikube, I have also explained what is Minikube here in simple words. Minikube is a tool that allows you to run Kubernetes clusters locally. So if you have a virtual machine on your VMware or VirtualBox or Hyper-V, so you can have Minikube installed on that VM, and you can learn all kube control commands that actually are used in production environments as well. So we are going to learn Kubernetes kube control commands in our next lecture, but you can execute all those commands if you have a Minikube cluster on your local machine. That's how simple it is. So you don't have to worry about I should have a master node, I should have at least 2 worker nodes. No, you can have Minikube on your virtual machine and you can learn almost everything about a Kubernetes cluster. But there is one thing that you must know. In Minikube, when we install Minikube on a virtual machine, that virtual machine becomes the master node as well as the worker node. So you must know that a Minikube is installed on a virtual machine. Now, which one is my master node and which one is my worker node? So surprisingly, that virtual machine where our Minikube is installed is also treated as a master node or the control plane. We have all the components of a master node, and we can deploy our workloads, pods, deployment services like we do on worker nodes. So that virtual machine is treated both as the control plane as well as the worker node. So you may be asked about this Minikube, that what is Minikube and is it master node only, or it behaves or it works as a worker node as well? So the answer is it is control plane or the master node. At the same time, it acts as the worker node. So that's what you must know about Minikube. We can install Minikube on our local virtual machine, or if you have a virtual machine on AWS, Azure, or Google Cloud Platform. And before proceeding, we used to make sure that Docker is installed on the virtual machine. You can watch the following tutorial how to install Docker. So guys, I have already shared this tutorial on my channel to install Docker on Ubuntu. So I have also shared the link. You can, if you know how to install it, then you can skip it. But if you want to know how we can install Docker on Ubuntu, I have also shared the URL. And by the way, we are going to install Docker, and I have this on my GitHub repository, a small short guide how we can install Docker. So without any further ado, let's start. I have this virtual machine on my AWS platform. Okay, on my AWS, I have created a Minikube virtual machine, and I will install the Minikube on this brand new virtual machine. It does not have anything priorly installed on it, and I will run. This is my first command. I will install. And by the way, guys, I'm working as root. So if you are not working as root, you have to use sudo. So after that, I will download the tools and dependencies for Docker. And now, yes, why do we need Docker in Kubernetes? You know that Docker is used as the container runtime interface. Okay, to run our containerized application, we can use Docker, we can use Containerd, we can use Podman. So I have chosen Docker because it is more simple with Minikube. So after that, I have to add the Docker's GPG key, and it should not take much time, and I will add the official Docker repository so that we have the latest version of Docker on our Ubuntu. By the way, guys, another thing, that my virtual machine is Ubuntu 24.04, so it works on both, and this tutorial is related to 22.04, but it works on 24.04 as well. And after that, I will update my repositories, and I will install Docker. CE means Community Edition, and it should not take that much time. And after that, once our Docker is installed, we will proceed to install Minikube. And now there are actually only 3 commands that are used to install Minikube. Now you can see we need to install Minikube, so we need to run the following command. The first command will download the release of Minikube. So it will get, we are using curl to get the release of Minikube, and after that we will install it on Ubuntu with these commands, and our Minikube version would be able to tell us that Minikube has been installed with that version. So after that, I will copy this first command. I hope that Docker has been installed. Now I can run all Docker commands. Docker is installed. Now guys, I will install Minikube. So make sure that you follow this guide that I will share in the description to install Minikube. This is the first command to get the release of Minikube so that we can install it. And okay, it has been downloaded. Now I will install with sudo, or you can use without sudo if you are on root. So this command would be going to install Minikube for us, and it is installed. After that, I can run Minikube version, and you would be able to see that Minikube has been installed. Okay, and this is the version of our Minikube Kubernetes cluster. That's how simple it is. So there are no rocket sciences here, and you can simply straightforwardly run these commands on your Ubuntu machine, and Minikube would be installed. Now I have to start Minikube with the Docker driver, because Docker would be used as the container runtime. The containers will run inside with the help of Docker, right? So we have to, this is just like we are going to integrate Minikube with Docker, and I will run this command. So Docker would be our driver for our Kubernetes cluster, and you might face this error. The Docker driver should not be used with the root privileges. If you wish to continue as root, use the -- or -- force. So I will use this same command, or I will copy this command. So we are going to forcefully use the Docker driver with our Minikube. I will rerun this command using force. So I'm forcing Minikube to use this driver, to use Docker driver, whether I am as root or any other user. Now it will take a couple of moments, and our Minikube cluster would be ready. So now you can see that downloading Kubernetes version. So this Kubernetes cluster version would be downloaded, and it will take a couple of moments to install. And if you are running Minikube within a VM, consider using driver is equal to none, but we are going to use driver as Docker, and also using the Docker driver based on our configuration. So we are going to use the Docker driver, and because it is recommended, and creating Docker container. So these containers will have our all Kubernetes masternode core components. Now you are going to see it when I will run kube control commands. You will see how we can have all the components of the masternode on this virtual machine. Okay, and now you can see that this is our Docker version, and we have this Kubernetes version, generating certificates and keys, and configuring rollback access control rules. And our Kubernetes cluster has been installed. Kube-Control is now configured to use Minikube. But to run all these commands, now we have to install Kube-Control, because you can see that Kube-Control not found. It is showing that Kube-Control is not here, because Kube-Control commands are used to interact with a Kubernetes cluster. We are going to learn a lot about Kube-Control, Kube-Cuttle. It is also known as Kube-Cuttle. So Kube-Control must be there, must be installed, and with the help of Kube-Control, we are going to get about our cluster deployment, services, pods, replica sets, Ingress, everything. After that, guys, I can check the Minikube status, since Minikube is installed, and I can see that Minikube has the control plane as type, and it is running host, Kubelet, API server, kube config, everything is running. So this status, it means that our Kubernetes cluster is ready, Minikube is ready. Now we have to install Kube-Control, Kube-Cuttle. The Kube-Control is a Kubernetes CLI, okay? Just like we have G-Cloud, we have AWS CLI, we have Azure CLI. So we have Kubernetes CLI, and it is known as Kube-Control. And it is used to interact with Kubernetes clusters. We will use it to work with our Minikube cluster. The installation of Kube-Control is also simple, and we need to execute the following commands. And I have shared all these commands. So I will run this, and we will have Kube-Control on our virtual machine. So I will add the GPG key, and after that I will get the release of Kube-Control from Kubernetes official repository, and after it I will just run this command, and we will have Kube-Control on our virtual machine. Now you can see it is downloading, and okay, Kube-Control is installed, and this is the version, and I can confirm the client version of Kube-Control. Okay, and okay, it has been installed. This is the client version, this is the customized version. So I should be able to install, now I should be able to run each and every Kube-Control command. So Kube-Control, which is a Kubernetes CLI, has been installed, and you can see Kube-Control, kubectl, controls the Kubernetes Cluster-Manager, and you can have everything, you can have the idea of all these Kube-Control basic commands here, like what is the purpose of Kube-Control create. Kube-Control create creates a resource from a file, that would be a YAML file. Similarly, expose, run, and set. So I have shared a couple of Kube-Control commands. By the way, in our next lecture, I have already prepared 50 Kube-Control commands that we must know as a DevOps engineer. All these are basic and fantastic commands, and literally so simple that we can learn them in a single day. So I'm sharing a couple of these Kube-Control commands here in this repository as well, like Kube-Control cluster info. I want to see the details and overview of the cluster. It will share the cluster information. Kube-Control cluster -info. Now you can see we have Kube-Control. Kubernetes control plane is running on this URL, and we have core DNS, which is just like Kubernetes own DNS server. So it is running on this URL. So it means that our Kubernetes cluster is running fine. And similarly, we have this Kube-Control config view. I will run it, and it will share more details about our cluster. This is cluster minikube extensions and the provider, and also the namespace which is default, and we have the kind as config. So that's how we can run kube control commands. And for instance, if I want to see the nodes, it will show us only one node because we have this as the master node, and you can see that this is our node which is control plane. So this virtual machine is acting as the control plane or the master node. So that's how we can run kube control get nodes, and similarly we can have kube control get pods, and there are no resources found in default namespace. But if I run kube control get pods minus minus or hyphen hyphen all namespaces, then it will show us all these parts of this minikube cluster, and most of these parts belong to the control plane components like etcd, Kube-API server, Kube-Controller-Manager, Kube-Scheduler, and these pods are running on this. So these are actually the core components of a master node. So all these components are running as pods on this virtual machine, and it has created a minikube cluster. I hope that you understand how minikube works at the backend. It has actually pods, and in those pods our control plane components run. Now if I want to see the namespaces, so I can have kube control get namespaces, and it will share all the namespaces of the minikube cluster, which is we have this default. We can create our own namespaces as well. So these are actually the namespaces of the minikube cluster. So guys, this is actually a fully functional Kubernetes cluster. We will have the same when we have the master node and a couple of worker nodes. That's how the same thing we can replicate using our minikube cluster. And now for instance, if I want to deploy a local application, and for instance I want to deploy Nginx server locally on my minikube Kubernetes cluster, I will have to create a deployment first, and then after that I will create a service and expose it. So in order to create a deployment, I have shared this command. Now you can see kube control create deployment, the name of the deployment, and that image. So this image is actually the Docker image, and I will use the default namespace. I'm not changing the namespace. We can do it and we can have our own namespace, but now for this lecture I'm using the default namespace, and it will create the deployment in the default namespace. Now you can see the deployment has been created. I can run kube control get deployment, okay, and it is ready and up to date and available. So after that I will expose this deployment using the kube control expose command. This is how we can create a service. And now guys, you can see I'm going to expose my application, my web server, to the external users. So I have to create a service. A service exposes our application for the external users, and there are actually 4 types. You can see the type is equal to load balancer. I will definitely have a full lecture on it because we have to discuss all the types of services in Kubernetes, like load balancer, NodePort, external name, ClusterIP. So these are actually the 4 types of services in Kubernetes. So a service is used to expose our application for the external users or for the external applications. I will use this command, and I will use this port 80, and type is equal to load balancer to create a load balancer service. And now you can see that the service has been exposed. So I can run kube control get services, and it will show us that I have actually 2 services. Just like I told you, ClusterIP, the internal IP address of the Kubernetes cluster, and we have this load balancer service DevOps web, which I have used to expose our Nginx deployment. Now I can check minikube IP, and this is actually the IP address, and I can run curl http this IP address and the port. I will use this port, and it will show us that our Nginx is running locally on that port. So that is how we can expose our application. So let me repeat it again. I will run minikube IP, and this is my internal IP address of the Kubernetes cluster, and I will get kube control get services, and this is actually the port where our Nginx is running. So I can use curl command to see if because since it is locally and I'm running my web server locally, it is not for external users at the moment. It is not externally exposed. I have to use NodePort to expose it externally, and I will run http and the cluster IP address and the port where our Nginx server is running, and you can see Nginx web server is running. So guys, I hope that you don't have a fear that Kubernetes is really tough. No, you can, or I can, learn Kubernetes real quick with the help of Minikube. And in the next chapter, we are going to learn top 50 kube control commands like kube control, get, config maps, services, deployments, pods, namespaces. And if I have mastered all these kube control command, it would definitely be no issue for me to manage or to work with a production Kubernetes cluster. So I would say that Minikube is a fantastic Kubernetes cluster, and I would say that it is the quickest and the most easiest way to learn Kubernetes. So if I repeat it quickly, we need to have Docker installed on our virtual machine, and using Ubuntu, I can run 3 or 4 commands, and you saw that Minikube has been installed using those commands that I have already shared on my Kubernetes repository, and you can go through this guide and you can have Minikube installed on your virtual machine. I hope that this video was really simple and it was quick for you. In the next video, we are going to learn 50 kube control commands. So stay tuned. We are going to learn each and everything about Kubernetes in this series. Have a good one and bye. Hey guys, I hope you're doing great today. Today we are going to learn 50 important kubectl commands. Guys, you know that kubectl is actually Kubernetes CLI. Just like I told you in the previous chapter that every tool has a CLI, just like we have G Cloud on Google Cloud Platform, AWS CLI on AWS, Azure CLI for Azure. So similarly, we have a Kubernetes CLI which is known as kubectl. Kubectl is used to manage, kubectl commands are actually used to manage the whole cluster. We can run kubectl commands to create services, deployments, pods, Rollbacks, and so on. So we must know kubectl command as a DevOps engineer, because we have to manage, we have to watch out our Kubernetes clusters. So in the previous video, you saw that I have installed Minikube. Okay, so Minikube is the simplest installation of Kubernetes on your VM, on our virtual machine. In Linux machine, we can install Minikube, and we can practice almost every kube control Kubernetes CLI commands, kubectl commands. So in today's lecture, we are going to learn kubectl 50 most used kubectl commands. So let's get started, and make sure that you subscribe DevOps Molvi. I really appreciate your support. So let's get started with our first kubectl command. So guys, you can see that I have already installed kubectl on my Linux machine and I have Minikube running on it. I can run Minikube status and it will show us that Minikube is running on this virtual machine. So first of all, our first command would be kubectl, kubectl. It is also known as kubectl or kubecontrol. Whatever you like or whatever you are easy with, you can name it. So I used to call as kubecontrol. So kubecontrol help. By the way, first, if I run kubecontrol, it will tell us that we can run these commands, like these are basic commands. For instance, kubectl controls the Kubernetes Cluster-Manager. Just like I told you that it is used to manage and work with Kubernetes cluster. So we must have kubectl installed, and these are actually the commands, like basic commands to create, expose, run, and each command has a simple and basic explanation. For instance, if I talk about kubecontrol create command, it is used to create a resource from a file or from stdn, standard input. And we have expose, run, and set, and we have basic commands, deploy commands, and cluster management commands. So all these commands have a little bit of explanation and what is the purpose of that command. But for instance, if I want to know more details of any kubecontrol command, then I can run, I will clear the screen, kubecontrol help. Okay, and now if I run kubecontrol help, it is showing the same output, but if I run kubecontrol help and more, like create, kubecontrol help and create, now I will get more details of this command. Okay, let me run it. Okay, now you can see that I am getting all the possible options of that kubecontrol create command. Now that is actually beautiful. You can see that we can create a resource from a file or from standard input. We must have a JSON and YAML formats that are accepted, and you can see the examples, like that's how we can use the kubecontrol create command. That's how this is also another example. And now you can see that we have more details of a command. So similarly guys, if I run, for instance, now you can see that there are more options of that command. That are actually more options, and each option has been explained in our Kubernetes CLI. Now, for instance, okay, I will clear it, and now kubecontrol help and expose. So now I want to know more information, more details of kubecontrol expose command, and I will enter. And now you can see that there are a lot of options and a basic syntax how you can use this command and what is the purpose of that command. So guys, if you are worried, if you don't understand any command, just run. That is actually our first command, kubecontrol help. So we can run kubecontrol help set, we can run kubecontrol help create, we can run kubecontrol help and expose, and each command is explained with all the possible information, and you can read out, you can explore more options, and you will have the basic syntax of that command as well. So if you are getting worried about any command, just run kubecontrol help and that command. So I have presented, I have demonstrated 2 examples in front of you. Now you must be easy with kubecontrol help and kubecontrol all other commands. And for instance, if I run if I want to know more about the expose command, you can see it explains that expose a resource as a new Kubernetes service. We are going to use this command to expose a service like ClusterIP, NodePort, LoadBalancer, external name. These are the services in Kubernetes, and more information has been shared, and that's how help command has got our back, and we can have every information, every option of any kubecontrol command. So guys, now the second command is kubecontrol cluster info. Now this command actually shows an overview of our cluster. So you can see that our kubecontrol control plane is running on this URL, and we have core DNS, and our core DNS is running at this URL. So we have the basic, a very general overview, a very general information of our cluster. Now moving to the next command, kubecontrol cluster info. Now I want to know every detail of the cluster first, and this command is, by the way, used for troubleshooting purposes. Cluster info and dump. Now I will run it, and you will be bombarded with the huge and long output. Now you can see this is showing a lot of logs and huge information about our cluster. So I will stop it, and for instance, if there are any issues with our cluster, we can use this command, which is kubecontrol cluster info and dump. So it will share all the possible logs and details of cluster, and this command is really helpful for the troubleshooting of our production Kubernetes cluster. Alright guys, now moving to the next command, kubecontrol get nodes. For instance, if I want to know the information about our nodes, master nodes, okay, so I will run this command, and it is showing only one node, which is our minikube, and it is being worked as the control plane. At the same time, it is our control plane, so that's why it is showing only one node. So if I want to know more information about our nodes, master node or worker nodes, I can run kubecontrol get nodes command. Okay. Similarly, I can run kubecontrol get services, get pods, get namespaces, get deployments, but I am going to share these commands one by one gradually. So guys, if I want to know the information about a specific node, for instance, there are multiple nodes in my Kubernetes cluster. Let's assume there are tens of worker nodes and master nodes in my Kubernetes cluster, and I want to know the information about a specific one node, then I can use this command, kubecontrol describe node and the node name. But for my current scenario, I have only one node, and this is minikube, so I will run this command and I will paste the node name as minikube. But it works like a charm. You just have to replace the name with your node name. Okay, I have this node and I want to know more details of this is my master node, right? So I want to know the details of this node, so I will use kubecontrol describe node and the node name. Okay, so that's how it works, and you can see that I have got all the details of this node, addresses, capacity, and CPU, system information, machine ID, etc, etc. Okay, I will clear the screen. After that, guys, I can run a simple command to know the version of my kubecontrol Kubernetes CLI, and the command is simple: kube control and version. Now you can see I have this client version, customized version, and server version of my current Kubernetes CLI. And now if I want to know the overview of all the resources in my Kubernetes cluster, I can run kubecontrol get all. Okay, and now you can see I have this pod, I have these services, this deployment and replica set. So that is actually an overview of all the resources in my Kubernetes cluster. So we can run kubecontrol get all command to know the information about the resources of our Kubernetes cluster. And after that, I will run kubecontrol options command. Kubecontrol options, and it will share all the possible options of our Kubernetes CLI. The following options can be passed to any command. To any kubecontrol command, we can pass all these options. So if you want to go more deeper and you want to have a deep insight of any kubecontrol command and its options, you can use this kubecontrol option command, and it will share all the possible options that can be used in any kubecontrol command. So there are a lot of options, and I can see like -s for server, TLS server name, token, and so on. And after that, I will run kubecontrol API resources, and it will print out all the supported API resources in our Kubernetes cluster. Now you can see we have these supported API versions and resources that are supported by our Kubernetes cluster. So this is actually important when we are going to upgrade our Kubernetes cluster, when we are going to change some versions. So we must know what are the supported versions in our Kubernetes cluster, what are the supported resources, API resources. And similarly, the other command is kubecontrol API versions, and these commands versions, and these commands are used to get the details about the supported resources and the supported versions. Now you can see these are actually the supported versions in our Kubernetes cluster. So these commands are actually required when we are going to change the version, when we are going to update the version, and these can be critical when we have a Kubernetes cluster in production. You know that changing version or updating any version can be challenging task, can be a huge challenge. So we must know what kind of resources, what kind of API versions are supported, so we can run kubecontrol API resources or API versions, and it will share all the supported API resources and versions in our Kubernetes cluster. Alright guys, now an easy command and most frequently used command is kubecontrol get namespaces. So what are the namespaces that our Kubernetes cluster? There can be more namespaces, but these are actually the current namespaces in my Kubernetes cluster. So I can run kubecontrol get namespaces to get the list of the namespaces. And now if I want to create a new namespace, kubecontrol create namespace and the name of the namespace, like for instance DevOps Molvi. So it will create a separate room for me, an isolated space for me. And now I run kubecontrol get namespaces, and I must have the DevOps Molvi namespace that has been created 13 seconds ago. So that's how we can create namespaces using the kubecontrol create namespace command. And by the way guys, default namespace is set as the default. Okay, for instance, if I run kubecontrol get pods, so you can see there is one pod running in my default namespace. So similarly, if I want to know the resources of any other namespace, I have to use the namespace as -n and the name of the namespace. Now there are no resources found in the DevOps Molvi namespace, or I can use -n default and it will show the resources in that namespace. So that's how we can use the -n switch and the namespace name. So by default, the namespace that is set is actually default namespace. Okay, if I run kube control get namespaces and I have this namespace, you can see this default namespace is everywhere and it is set as default. Now there must be a question in your mind that if I want to set DevOps Molvi as the namespace, as my default namespace, can I do that? Yes, it is possible, and the command for that is kube control config set -context -- don't worry guys, I have created the document on my GitHub repository and I will share all these commands that I have practiced in this practical session. So current namespace is equal to DevOps Molvi. Now you can see that context minikube modified. Okay, so I can set DevOps Molvi or any namespace as my default namespace running this command kube control config set context current and the namespace name, which is DevOps Molvi. Now if I run kube control get pods command, okay, it will by default tell me that there are no resources in DevOps Molvi namespace. Now for instance, if I change the namespace as default as kube system, okay, you must practice these commands again and again. And now if I run kube control get pods, and now I must see all the pods of this kube system namespace. Okay, now you can see the difference. Okay, so there were no pods in DevOps Molvi, and now I have set kube system as my default namespace. And now again, if I want to change to DevOps Molvi, I will just run this command kube control config set context current and namespace is equal to DevOps Molvi. Now there must be no resources kube control get services, and there are no resources get deployment, because this is actually a brand new namespace. So there are no resources and we are going to create our resources in our DevOps Molvi namespace. So for instance, if I create another namespace kube control create namespace my test namespace. Now kube control get namespaces, and you can see this is my test namespace. Okay, and it is active for the last 6 seconds. So I can now I want to delete this namespace. It was created by accident. Okay, and I want to delete it. Then the command would be kube control delete namespace and the name of the namespace my test ns. All right guys, now you can see that my test ns namespace has been deleted. So if you want to delete the namespace, you can run kube control delete namespace and the name of your namespace. And by the way, it is a dangerous command because the resources in that namespace will also be deleted. Okay guys, now if I want to see the pods in any namespace, kube control get pods -n and kube system. Okay, now it will show me the pods that are running in this namespace. If I want to see the pods in my default namespace, then kube control get pods minus or -default. So you have to run and -n and default, my bad. and you can see that there is one image, one pod in that is running in our default namespace. And if I want to see all the pods in every namespace, then I have to run kubecontrol get pods hyphen hyphen all namespaces. And now you can see that I have pods in all the namespaces. So this is the command kubecontrol get pods hyphen hyphen all namespaces. I am going to use extensively this switch to get the resources, to get the information about the resources, services, deployments, pods, okay, in every namespace. Then I can run kubecontrol get deployment get services hyphen hyphen all namespaces. So every pod in each namespace, if it is running in any namespace, would be shown here. Now I can see the pod of default namespace, kube system namespace, and Kubernetes dashboard namespace. So that's how we can run this command. Now if I want to know more details of all these pods in all namespaces, there is a beautiful command and I personally love it. Kubecontrol get pods hyphen o wide and all namespaces. Now you can see that I'm getting more information about my pods, the node it is running, each pod, the name of the node where it is running, and the IP address, age, restarts, and the status, and if it is ready or not. So you can use this hyphen o wide switch to get more details of one pod or all the pods in all namespaces. So guys, if I'm troubleshooting any issues with any pod and I want to get more details about a specific pod, then what kind of commands I have to use? So first of all, I am using this command to get all the pods in all namespaces. Kubecontrol get pods hyphen hyphen all namespaces. Okay, or I can also use kubecontrol get pods capital A. I will get the same output. See, so if you want to avoid writing this all namespaces again and again, you can simply use hyphen capital A with caps lock. Okay, so kubecontrol get pods hyphen A. Now for instance, if I want to know the details of my Kube-API server and it is in the namespace kube system, so I can use kubecontrol get describe pod, the name of the pod and the name of the namespace, okay, hyphen n kube system. So now you can see it has shared all the details of that specific pod. Now I am digging into any issue, so I'm getting all the possible details of each pod. So I can use this command, and describe will describe the details. It will list down all the details of a specific pod and the date of creation, what this pod is being used for, the IP address of the pod, and also the containers that are running in this pod. So kubecontrol describe pod, the name of the pod and the name of the namespace. Again, kubecontrol describe pod, name of the pod and the name of the namespace. For instance, if I want to run this command again, kubecontrol get pods capital A, and I want to get the details of this pod, kubecontrol describe pod, the name of the pod and the name of the namespace. Its namespace is default. Okay, now you can see that I have got the information the details of this pod and the time, start time, labels, annotations, status, IP address, and so on. So these are actually really important commands used for troubleshooting. Similarly, from troubleshooting, I want to share more details about the logs of any pod. Kube control, log, and the name of the pod. Sorry. Now, if I want to see the logs of any pod, then I can run kube-control logs and the name of the pod and the name of the namespace. So this is actually the logs. It is facing any issue. Similarly, I can run kube-control logs of Kube-API server. This is the pod and namespace as Kube system. Now you can see I'm getting the logs of that specific pod. So if I want to see the stream or live logs, then I can use kube-control get logs -f. This is just like tail -f or logs -f, and the name of the pod and the name of the namespace, Kube system, and I will get the stream logs, or you can say the live logs. So guys, 20 commands have been completed. Okay guys, now if I want to access any pod using SSH, for instance, if I want to enter into any pod, what would be the command? So first of all, I will run kube-control get pods, and you can see this is running as DevOps web. So for instance, if I want to SSH this pod, then I will use kube-control exec -it. This is just like we used to access Docker containers, okay? If you remember, and the name of the pod and the command with space, okay? --, and bin bash. Now I am in this in the pods environment. In the pod, just like we used to access any Linux server using SSH, we can access any pod using kube-control execute -it, name of the pod, and the command. Similarly, we can execute other commands as well. So now you can see this is my pod. I am inside the pod. So we can access the pods using this command. Now I will exit. Okay guys, if I want to run a new pod, for instance, a new pod can be run using kube-control run name of the pod. This is my pod 2, and the image that I want to use to run this pod. So --, image is equal to Alpine latest. So it will create a new pod. Now if I want to see that if that pod has been created, kube-control get pods. So you can see it has crash loop back off. This is the status of the pod, but that's how we can run new pods. For instance, if I want to run kube-control run pod 3 and image is equal to nginx latest, let's see what it does. Pod 3, pod 2 already exists and pod 3 has been created. So kube-control get pods, and you can see our pod 2 has also been completed and it will be running in a while. And our pod 3 is already running. Now I can use docker exec, just like we use docker exec. I can use kubectl exec to enter or to access this pod. So that's how, guys, we can run new pods. We can create new pods in any given namespace. Now, for instance, if I don't want to have this pod and I want to delete it, the command is simple: kubectl delete the name of the pod and the name of the pod, and it will delete the pod. Kubectl get pods, and pod 2 should be deleted. Okay, and now I have only 2 pods. So these are actually the related commands to create pods, to run new pods with different images, to see the pods, or to access the pods using the kubectl execute commands. So these commands were related with pods, and these are extensively used by the DevOps engineers who are managing Kubernetes clusters, because they have to troubleshoot any issues with the pods. So we have covered almost all the basic commands that are relevant to pods, like kubectl logs of the pod or stream logs of any pods, how we can delete any pod, how we can create new pods, etc. So I hope that these commands are simple for you, but you have to practice all these commands again and again to get your hands on these commands. Alright, guys, now after that, if I want to see the deployments, kubectl get deployment. You can see I have already one deployment that has been created. And guys, if you are confused, if you want to know about all these terminologies, you can watch my previous lecture about Kubernetes terminology, and I have explained each thing like pod, config map, deployment, service, etc. So since I'm focused on running commands in this lecture, so if you have any confusion about any terminology, you can watch out that lecture. So this is used to get the deployments, kubectl get deployment. And similarly, we can create a new deployment with the help of kubectl create deployment. The name of the deployment, like for instance DevOps Molvi, and the image is equal to Nginx and latest. You can see a new deployment DevOps Molvi has been created. Kubectl get deployment. Now you can see both deployments are ready and available. So that's how we can create a new deployment. Kubectl create deployment, and the name of the deployment and the image that you want to use to create that deployment. Similarly, if I want to see all the deployments of all namespaces, then I can run kubectl get deployments -- all namespaces, and it will list down all the deployments of our Kubernetes cluster. Now I can see 2 deployments in the default namespace, and there is only one deployment core DNS in the kube system namespace. So that's how we can use kubectl get deployments command to see the list of all the deployments. And now, guys, for instance, if I don't want to have the DevOps Molvi deployment, I can simply run kubectl delete deployment and the deployment name, and it will delete the whole deployment. Now again, if I run kubectl get deployments, our DevOps Molvi deployment has been deleted. So these commands are actually related with the deployments. After that, guys, let's discuss a few commands related to services. Kubectl get services -- all namespaces. Now you can see there are actually 2 types of services that has already been created. I have created this one, for just for testing, and it is a load balancer type, and it is cluster IP. A service is actually created so that the external users can interact with applications. We can use services to expose our applications for the external users, like NodePort. And we can also use services to expose our applications internally in within the Kubernetes cluster as well. So that is actually the purpose of services. And just I told you that there are 4 types of services. We can get all the services details with the help of kube control get services, and using all namespaces, it has shown me all the current services of that Kubernetes cluster. For instance, if I want to remove this service, okay, kube control delete service and the name of the service DevOps web, so it has been deleted. Now I want to recreate it. Then how can I create a new service? Kube control create load balancer. This is actually the type of the service. Load balancer, sorry, what is the spelling? Load balancer. Name of the service DevOps Molvi service, and the ports TCP is equal to 80 80 80. Now this is actually the external port, and that would be the internal port. This would be for the external users, and that is actually the port inside the container. So it will create, okay, and kube control create load, sorry, I have to use service. Okay, now it has been created. So this is actually the full syntax. Kube control create service. The type of the service can be cluster IP, node port, external name, and the name of the service DevOps Molvi service for this video, and the ports, the external port and the internal port of the container. So now kube control get services, I should be able to see the DevOps Molvi service and its type and the cluster IP, and this is actually the port where it is running. And if I want to delete this service, then the command would be simple: kube control delete service and the name of the service, and it will delete it. So these are actually the service related commands. That's how we can create new services and delete, or that's how we can also change the ports of any service. Alright guys, now after that we are going to discuss some config maps command. Config map in Kubernetes is used to create non-sensitive data. That data is not important from security point of view, so we can create config maps. So I will run kube control get config maps -- all namespaces. Now you can see this is the output. We have the data for against each namespace and what is that. For instance, these are some certificates, and this is also the certificate and other data. So that's how we can get all the config maps in Kubernetes cluster using kube control get config maps. And for instance, if I want to get the config maps of a specific namespace, then kube control get config maps -n default. So there is only one config map, and if I want to change it to kube system, now you can see there are other, and also it is showing the number of data that config map contains. So this, now if I want to use the describe command, kube control describe and the name of the config map and its name, sorry, kube control and hyphen n kube system. The server does not have a resource type, and this I will use config map. Okay, now it works. So that's how, guys, if some command is not working for you, you have to check where are you creating a mistake. So I was also creating some mistakes. So that's how we can see the data of any config map. What's the data inside any config map? So I have described the whole data of this config map using the kubecontrol describe config map command, and it is in the kube system namespace. If you are not getting any data, make sure that you check out the namespace and you check out the command or any typo or mistake, etc. So that's how we can see. Now this is actually the certificates and keys. So we can use config maps to store that kind of data. For secrets or passwords or tokens in Kubernetes, we use the secrets. And for non-sensitive data in Kubernetes, we use config maps. I hope that you understand the difference as well. Config maps are used for non-sensitive data, and secrets are used for highly sensitive data like passwords, keys, SSH or tokens, beer tokens, etc. And by the way, guys, similarly, we can use the kube control get config maps, and if I want to remove it, I can use the kube control delete config map. Okay, kube control delete config map and the name of the config map, but I need it, so I'm not deleting it, but the command, it should work for you. Kube control delete config map and the name of the config map, it will delete the config map. Alright, guys, after config maps, for sensitive data we can use the secrets. Okay, kube control get secrets hyphen all name spaces. Now there are actually no resources in any namespace on this Kubernetes cluster. This is just for testing purposes, but you can run this command to get the secrets of any Kubernetes cluster. And by the way, in order to create a new secret, I will just copy this command. This is a lengthy command actually, but it is really simple to understand. So I will just copy it. You can also see that I have all these commands pasted here, and each command has been described, explained in simple words so that you can quickly understand. So in order to create a new secret, for instance, I am creating a new secret, I will just copy this command and run it. So kube control create the secret, okay, and the name of the secret and the type generic, and this is actually syntax. Now I'm using username as admin and the password is admin123. So this is just a test secret, and you can see that I have created this secret. So if I run kube control describe my secret, in the default namespace, secret, my secret, and now you can see I have this. It has been created in the default namespace, and the data has been also encrypted using this type. So the password is and the username is 5 bytes and 8 bytes. So that's how we can describe the secret. And if I want to delete it, I don't need it, so I can run kube control delete secret and my secret. So that's how we can create new secrets, and that's how we can delete or work with secrets on Kubernetes. Alright guys, we have covered almost 43 commands. I have numbered all these commands here as well. So I have executed each and every command according to that page, according to that list. Now I have only, so we are left with around 6 or 7 commands. So the next command is actually related to see the replica sets on our Kubernetes cluster. Replica set is actually the identical number of pods on a worker node. That is actually a replica set. Kube-control get replica set -- all name spaces. So we have these replica sets, and if I want to check the daemon sets, a daemon set ensures that at least one pod should run on each worker node, but it is for actually a large Kubernetes cluster. So we can see a daemon set here as well. You can see we have this Kube-Proxy, so it means that Kube-Proxy should run on each worker node. So these commands, and also Kube-control get stateful set. Stateful sets are more organized pod with backend store or with storage with etcd. So stateful sets -- all namespaces, and there should not be any stateful set, but this command is used to get the list of all stateful sets on that Kubernetes cluster. So we can run Kubernetes kube-control get replica sets or daemon sets or stateful sets to get their details accordingly. And by the way guys, if you want to monitor the pods and nodes in your production cluster, I will just share the commands because I don't have any data on this testing Kubernetes cluster. This is just a mini cube. There is no load, there is no traffic, but the commands are really simple, and you can run kube-control top nodes, or you can see that there is no matrix, there are no data that is available for me, or I can also run kube-control top pods and there is no data available. Just like we use top on any Linux server, we can use the idea is the same. We can use kube-control top pods, or we can use kube-control top nodes, and it shares the live coverage, live load average, resource consumption, memory consumptions of nodes if we run kube-control top nodes. And if we want to monitor or watch out our resource consumptions regarding pods, we can run kube-control top pods. So guys, this would be our second last command. And if I want to watch all the pods, I mean their live status, then I can run kube-control get pods -- watch all name spaces. Now you can see this is actually the live status of the pods. I'm now monitoring the status of my pods, so this is just like a live stream. So that's how we can see the status of all the pods. And the last command, which is a dangerous command, but let's try it out. Kube-control delete all all namespaces, and it has deleted everything. Now you can see this pod has been deleted, pod 3 has been deleted, all the other pods have been deleted. So if I run kube-control get deployment, there is no deployment. If I run kube-control get pods -a, and Now these pods have been created again. You can see their age is 33 second, 32 second. So after their right after their deletion, because these are the core components of our mini cube clusters, so these have been created. Now the other data, other parts that we had on our Kubernetes cluster has been deleted. So there should not be any, now you can see there should not be any deployment, just like we have created DevOps web, and there is no service like we had in Kube DNS, Kubernetes, and all these parts were deleted. So that's why I have pasted this command at the end of today's lecture, because it is really dangerous. Make sure that you never execute such commands in even in dev or staging or QA environments. And I'm not talking about the production. It should be a disaster, and it can cost you job. So this is actually a dangerous command, but you can run it on your minikube Kubernetes cluster just like I did in front of you, and it will delete all the resources on one go. So guys, that was our lecture on 50 kube control commands that are mostly used by DevOps engineers to manage their Kubernetes cluster. Now, you must have minikube on your VM, and you run these commands again and again and again, so that you get a good practice of all these commands, and you understand how resources can be created in any Kubernetes cluster. Guys, honestly, these commands uh, are used to manage the production Kubernetes clusters. So if you have a good practice on this minikube cluster, I hope that you will have a great confidence to execute these commands on production environments. And in the upcoming lectures, I will be sharing more Kubernetes command, control Kubernetes CLI commands with you guys. Make sure that you subscribe DevOps Molvi. I will watch you in the next lecture. Have a good one, and bye. Hey guys, I hope you're doing great today. This is actually the part B of our kube control commands cheat sheet. Guys, you know that in the last part we covered around 50 kube control, which is Kubernetes CLI. Kube control is actually Kubernetes CLI, and it is used to manage your Kubernetes cluster. So in the first part, we covered actually around 50 kube control commands, and I hope that you have executed all these commands on your minikube cluster. Guys, minikube cluster is a fantastic solution. It is one of the best solution to get started with Kubernetes, to get started learning Kubernetes in a very quick way. Okay, so I have Kubernetes installed on my local machine. So it is really a quick way to get started learning your Kubernetes journey. So I have shared the Kubernetes repository that I have on my GitHub. You can take a fork, you can copy, you can clone it on your system, and I will be sharing everything on this repository regarding our Kubernetes course. So in the first part, in part A, you saw that we have covered around 50 kube control commands. Now you can see I have shared each command with a little bit of its explanation, so that you have an idea what is the purpose of that command, right? So I have shared each command and its information, a little bit information, and the purpose of that command, like kube control get nodes, you will get the nodes, master node and worker nodes of a Kubernetes cluster. And similarly, get all options, API resources, get pods, get namespaces, get services, and every command has been explained, and I practically executed each command in my Kubernetes commands cheat sheet lecture. So I will share the part A. I will share the link of part A in the description. So if you skipped that part by any reason, make sure that you must watch it. You have an idea of how kube control or Kubernetes CLI works. So in part B, we are going to cover around 30 more kube control commands, and in total we will have 80 kube control commands. Guys, if you know each and every command that we discuss in these two parts, around 80 kube control commands, I'm pretty sure that you will feel really confident to manage even servers or clusters in production. You are going to be managing Kubernetes clusters, master nodes, and worker nodes in production environment. And this is actually a professional training, and I would like to share each command in detail so that you feel confident that I know that much kube control commands. I can manage every Kubernetes cluster. So in part B, by the way, Kubernetes kube control is a command line tool which allows users to interact with Kubernetes cluster. And in our solution, we have Minikube. So Minikube is just a fully functional Kubernetes cluster on your personal machine or on your personal laptop, right? So we have Minikube as our Kubernetes cluster, and we can practice each command, all these 80 commands on our Minikube cluster to get our hands on Kubernetes. So kube control is used to deploy applications, manage and monitor cluster resources. So are you ready to run these commands with me? Let's get started. And before getting started, make sure that you subscribe DevOps Molvi, and you are going to learn and you are going to get professional Kubernetes training in this Kubernetes free course. So this would be our first command, kube control config view. And I have shared the brief explanation of this command, that to view your current Kubernetes configuration. Now I will start my WSL2. I have this machine on my local virtual machine, and I have installed Ubuntu via WSL2, and after that I have installed Minikube on this machine. So I will log in via root user, and I will give the password of my DevOps Molvi user. Alright, now I will clear the screen and I will check Minikube status. I've already shared how we can install Minikube. You can find it. There is a complete guide, install Minikube on your local machine, and you can install it on your personal computer. And it is a fully functional Kubernetes cluster. I have practiced all these 80 commands before presenting in front of you. I have practiced all these 80 commands on this Minikube cluster. It's fantastic. So you can see that it has been stopped. So I will just run this command, Minikube start, and our Minikube cluster will be started, and it is saying that you have to run with force, using force switch, because I am using the root user. Our Minikube cluster would be started in a moment. I guess we have to wait for it. Alright, it is now preparing, and you can see that we are going to use it is actually the latest version of Kubernetes, and we have this version 31. By the way, there is also 32 version also. It is available, but it is in, I think, beta release, and it is not recommended for production environments, I guess so. But this is actually the stable version and the updated version that I have on my virtual machine. So guys, this is the solution. You can learn Kubernetes on your computer using Minikube. And now Minikube status. Now you can see I have Minikube running on my virtual machine. So it is running. Now I can kube control run every Kubernetes command. Kube control get pods. Okay, I will just, okay, and there are no resources. and if I run kube control, I have already covered these commands. Kube control get pods minus or hyphen capital A. It means that I will get the pods in all namespaces. Alright, namespace is an isolated environment, and if you are going to create the resources in a specific namespace, those resources can only be managed using that namespace name. Now you can see I have ES cluster, Elasticsearch cluster. It is a functional cluster on my PC personal computer, and I have this namespace. By the way, if I want to see the pods of a specific namespace is an isolated environment, you can say, and you can build resources in that namespace, and those resources can only be viewed using the namespace name. Okay, this is actually a confusing thing, but let me explain it to you guys. Now kube control get pods minus n. Now I have to give the namespace name. Now what is the namespace name? You can see this is namespace. I have a couple of namespaces on my Kubernetes cluster, DevOps Molvi Elasticsearch. That would be our next chapter, by the way, in which we are going to discuss the YAML file structure of Kubernetes. And you can see Ingress, Nginx, and Kube system. So if I want to see the pods of Kube system namespace, then it will show me the pods of that namespace only. Now you get it. Namespace isolates the pods from other namespaces. Okay, now if I want to see the pods of DevOps Elasticsearch namespace, then I can use kube control get pods hyphen or minus n hyphen n namespace name and DevOps Molvi Elasticsearch. So it will share only two pods. Alright, I have two pods running in that namespace. So I have already covered these commands, just repeating for yourself. And if I clear, and if I run kube control get svc service, and you can see we have this service in the default namespace. That now the default namespace is set as default. We can change the namespace. I have already shared this command in our part A. So guys, now this was how we can use Kubernetes CLI, right? And now you must know how you can use Kubernetes CLI to manage Kubernetes cluster, your master node and your worker nodes. We are going to use these commands extensively in our upcoming lectures while we create DaemonSets, replica sets, stateful sets, namespaces, services, ClusterIP, NodePort, etc. Kubernetes CLI, which is kube control, it is actually the command line tutorial. It is actually the command line interface which is used to manage Kubernetes cluster. Now our first command, kube control config view. Make sure that you remember these commands. It is a good practice to execute the commands without copying it. Okay, I can copy from my GitHub repository, but I have tried to remember these commands, and it is a good practice to deeply explore what any command does. And now you can see I have got the whole cluster's configuration, and you can see the cluster info. It is running on this IP and port. Its name is Minikube. Context you can see, and last update of this cluster, its version. All right, and the namespace that is set, as I told you, it is default. User is Minikube, name Minikube, and every other information, the version, right, and the certificate information and provider, every information about your Kubernetes cluster. You can run kube control config view, and it will share the Kubernetes configuration overview. Alright guys, now you can see I have kube control and get pods minus n DevOps Molvi. This is my namespace for Elasticsearch cluster, and I have these two pods, and I have created a stateful set. Now what is the difference between daemon set, replica set, stateful set? There should be a separate full lecture covering these important concepts, but for the sake of this lecture only, we are going to discuss the commands. You can see I have these two pods running on my Kubernetes cluster. If I want to SSH each pod, I can run this command kube control, all right, execute minus it, and the name of your pod, es cluster dash or -0, whatever you call it, and this is the name, and double hyphen dash dash, right, and the shell bin bash. Okay, it is saying that error from server not found pods. And what is the issue? The issue is that I have not used the namespace name because it is not in the default namespace. It is in my DevOps Molvi Elasticsearch namespace. Now I should be connected. Okay, it is still saying that not found. So I have to use this command like this way. Right now, that's how we can troubleshoot -n DevOps Molvi Elasticsearch. Okay, now we are in that part. Okay, so that's how sometimes our commands, if they do not work, you have to fix them. So by the way, this command was also correct. If we have been in the DevOps Molvi Elasticsearch namespace, if it is our default namespace, then this command should have worked perfectly. But you saw that I have to explicitly mention the name of the namespace, and then I executed this command. It also didn't work. So I have to run this command in other way, and I have used -n the namespace after the pod name. So that is the correct syntax. I was making the syntax mistakes. So now if I run curl localhost and 9200, the Elasticsearch port is 9200, and you can see it is running on my pod. So that's how guys you can SSH any pod. For instance, if I run, I have another pod, kube control get pods -n DevOps Molvi Elasticsearch. Now this is my pod es cluster 1. If I want to SSH this pod, I will quickly do it. Kube control exec -it es cluster -1 -n. Now it should not create any problems for me. So DevOps Molvi Elasticsearch and -- bin bash. I have remembered the whole command. Okay, and it worked like a charm. There were no issues. So that's how guys you can enter into any pod. Okay, so if I want to delete certain pod, then I can run kube control get pods -n DevOps Molvi Elasticsearch. Okay, sorry, this is the CLI problem, and I can use delete pod. Okay, delete pod, and if I want to delete this pod, I have to mention, I have to give the name of that pod. Guys, by the way, I am executing all these commands. Okay, you can see all these commands, and make sure that you have to use your own pod names and you have to use your own namespace name. That's how you can clear your concepts. Everything should be customized. Okay, you must change your namespace name, you must change your pod's name. That's a better idea, so that you know what are you doing. And now if I want to delete this pod, I can run this command, and okay, now again, yeah, DevOps Molvi Elasticsearch. Alright, our pod has been deleted. That's how we can delete any pod. Now if I run kube control get pods -n DevOps Molvi Elasticsearch. Alright guys, now you can see that my new pod is initializing again, though I have deleted the pod. But why it is now being reinitialized, why I'm getting a new pod? Because I'm using StatefulSets. If I want to show you ES cluster, I have the YAMLs here. You can see I have this main cluster YAML, nano ES main cluster. You can see I am using StatefulSets. So if by any chance you remove or you delete a pod, Kubernetes cluster will recreate a new pod. This is the you can see that this is actually the benefit of using StatefulSets, right? So you saw I deleted the pod and a new pod has been reinitialized. If I run kube control get pods -n DevOps Molvi Elasticsearch, it is now running. If you want to practice it, you can delete this pod ES cluster 1 and you will see that it will be reinitialized again. And if I want to forcefully delete all these pods in that namespace, I can use kube control delete pods -n all -n DevOps Molvi Elasticsearch -force, and it will forcefully delete all the pods in that namespace. Let me run it. Let's see. Okay, and you can see that it is saying immediate deletion does not wait for confirmation that the running resource has been terminated. The resource may continue to run on the cluster indefinitely. And after that, my both pods have been deleted since I have used forcefully. So it has forcefully removed and terminated both pods. Now if I check get pods -n DevOps Molvi Elasticsearch, and one pod is now running again and the second pod is in the initialization phase. So it will take a couple of minutes to get initialized. So that's how guys, if some pod is not getting deleted, it is causing any issues, we can run the force command. We can run this switch to forcefully terminate, to forcefully delete any pod or all the pods in any given namespace. All right. And if you see the command, I have also explained that this command deletes all pods forcefully in the DevOps Molvi Elasticsearch namespace. After that, guys, we can remove. First of all, I should tell you that kube control get StatefulSets -n DevOps Molvi Elasticsearch. Now you can see I have a stateful set with the name ES cluster. This is a stateful set with 2 pods. And if I want to delete this stateful set, I can run kube control delete. By the way, I have used YAML files to create these stateful sets and namespace and service. if you want to see, I have used this namespace nano namespace.yaml. It has created this namespace DevOps Molvi Elasticsearch. And if I want to see the service, ES service, and this is my service Elasticsearch cluster using this namespace, and you can see I have the ports information in the service YAML file, and this is my main clusters YAML file in which I have created this stateful set in this namespace with 2 replicas. Okay, you can see, by the way, I'm sorry, we are going to have the full YAML lecture, which is our upcoming lecture, but I just want to give you an idea from where I have created this stateful set. I can increase the number of replicas. Okay, if I want to increase the number of replicas, for instance, then I can run and change, and after that, if I apply, there would be 3 replicas. Should I try it? Okay, I'll give it a quick try, and kube control apply -f es main Elasticsearch. Okay, and it has been covered. Now if I run kube control get stateful sets -n DevOps Molvi Elasticsearch, now you can see there are 3 stateful sets. 2 are ready and 3rd should be in the process of initializing. And if I run kube control get pods -n DevOps Molvi Elasticsearch, and you can see now I have 3 pods. So this is actually a stateful set with 3 pods. I have the replica. Each replica is identical with the same storage, with the same features. All right, so that's how we can create a stateful set using the YAML. So now if I want to delete this stateful set, the command is kube control delete stateful set, and stateful set and its name es cluster -n DevOps Molvi Elasticsearch. Okay, I'm going to delete it. It has been deleted. Now if I check it using kube control get stateful sets, that's how you practice the commands. Stateful sets -n DevOps Molvi Elasticsearch. All right, it has been deleted. Okay, so that's how I have also shared the command with you guys. Kube control delete stateful set es cluster, and it will delete the es cluster stateful set from my DevOps Molvi Elasticsearch namespace. And if I want to create again, now if I want to see the pods, there should not be any pods now, because the stateful has been deleted, the stateful set has been deleted. -n DevOps Molvi Elasticsearch, and it has been, everything has been deleted regarding stateful set. We just have the namespace. And if I run kube control apply -f and es main cluster.yaml, and I will create a new stateful set with the same name es cluster. Okay, kube control get stateful set -n DevOps Molvi Elasticsearch, and it should be in the process of initialization, and the rest of the 2 are in the phase of creation. So guys, that's how we can deal with stateful sets in Kubernetes. Now you saw that I have deleted the stateful set. I want to see the new stateful sets progress. Then I can run kube control status, rollout status sts stateful set and es clusters, which is the name of the stateful set, -n and the name of the Elasticsearch namespace, and it is saying that partitioned rollout complete, 3 new pods have been updated. So you can see if there are hundreds of pods, okay, in that stateful set, and you want to see the progress, how my pods are being initialized, then you can run this command kube control rollout status, and stateful set, STS stands for stateful set, and name of your stateful set and the name of your namespace. If I run kube control get pods -n, all pods should be running and good to go. Elasticsearch. That's how we can create and terminate and then recreate stateful set. It is our mini kube cluster. We can get our hands dirty on this. And I have shared this command as well here. But before running this command, make sure that you remember these commands so that you have a better idea what are you doing. After that, guys, now we are going to start with PVC, okay? And PVC stands for persistent volume claims, and there is PV persistent volumes and there is PVC persistent volume claims. And guys, there is a difference between a PV and a PVC. Persistent volume is actually the volume that is physically attached to any pod, and PVC is just like we claim for the storage, and when we claim for the storage, it is assigned to our resource, then it becomes the physical and the actually attached storage. So first we have to claim for the storage. It is just like the example of voucher, and we claim the voucher and then we get everything, a certification voucher, like, so we have to claim the voucher and then we can get the discount or the actual money. So similarly we have to claim the storage, and this is the difference. The key difference between PV and PVC is that persistent volume is actually the volume that is attached to a pod, and PVC is actually the storage that has been claimed by that pod to be attached to it. All right, so we have to claim, and by the way, when the claim is successful, that volume is attached as PV. So it is one of the important interview question and answer. What is the difference between a PV and PVC? So I've told you the best example of PVC is the voucher. You have to give the voucher to claim your discount, to claim your money. All right, so now I will run this command kube control get PVC, okay, persistent volume claims, and we should have around 3 volume claims, because since we deleted our stateful set, and now we should have 3 volume claims. Now you can see that I have 3 persistent volume claims. All right, and in my YAML file I have es main cluster. I have this information here, and you must see that volume claim templates and the metadata, data, ES service, and each claim is 5 GB. So that's how we can see the persistent volume claims. And also, if I want to see the persistent volumes, then I can run kube control get PV and the namespace name. So these are my persistent volumes that were actually attached to the pods. So this is the claim, how you claim for the storage, and this is the storage that is actually attached to any pod. So this is the difference between a persistent volume and a persistent volume claims. So similarly I can run other commands, and if you know the commands for PVC or PV, both are almost the same. Just have to use PV or PVC. Kube control get PV, all right, in all namespaces, then this command. And if I run PVC in all namespaces, then you have to use this command. And similarly, kube control describe And if I want to describe any persistent volume, then I can run this, the name of describe PVC and the namespace name to get more details of any volumes. Okay, now you can see the output, the name of the persistent volume, its storage class and its claim, and also the storage or the disk space that this volume has, and it has 4 GB. All right, so for instance, if I want to edit and I want to reduce the disk space, okay, then I can use the name of the persistent volume. This is the name of the persistent volume, and I will use kube control edit PV and the name of the PVC and the name of the, okay, now it is better to see it. Now you can see I have the information here, and for instance, if I want to reduce the size, and I can edit and 3 GB, okay, then okay, sorry, and I will save the changes, and it is saying that persistent volume, this has been edited. Now if I run kube control get PV and DevOps Molvi, you have to use this namespace again and again. I can set it by default, but I just want to make sure that you practice that way, because in a Kubernetes cluster there can be 10 or 20 namespaces, so you have to use the namespace name. Now you can see from 4 GB it has been reduced to 3 GB. And similarly guys, I can use the kube control delete PV and the name of the persistent volume, and it will delete that persistent volume. And similarly I can use the PVC and the name of the persistent volume claim and the name of your namespace. I have already shared these commands. Now you can see I have this kube control get PV. PV stands for persistent volumes, and this command tells us all the persistent volumes. And similarly I can use the describe command, kube control describe. I have already run this command, and get my persistent volume name o wide. So it is, let's run this command, and kube control get PV and the name of the persistent volume o wide, and it will actually share more details about that persistent volume. Now we have got a little bit more details, and if I want to see the output in the JSON format, I can run, I will get all the details about that persistent volume in the JSON format. Now you can see I have each and every detail of this persistent volume in the JSON format. And similarly I can get in YAML as well, YAML, and now you can see I have got the details in the YAML format. So I will clear, and now this is YAML -o -o YAML, or if I want to see in the JSON format -o JSON, or I just want to know some general details about that persistent volume. I have shared all these commands here. You have to replace, you have to change the name of your persistent volume. That's why I have used my PV name. It is because you have to change the persistent volume name accordingly, okay? And that's how we can edit. I have run this, and that's how we can delete any persistent volume, and we can delete all the persistent volume running this command. And similarly this will show us all the persistent volume claims in all the namespaces, sorry. And now if I want to see this storage class, then I can run this command. And it is also a simple storage class, means the standard storage. Just like we have in cloud computing, there are storage classes. So we have normally the default storage class as standard kube control get sc, and now you can see it is actually the standard storage class Kubernetes cluster minikube is using. It can be high performance as well. So this command is used to tell the storage class of your Kubernetes cluster. And if there are normal workloads, then we can use this storage class. And if our applications need intensive high performance, then we can use the storage class as high performance for large Kubernetes clusters. So this is the command to get the storage class information. That's how I can get more details, or if I want to run the JSON, so that's how I can get more details in the JSON format. And similarly, the purpose of showing these commands that you can change these switches so that you can get more details. Now -o YAML, it will print out the output in the YAML format, and you will have a better idea and full details of any storage class or persistent volume or pod. These three switches, -o wide, -o and space and JSON, or -o and space and YAML. And if I want to know more details of this pod, then I will run kube control get pod and the name of the pod es cluster get pod. Okay, get namespace, get service, get pv, get pvc, 0 hyphen o y -n and name of the. Alright, now you can feel the difference between both commands. It is sharing the output and it is just telling that it is ready and running. But this command is showing a little bit more information. It's node, IP, age, status, readiness, nominated node, etc. So similarly, if I run SER, and if I run JSON, I will replace, and now I can have every possible detail of this pod in the JSON format. And these commands are extensively used for troubleshooting issues with pods, services, replica sets, daemon sets, etc. And if I want to replace with YAML, YAML, and I will have the information in the YAML format. So that's how, guys, we can get the detailed information about any object or any resource in a Kubernetes cluster. And don't worry, each command has been written here. You can run each command one by one. And now I think that I have covered almost every command. And okay, I have used this command as well. And now I have also used this command for, I will run it and I will tell you what this command does. And we have kube control get stateful set and now if I want to scale down it, okay, then I can run this command kube control scale stateful set es cluster replicas is equal to 2, and then I will have only 2 replicas of this stateful set. So changing the number will scale up or scale down that stateful set. So we will have the number of pods accordingly. Now if I want to scale down, okay, now you can see it has been scaled, and we must see es cluster as 2 by 2. Okay, if I run this command again, and okay, I will just copy this command. Okay, now you can see we have only 2 replicas of this stateful set. And if I scale it up, then I can run 4, and it has been scaled up. They should be 2 are running and 2 must be initializing. Then I can run kubecontrol get pods -n, and the name of my namespace. You can see now the 4th is in the initialization process. So I have also shared this command how we can scale up. By the way, in our daemon set, replica set, and stateful set lecture, it should be a complete lecture because it is one of the most important concept in Kubernetes. Replica sets, daemon sets, and stateful sets. So we are going to practice these commands again by scaling up, scaling down daemon, replica, or stateful sets. Alright guys, our last 5 commands, and these commands are about roles. Guys, you know that roles are set of permissions telling that user or a service account how you can manipulate or deal with the Kubernetes cluster resources. Just like if you remember, we discussed roles in Google Cloud Platform, like editor role, viewer role. So these are all permissions, and we can grant those permissions, those roles, to a specific user or a service account. Similarly, we have roles here in a Kubernetes cluster, and we can get the roles information about roles running this command, or we can use the namespace kubesystem, which should have every information about the roles. So you can see we have these predefined roles, and similarly we have cluster roles to see all the cluster roles, and then we can assign those roles or cluster roles to specific users or service accounts. Now if I run, and kubecontrol get cluster roles, and all these are cluster roles. So there is actually a slight difference between a role and a cluster role. So what would be the difference? A role is actually the set of permissions for a specific namespace, and the cluster role is actually the set of permissions for the entire cluster. A role can be applied to a certain namespace, and a cluster role is going to be applied to whole cluster. Okay, this is actually the difference. A role is specified for a specific namespace, and a cluster role is specified for the whole cluster. So that is actually the key difference between a role and a cluster role. Kubecontrol get roles, you will find the roles in any defined namespace, and if I run kubecontrol get cluster roles, you can see we have all these cluster roles like cluster admin, which are the administrator roles for any Kubernetes cluster. So similarly, if I want to see what do I have in this role, then I can run kubecontrol describe cluster role. Okay, if you want to get the information about role, then you have to run kubecontrol describe role, and if you want to get the information or details about a cluster role, then you have to change the command as kubecontrol describe or get cluster role and the name of the cluster role. Okay, now you can see the information, more details about this cluster admin role, and it has access to all the cluster resources, just like we have administrator or just like we have the root user. So similarly, we have this cluster admin role, and if I run admin, then it is the most powerful role in our Kubernetes cluster. So that's how I can see what this role has, policies, all the policies and resources this role has. So I can use the kubecontrol describe cluster role and admin. So similarly, I can use other roles names, and I can get the details about every role. So these commands are used to get the information about roles and cluster roles. And I have also shared all these commands here. You can see kube control describe role, see the details of a specific role, and kube control describe cluster role to see more details of any cluster role. And finally, guys, our second last and last command, and you can see my Kubernetes cluster tutorial where I have shared and practically used these commands. This is actually the Kubeadm, Kube administrator. These are commands to join or to create token for the worker node. Now you can see I have this command Kubeadm join, and I can run this command on Kubernetes worker node so that it can join the master node. And similarly, if I forgot the token for some reasons, I can recreate this token again, and I can use this token on my worker node to join it with the master node. And I can show you here, I have used this command. So it is used to join our worker node with the master node. Each worker node should have run this command so that it can join the master node. So I have also shared these two commands. By the way, if you are still confused how we can use these commands, you have to watch how to create a Kubernetes cluster. That was my previous lecture in which we created a master node and a worker node, and we created one-to-one Kubernetes cluster with one master node and with one worker node. That's it, guys, for today's lecture. So we covered around 80 kube control commands. I hope that if you practically perform and practice all these commands, you will have a better grip on kube control and Kubernetes CLI. In the next chapter, we are going to discuss the YAML files of Kubernetes and how the syntax of those YAML files look like or work. So next chapter is really important to understand, because if you understand one or two YAMLs of any Kubernetes cluster, you will be able to manipulate or change those YAML files to create resources, namespaces, pods, services, etc. on any Kubernetes cluster. So make sure that you subscribe DevOps Molvi. I will watch you in the next chapter in our free Kubernetes course. Have a good one and bye. Hey guys, I hope you're doing great today. This is our chapter number 42, in which we are going to create our own cluster. That cluster will have one master node and one worker node. It depends on you if you can join more. If you have more worker nodes, you can join with the master node. But for this lab, since I have resources on my AWS, so if you can join one worker node, it would be the same practice to have more worker nodes joining your master node. So let's get started, and make sure that you have subscribed DevOps Molvi. This is my Kubernetes by DevOps Molvi repository. I will share the link of this GitHub repository in the description of the video so that you can fork it, and you must give it a star. So everything related to Kubernetes we are going to discuss in our lectures. I will share every information, every notes of the discussion in my YouTube tutorials on this GitHub repository. So I have opened the main the repositories page, and you can see I have this how to install Minikube. We have already did this, and we practically installed Minikube on our virtual machine, Linux virtual machine. And also, guys, if I click on what is Kubernetes, this is actually the main page of this repository, just like we have README. So this is the README of my repository, Kubernetes repository, and I have been sharing all the links of YouTube tutorials here, and also the Google Docs since two of these lectures had the slides on Google Docs, Google Slides, so I have also shared the URLs, links of those drives, those slides here, and a general information about Kubernetes and its components that we have already discussed in our previous lecture. So in our today's lecture, we are going to learn how to create a Kubernetes cluster. Okay, we can have Minikube on our local Linux virtual machine, and we can practice everything on that local Minikube cluster. But what if I'm asked to configure to create a cluster with one master node and two worker nodes, or one master node or three worker nodes? So we also know the process, the procedure to create a Kubernetes cluster that is actually for production environments. In a production environment, you know that there can be three master nodes and there can be 2 or 12, a dozen worker nodes for load balancing and for fault tolerance and also for high availability. And for this lecture, guys, you can do it on your virtual machines as well. If you have 3 or 4 virtual machines, you can do it as well. But since I have virtual machines created on my AWS account, I have created a master node and a worker node on AWS EC2 instances. So I am going to create a Kubernetes cluster where I have one master node and one worker node. So it is one of my favorite guide in which we are going to create a Kubernetes cluster ourselves on a couple of virtual machines on our AWS account. I will show you that. And in this Kubernetes cluster, we will have one master node, and also I have shared the specs, at least 8 GB RAM and 2 CPUs, and one worker node with 4 GB RAM and 1 CPU each. So it means that if you want to have 3 or 4 worker nodes, you can create these worker nodes, you can create these virtual machines on your AWS account with these specs. Okay, and it is up to you. I have also written each and everything so that it should be easy for you. And if you want to have one master node and one worker nodes, you can create with these specs. In the beginning, I will have one master node and one worker node, and we will learn how we can join the worker node with the master node. If you can join one worker node, it would be definitely easy for you to join 2, 3 or 4 or 12 worker nodes. The same practice should be observed on each new worker node. You just have to create worker node, you just have to create virtual machine on your AWS account, and you can do the same practice to add as many as worker nodes that you want. So now, guys, the step number 1 is to create a VPC on AWS, and we need to have a virtual private cloud where we will run all our virtual machines. And if you don't want to create a VPC, you can use the default virtual private cloud of your AWS account. But I have created mine, and I will create a security group. I have did that, and let me show you that this is my console. So you can see I have VPC here. Now if I click on VPCs, you can see that I have created my own DevOps Molvi virtual private cloud with internet access, and I also have created a subnet, DevOps Molvi subnet, and an internet gateway to route and to connect the virtual machines with internet gateway. After that, guys, I have created the EC2 machines, 2 virtual machines. One is my master node and the other is my worker node. Now you can see both machines are running. This is master node and it is a T3.large instance, and this is my worker node and it is T3.medium. This is 8 GB and this is 4 GB RAM, and these master node and worker nodes machines are created in the same VPC, in the same subnet, so that the communication, there shouldn't be any issues with the communication between master and worker nodes. That's why it is recommended to have your own VPC, to have your own virtual private cloud and subnets and security groups and the internet gateway within a virtual private cloud. So this is a recommended practice, but if you know AWS, you can do as per your choice. Now I have, this is my worker node, this is my master node, and I have this as my worker node. So after that, we have created the EC2 virtual machines, okay, and the VMs must be created in the same VPC that we created above and the same security groups. Now guys, the actual drill begins, and we will have to install containered on the master node, and we will do the same thing on our worker node, okay, because the components that are installed on the master node should be installed on the worker node, okay. There would be slight difference, and what is that difference I will tell you by the end of this video. So first of all, we have to install containered on the master node, and then we will install containered on the worker node. Guys, if you remember, we used Docker as our container runtime on Minikube, but for production systems, for large workloads, it is recommended to use containered instead of Docker. And the recent latest versions of Kubernetes are more comfortable, I would say, or more compatible with containered instead of Docker. So that's why we are going to install containered on our master and worker nodes. And containered is the container runtime, just like we have Docker or Podman. And guys, you know that the pod is the smallest unit in a Kubernetes cluster, and it contains containers, okay. Each pod contains containers, and those containers are created using a container runtime, just like Podman, Docker, containered, okay. And we are going to proceed with the installation of containered. Now there is a really important concept that we must know about swap memory, okay. Why should we disable swap memory? All the installation guides you see on the internet, on Google, they recommend to turn off, to disable swap memory. And why? What is the reason? I have also shared the reason with you guys. Because disabling swap memory is that Kubernetes relies on a predictable memory usage for scheduling pods efficiently, and swap can make it difficult to accurately calculate the memory requirements of a pod. Therefore, it is recommended to disable the swap memory to avoid any performance degradation issues. Guys, swap memory is just an additional virtual memory, and the swap memory is used to avoid our Linux servers to run out of memory. So swap is actually a virtual memory, but in Kubernetes we need actual physical memory. We need the actual RAM that our master node or worker nodes have. Therefore, it is recommended that we must disable the swap memory, so that our Kubernetes cluster should have a clear idea that much amount of memory or RAM I have on my master node or on my worker nodes. I hope that you got the concept. We disable the swap memory so that our Kubernetes cluster should not get confused with the memory allocation. It should have a clear idea of the exact physical memory on the master node or on the worker nodes, right? So if we disable swap, we will definitely have the actual physical memory. We will not have any virtual memory or any additional. We must disable swap, and this is one of the important interview questions and answers regarding Kubernetes. So that's why we disable swap. I hope that it is clear, and this command is used to disable swap. So I am logged in on my master node and I will run it using the root user. If you are using any other user, you have to run all these commands with sudo. I am using root, so because I feel more comfortable using the root user. And we are going to copy and paste all these commands that are here in this tutorial. After that, we need to run these following commands to install container. So the first step is to install containered. So I will apt update or apt get update, whatever, and apt install. Guys, this is a brand new virtual machine. This is a brand new master node, and I literally didn't execute any command before starting this lecture. And the purpose of doing so is that you have a clear picture when you start creating your own Kubernetes cluster. You can do it along with me, and you have to run all these commands. By the way, there is one point. It is Ubuntu 24.04. The operating system that I have is Ubuntu 24.04, and also I have to change the settings. Colors, I will use the system colors, and appearance, I will change it to 14 so that you can clearly see. Apply. Now I think it is better. So I have run apt install. I will clear the screen, and the next command is to make this directory, and I will just copy and paste the command. This directory should be created, and after that I will download this GPG key for Docker, and it should work like a charm. And these commands can be run without any issues. And if you are okay, after that I will run apt get update, and my repository should be updated. So now this is actually the command to run to install containered. Okay, I will just run it, containered.io, and it will install containered on my Ubuntu master node. And after that, we are going to create a directory. So containered has been installed. Now I will run this command, and it will actually copy the default contents of our containered configuration in this file known as config.toml. Okay, TOML, and I will just copy it, and you will see that this file should be created. I can cat this file to see the contents. All right. Okay, now you can see we have this container config.toml. So it is actually the configuration file of container. And now I will run this command, and I will edit config.toml, and I will set the value of systemdc group is equal to true, which is false by default. And the purpose of setting this value is equal to true is that in the config.toml file, container is to enable the use of systemd for managing control groups for containers. That is the purpose of doing so. And I will edit this file and run it. Now I can find this. So I will copy and Control W, enter, and you can see it is false by default. So we have to create container groups, and that is why we need to make it true. And yes, whatever lecture you are following for installation Kubernetes cluster, you will find it. All right, and it is recommended. After that, we just have to restart containered, and I will do so. and after that systemctl status container, and it is active and running. So our container has been installed, and this is our container runtime to create containers in the pods on our worker nodes. The container should be installed now, and now we have to install Kubernetes components like Kubeadm. Kubeadm is just like Kubernetes administrator. Kubelet, a service which communicates with the core components of the master node and also with the worker nodes. And we have Kubernetes CLI. So these three components should be installed on the master node and also on the worker nodes. So the first step is to get the GPG key, okay? And now we are going to install our Kubernetes components on the master node. I will get the Kubernetes apt keyring.gpg key, and after that I will update the Kubernetes repository, Kubernetes. You can see every repository that we update should be here in etc apt. All right, and after that I will update, and I will just run this command to install these three components. First of all, I have to update apt update, and all right, it is done. And after that we are going to install the three major components of the master node, and it shouldn't take that much time, and we are going to have it in a couple of moments. All right, it is done, and now I will hold, or I will lock the versions. Okay, this command is used to lock the versions, and you can see the versions of these three components have been logged. So these are just some modules and dependencies, or you can see prerequisites that we have to install or add. And after that I will run this, and finally I will initialize after updating these configurations. And now I will start my master node and running the Kubeadm init command, and it will initialize my Kubernetes cluster on this network. So I will just run, and let's see. I'm a little nervous. I would like to see that this command should work perfectly without any issues. So let's see how it goes. Okay, now it is pulling the images required for setting up a Kubernetes cluster, right? And it is using this command to pull the images. And now I hope that you're following up with me running this command. And now you can see etc Kubernetes. All right, our Kubernetes cluster has been initialized, and now there are some important points that we must know. Your Kubernetes control plane has initialized successfully, and control plane is master node. All right, control plane is master node. So our control plane, or I can say all the components of the master node has been initialized. To start using your cluster, you need to run the following as a regular user. First of all, I will create this directory. So we have to run these commands so that we can access our cluster without any issues. Every configuration regarding our cluster is stored here, and we want that we can access every data, users, contacts, config maps, etc., everything of our Kubernetes cluster. And that's why we have to run these commands that you will get after you run kube init, Kubeadm init command. At the end, you must see these commands, and it is, you can say that it is a symbol that your Kubeadm init command has run successfully. So after that, I will export the kube config, and now we must be able to run Kubernetes commands and kubectl get pods. You can see that there are no resources found in the default namespace. But if I run all namespaces, and now you can see that we have these components of the master node. They are running fine, and it means that our master node or the control plane is up and running. So we have also have core DNS, and it will take a little time to run. And after that, we have to install network plugin Flannel, and it is an open source container network interface plugin which creates a virtual network for containers so that the containers can communicate worker nodes and also with the master node. And it is required so that worker nodes do not face any issues while communicating with the master node. So you can say that it is just like a virtual network of the master and the worker nodes. So we have to install this plugin on the master node only. All right, you don't have to install it on the worker nodes, and I will just run it. You can see a new namespace has been created and a new RBAC account has been created, a config map, and a daemon set. Now if I run kubectl get pods, and luckily everything worked perfectly without any issues. Now you can see every component of our master node is fully functional. But there is something we are forgetting. Now it is saying that you can join any number of worker nodes. We have done this. It is talking about the Flannel plugin. Okay, we have already installed this pod network. We have used this Flannel. All right, and after that there is one step. We are one step away from joining our worker node with the master node. Now if I run kubectl kubectl get kube control, by the way, you can see we have only one master node. So in order to join worker nodes with the master node, make sure that you save the kubeadm join command. Okay, and it contains the token information and the certificate hash. So I have saved it. Make sure that you save it. And now we are logged into the worker node. So I will also change the settings, use system colors and appearance as 14, and I will apply. So this is my worker node. I will restart the session and sudo -i. So I will run apt update. Now I will repeat all these steps that I did on my master node. So first of all, we are going to disable the swap memory should be disabled, and after that apt get update, and I have run already. I will install these prerequisites, and now we are going to install container, and I will just copy and paste these commands. So you have to do is the same way, just copy and paste the commands, and we will have container installed in a couple of moments. All right, and after that apt update and this command. So I will run apt update, And now I will install container. And after that, once it is installed, we will do the same practice. I will create this directory and I will copy the default configuration of container. And now I will just edit my container configuration file and I will change the value from false to true. Control W. I will search it and true, and I will just save it. And after saving the configuration, we are going to restart container, and our container should be running on our worker node. All right, it is running, so it is not a big deal, and you can easily run these commands to install container. So now after that, we are going to install these components of Kubernetes on our worker node as well. So make sure that you pay attention. There is one last step that we must know in order to avoid any inconvenience. So I will just paste these commands, and these commands are just to update our repository, okay, so that we can install the latest version of these core components of the master node. Now our repository has been updated, so I will run apt update, and after that I will just run this command to install the components of my worker node, and I will also hold the version so that each master and worker node should have the same versions. And running this command, these are some prerequisites, you can say, and I will run this, and after that we will update our system with the configurations. Now I do not have to run this command at all on my worker node. This command should be run, I will mention it here, sorry I forgot. This command should run on the master node only, and we should not run this command on the worker nodes. We just need the components, the services on the worker nodes. And for your information, I have also shared here that just like we did install container, Kubeadm, Kubelet, and Kube-Control on master node, we have to install these packages on the worker node as well. There is an important point to remember that we don't have to run Kubeadm init, which initializes the Kubernetes cluster on the worker node, because we are going to join our worker node with the master node. So we don't have to initialize Kubeadm on each worker node. We don't have to do this, and it will create a mess. So instead we have to run Kubeadm join to join the worker node with the master node to create a Kubernetes cluster. And this is actually the general command. And now I told you that we have only kube control get nodes on the master node. You can see we have only one master node, and when we run this command Kubeadm join, so our worker node will join our master node and it will be a Kubernetes cluster. All right, now let's see. Okay, so it worked like a charm. I was expecting some issues, but there were no issues and everything worked perfectly. Alhamdulillah. And now this node has joined the cluster. So our worker node has joined our master node. So certificate signing request was sent to API server and response was received. Okay, so the kubelet was informed of the new secure connection details. Now I can run kube control get nodes on the master node or the control plane to see if our worker node has joined it or not. Guys, this is beautiful, by the way. So I will run kube control get nodes, and we should see our worker node here. So the suspense is over. All right, and you can see our worker node is ready and it has joined our master node. So now you saw we had only one master node, and now similarly, if I have 3 worker nodes or 5 or 6 worker nodes or 12, I have to do the same practice, and I can join all these worker nodes with the master node, and master node would be responsible to manage all these worker nodes. So guys, you can run these commands. I have practiced and I have run these commands again and again to make sure that you don't face any issues while creating your own Kubernetes cluster. So these, you saw that every command worked like a charm. There were no issues running in any command, and these are optional. You can run kube control autocomplete so that you get all these commands auto completed, and we can execute the following commands for kube control autocomplete, and it is recommended for quick learning. So let's try this out as well, and I will run this on the master node. All right, and after that, alias k is equal to kube control, and if I run k, now you will see the magic. Okay, k, and we will have all the kube control commands. Okay, k get pods, k get pods, and k get pods -a. So we have k, the alias of kube control command. So instead of running kube control again and again, I can run simple k and it will share all the kube control commands. Now guys, there is one last thing before we wind up this lecture. You can see I am going to create a deployment, and we are going to run our Nginx, simple Nginx web server on our worker node. So first of all, I have to create a deployment. All right, this is my deployment. We are going to just deploy a simple Nginx web server on our worker node. Nano deployment .yaml. Okay, in this, and I will just save it. Kube control or k apply -f deployment, and now my deployment has been created in the default namespace. Okay, kube control get deployment, and it is ready. After that, we have to create a service. A service exposes our application for the external users. Now I will create a service nano web.yaml, and I will paste. You can see this is simple web service running Nginx on this. This is the NodePort. A NodePort is actually the service type for external users, and I will just save it, and after that I will run kube control apply -f web.yaml. Now our service should be created. Now if I run kube control get pods, I should have one pod running Nginx in the default namespace, right? You can see I have this, and if I log in inside the pod, I will run kube control exec -it and the pod name and the command bin bash. I have logged inside the pod, and now I can run curl localhost colon 80. Okay, our Nginx is running on our pod. You saw that. Now this pod has been created on the worker node. You don't have to confuse. The worker node should have the pods, but we can manage all these pods running on the worker nodes from our master node. So I will just exit, and if this is actually the IP address of worker node, curl if config dot me, and if I run this is the worker node's IP, and if I run the node port, right, where is my node port? I can see this is my node port. By the way, I can check, sorry, I can also see kube control get service svc. Now I can also see the node port here as well. So I will use the worker node. Now this is the IP address of my worker node, and I will use the node port here. Okay, you saw that our Nginx has been deployed on the worker node. This is the IP address of the worker node. Again, if I tell you, this is my worker node 16.16.210.9 and 16.16.210.9, and it is running on this node port. But if you want to run it on port 80, we will have to use Nginx as the reverse proxy. All right, so we can install Nginx on our worker node just like we can do it on a normal machine, on a normal Linux machine. Apt install Nginx, and we will have Nginx. After that, I just have to edit the default configuration file, and I will just paste these contents so that we should not use this port. This is the node port. All right, and I will clean up the file, and I will add my own content, the configuration I mean to say. So you have to change the IP address here. Don't worry, I will share every file so that you can do it on your virtual machines or on your local. So what is the IP address of the worker node? I will get it from here, and I will copy it. And what was the node port? So I will get from here, and I will copy the node port. And now our Nginx will route the traffic on this port to port 80. Okay, so this is some additional step, and I will just run service Nginx restart, and I hope that everything should be good. Now if I remove the port and run, okay, our Nginx is now running on port 80. I can run it in a different browser as well to make sure that it is not from cache. So okay, so our Nginx web server is running on our worker node on our Kubernetes cluster. So guys, now you can see this is our Kubernetes cluster, kube control get nodes, and we have one master node and we have one worker node. So that is actually the same practice you have to do to add more worker nodes. Make sure that when you initialize your Kubernetes cluster, you save this Kubeadm join command, okay, so that you can later run it on your all worker nodes. That is actually important. But what if you lose this command? You can run this command as well. You can use it, Kubeadm token create, and it will share the token and the join command again if you run it on the master node. If I run it, okay, you can see I have got the Kubeadm join command. Now I can save it. So don't worry, I will share each and every command and file with you guys so that you can create your own Kubernetes cluster with one master node and with one worker node. Alright guys, that's it for today's lecture. You saw that we created a master node and we had a worker node. Both virtual machines were created on my AWS account. So you have to create 2 virtual machines or 3. That is totally up to you. So the practice is the same. If you have one master node and one worker node, you will learn a lot from this practice as well. So I have one master node and this one worker node in the same VPC, in the same security group and internet, etc. Everything, so that their communication, there are no issues and everything should work without any issues. After that, on master node we installed container and we also installed container on the worker nodes, and these commands you can run on both master and worker nodes. And finally, on the master node we initialized our Kubernetes cluster. This command should run on the master node, and after that we configured, we set up our worker node, and finally we joined our worker node with the master node. And also you saw that we deployed a simple Nginx server on our worker node. So that's it for today's lecture. I will watch you in the next lecture where we will cover more kube control commands. We had already discussed 50 kube control commands, and you saw that Kubernetes CLI is a must learning tool. You have to learn kube control commands, each and every command, to create pods, to get deployments, to get services. So I will have a list of more kube control commands, and we will have around 60 to 70 in total. So make sure that you subscribe DevOps Molvi. We are going to learn more about Kubernetes in our this free Kubernetes course for beginners. Have a good one. Bye. Hey guys, I hope you're doing great today. This is our chapter number 44, in which we are going to discuss about YAML in Kubernetes. Guys, first of all, I would like to apologize for the delay in today's video. I was not feeling well for the last few days. That's why I couldn't upload a video lecture in our DevOps Roadmap playlist. So I apologize for that. Today we are going to talk about YAML in Kubernetes, because we are going to deal with the YAML configuration files in Kubernetes a lot, because we are going to create deployments, StatefulSets, services, Ingress, and pods using YAML configuration files. Now, what is YAML? So let's get started. And before getting started, make sure that you have subscribed DevOps Molvi on YouTube, and I really appreciate your support. So let's begin with YAML in Kubernetes. Guys, in order to understand the YAML, the core concept of YAML, why do we need YAML? I would like to share that example with you. We run disk free, df command, to know the disk usage on our Linux virtual machine. But when we run disk free command, df command, we get the values, but not with any idea that the disk space is 1, 2, 3, 4, 5, and these are just random values, 6, 7, 8, 9, 10. Okay, but we don't have MB or GB or KB. We don't know. So when we run df -h -h, and then the value can be 1.23 M or 2.2 G or 1.0 K. Okay, so what does this H switch mean? It converts, it makes these values in a human readable form so that we can easily read. So we can easily get to know how much disk space do we have on our Linux virtual machine, right? The purpose of sharing this example is that it is really hard for us if the data or the configuration files are not in human readable form. And that's what YAML does. That's what JSON also does. And that is actually the core purpose of YAML. It makes the configuration files human readable. So we can go through the YAML file and we can get to know that we have two stateful sets in this configuration file. We are going to deploy that many pods. We are going to deploy Nginx deployment. So that is the purpose of YAML. It makes it easy for DevOps engineers, for us, so that we can easily read out the configuration file. And guess what? We don't use YAML in Kubernetes alone. We also, if you remember, we have also used YAML in our Docker Compose lecture. Docker Compose dot, we have Docker Compose .yaml, right? We have used YAML file in GitLab CI, and we have also used the YAML in our GitHub Actions CI/CD pipeline, right? So YAML has a lot of importance in DevOps, because YAML is the only language that makes it easy for us to go through the configuration files. We can create new configuration files using YAML language. So YAML stands for YAML. YAML stands for yet another markup and language. Okay, so that is actually the abbreviation of YAML, yet another markup language, or also it stands for YAML ain't markup language. YAML ain't markup language. This is also the the abbreviation of YAML. So YAML stands for yet another markup language, and it is an easy, human readable friendly language, so that we can write configuration files in our DevOps routine jobs for DevOps tools like Kubernetes. We can also use YAML to write Docker Compose files. We can also use YAML configuration language to write our CI/CD pipelines using Circle CI, GitHub Actions, and GitLab CI. So YAML stands for yet another markup language, and the extension of all these YAML configuration files can be .yml, or it can be .yaml. It can be .yaml and it can be YAML.yaml. So guys, this is the general introduction of YAML. We have also gone through YAML configuration files while we had CI/CD lectures, and also we discussed YAML in our Docker Compose lecture. So now we need to understand that how we can write, or how we can easily understand a YAML configuration file in Kubernetes. Guys, there is really important to know that YAML is a syntax based language. Okay, so for instance, if I have this configuration file, for example, it is my cluster.yaml file. Okay, YAML. This is cluster.yaml file. So it contains a couple of data, metadata, and etc. So why it is a syntax based language? Because an extra space can cause your YAML file not to work. If I have extra space, or if I have any extra colon or semicolon, etc., so I have stronger chances that my YAML file, my YAML configuration file will not work. So extra spaces, extra semicolons, colons, or any other random configuration will not work in the YAML file. So that is why it is known as a syntax based language. We have to take care of our syntax, and guess what we have? It is one of my favorite tool, and it is known as YAML lint. YAML lint. So if I write a YAML file myself, I can paste the content in YAML lint. I can search, we will practically see, and this YAML lint will tell us that this configuration file, this YAML file is 100% perfect. There are no extra spaces, there are no extra semicolons or colons or any extra configuration that is not needed in your YAML configuration file. So it is 100% okay. And if there are any issues, this YAML lint tool will tell us that, man, you have to fix your YAML configuration file. It is having an issue on that line number or that line number. So that's why we must use YAML lint tool so that we can have a better idea that our configuration file does not have any issue. So that is why YAML is really sensitive and it is a syntax based language. Now let's see what are the core components of a YAML file in Kubernetes. Guys, in order to make it simple, I will write a simple configuration file with its core components so that it is easy for you to understand real quick. For instance, if I have this namespace dot YAML, guys, and let me share a really great tip with you that when we are writing configuration files in YAML for our Kubernetes cluster, it is a recommended practice that we must divide the YAML file into sections. If you don't understand it, let me explain. For instance, we have a namespace in our Kubernetes cluster. So we must have a separate namespace dot YAML file. We have a service and we must have service dot YAML file. And if we have a stateful set, then we must have a StatefulSets sts.yaml file. If I have been using NodePort or cluster any other service, then it is a recommended practice that I can use NodePort.yaml. So these are a couple of examples, and when I have these YAML files in a single directory, it would be really easy for me to understand quickly what do I have in my Kubernetes cluster. Okay, I have this for my namespace, this for service, and this is for stateful set, and this is for my NodePort. So I can easily go through these YAML files and I quickly learn what do I have in my Kubernetes cluster, instead of having a whole and large YAML file. And it is possible that I have all of that content in a single YAML file, but it would be really hard. It would be difficult for me to understand because that YAML file would get bigger and bigger and bigger. So it is a good and recommended practice that we must have separate configuration files. In the beginning, as a DevOps beginner, we must define, we must create, and that's what we are going to do in our lab. We are going to have different YAML files. Now, if I have this namespace.yaml file, then what do I have in this YAML file? So let's break it down, the core components of a Kubernetes YAML file. So most of the YAML configuration files in Kubernetes start with this API and API version. Okay, you will see it in all of our Kubernetes YAML file, and the version is v1. We are using the version 1 of our Kubernetes API. So API version v1, and after that kind, right under API version, kind. If I write kind here, this YAML will not work for me. That is why it is a syntax language. I have to take care a lot while I'm writing the configuration files of additional spaces, etc. And now, what is kind? What do we mean by kind? A kind can be a namespace, a kind can be a service, a kind can be deployment, a kind can be pod, a kind can be daemon set, a replica set, a service, etc. So all of these are kinds. Okay, now if I am going to write another YAML file for service that I will be writing in front of you, then the kind would be service, the kind would be stateful set, the kind would be NodePort. So now in my namespace.yaml file, my kind is namespace. I am going to define the namespace, okay? And after that, metadata. Metadata. And now what do we mean by metadata? I have defined that my kind is namespace. So I have to share some additional details about my namespace. Its name, okay? So metadata can be name. If I want to share the name of my namespace, DevOps Elasticsearch, okay? We are going to create an Elasticsearch cluster. DevOps Elasticsearch. Now this would be the name of my namespace. Alright guys, now you understand. This is how we write YAML configuration file. Now this is actually the simplest configuration file in YAML, and we have API version, we have kind, it is namespace, we can have kind as pod, we can have kind as deployment, and the metadata. Metadata means that if there is any additional information that you would like to share about your resource, and I have shared that the name of my namespace is DevOps Elasticsearch, okay? So that's it. That is the example of a namespace YAML configuration file. So we are done with namespace.yaml file. If you have any questions, please write down in the comments and I will answer. Now we are going to write a sample configuration YAML configuration file for our service. For instance, I am going to run Elasticsearch. This is for my Elasticsearch cluster, and I am going to define a service.yaml configuration. A service is actually the logical grouping of pods, and we define service so that our clients can access our pods. So I will modify this configuration file and my kind would be now service. If I am going to write any configuration file for pod, then the kind would be pod. For deployment, the kind would be deployment. I hope that you understand this concept. What is kind? And after that, guys, metadata. What is the name of this service? And also we are going to add some more additional specs, SPEC spec. So the metadata can be, I will write this as my ES service. So the name of my service is ES service. And also I will add that the namespace is namespace is DevOps Elasticsearch, the namespace that we have created earlier, DevOps Elasticsearch. And also if I want to add some labels, okay, I can add labels that this application is app is ES cluster. So this is my Elasticsearch cluster. So the name of the application is ES cluster. And now there is an important configuration that we have to add in this YAML configuration file. And it is actually spec, S-P-E-C, specifications, or you can say that additional specifications, additional data about the service. And since we know that a service is a logical grouping of pods, that's why I will use spec and I will write as selector that you have to use or you have to select the pods from where? From this app. And then I will write as app colon ES cluster. Now this is the specification of this service and it will select all the pods that are running under this label ES cluster. Since we know that a service is the logical grouping of pods, all the pods are grouped into a single service. Now I have used this selector so that it must know that it has to select all the pods that are running in this label. Okay, so every pod that is under this label is going to be selected. And now after that, I have to define the type of the port type, and the type can be NodePort, the type can be ClusterIP, and the type can be LoadBalancer, the type can be external name. So we have four types of service in Kubernetes. I'm going to use NodePort. Why? Because NodePort is used to expose the port of our service, Elasticsearch service, to my external user. Now after that, I have to define the internal and external port. The internal port where Elasticsearch runs on is 9200. I have to explicitly write all those ports for internal communication and also for external communication. So type would be NodePort. Why? Because I want my users to access my service using NodePort. NodePort is actually a service type which allows our external users to access the service. Okay. Similarly, we have load balancer, we have ClusterIP. So I will write the rest of the configuration here, and I will just add some ports. Okay. So we have a couple of types of ports here, and I have this port. For instance, this is 9200 for Elasticsearch, and I can define target port as 9200, and I can also define node port for my cluster as 31235, etc. So that's how, guys, we can define the ports. Okay, so this is an example of a service, and I have given the example of Elasticsearch which runs on port 92. Similarly, if I have service as Nginx, then I can use the port 80 here. Okay, I hope that, guys, now you understand. This is the API version. Kind as service. Earlier we had kind as namespace, metadata, name of our service, namespace, and also the labels, so that all the pods are under this label, ES cluster of this service. And now we have to define further specification. This is more, we are going to modify, we are going to extend our YAML file, and we have added selector that all the pods in this label should be grouped together in this service. And after that, we are going to expose our service for our external user. That's why we are going to use the node port. And after that, for node port, we have defined some ports. This is the port for my Elasticsearch service, and I want all my traffic to be routed to this port 9200. That's why I have used target port. And finally, I have defined the node port as 31235 so that I can access this port on all my cluster nodes. So this is the example of a service.yaml file. And by the way, guys, I told you that I can define everything this in a separate NodePort.yaml configuration file as well. So instead of creating a separate file, I have defined all the specifications in this YAML configuration file. Now talking about the StatefulSet.yaml file, if I write sts.yaml file, the name of my file would be sts.yaml. Okay. Now my kind would be StatefulSet. Instead of service, instead of namespace, I will have StatefulSet. So this is the kind. The API version would be v1 StatefulSet, and we create StatefulSet for stateful applications. Okay, those applications that need persistent storage. And we can create DaemonSets and replica sets for stateless applications that do not need any persistent storage. So that's why we have StatefulSet for those applications which are stateful, which needs a persistent storage. So for those applications which need persistent storage, we can define StatefulSet. And if these applications are stateless, then we can use replica sets or DaemonSets. So the kind would be StatefulSet. And now For metadata, I will change from ES service to let's say that ES cluster. Namespace would be the same, DevOps Elasticsearch, and label would also be the same as ES cluster. Now we have to add some more specifications according to the stateful set. Okay, these specifications were regarding the service. Now we are going to change these specs as per our stateful set. So in stateful set, we can define containers. Okay, and now the name of the image which is used to build to run our containers. Okay, so I will write the image here, image, and the name of the image like my test image, my ES image. And since it is a stateful set, so we can mount the volumes as mount volume, data, etc. And also we can define mount path. So we can define the mount volumes, we can define the data and mount path. All of these are actually the requirements of a stateful set, since it needs a persistent storage. And one of the key important thing that I forgot, sorry, we have to define the number of replicas. Okay, my bad, number of replicas. If I define as 2 replicas, then it means that there would be 2 identical number of pods. And if I define as 3, we can change them later. And if I define 4, then there would be 4 pods in that. Then there would be 4 replicas. It means that there would be 4 pods, identical pods, and each pod will need a persistent storage, and each pod will use this image to run the container. So for storage, I have to define as volume claim templates. Okay, templates. And here I have to define the storage so that each stateful set should get that amount of storage. And storage class, like storage class can be standard, storage class standard. And also the disk usage request, I will, since it is volume claim, I will add request, and here I will define the storage as 5 GB. So if I have 2 replicas, it means that there would be 2 identical pods, and all those pods will get 5 GB of storage. And don't worry, we are going to practically execute these YAML files on our Minikube cluster. So we have replicas as 2. So it means that our 2 pods in that stateful set will have 5 GB of disk usage. So guys, this is a general example of a stateful set.yaml, which is a configuration file. And now I hope that you have a better understanding of how a YAML file in Kubernetes looks like. So we have API version, we have to define the kind can be namespace, kind can be pod, a stateful set, a replica set, deployment, service, NodePort. All of these are actually kind that we have to define. It is a must in our YAML file. And after that, the metadata, name of your kind, I have defined as ES cluster, the namespace, and also additional information like labels, app. And in stateful set, I have defined that my replicas, identical pods should be 2. We can also upscale or downscale. We can upscale to 4 or 6 stateful set, and we can downscale by writing, by changing or modifying this YAML configuration. And after that, additional specifications like container and the image, Docker image, which is used to run that container. Okay, and also since we have stateful set and Elasticsearch cluster and we need the data, so we have to define the mount path. Okay, it is similar that we defined in a Docker Compose or in a Docker container. So we have to define the mount path, and it is mount volumes, and its path And after that, volume claim types, it is actually PVC, persistent volume claims, and storage class is standard. We have the request for storage of 5 gigabyte, 5 GB. So we have actually two replicas. It means that each pod in that stateful set will get 5 GB of disk usage. So that was the example of the YAML file for a stateful set. We saw the example of namespace and service, and we can define a separate for NodePort, and we can have a separate YAML file for stateful set. So we have divided our whole Kubernetes cluster into small YAML, into separate YAML configurations. Now it is better for us to understand that we have a separate namespace YAML, we have a separate service, stateful set, and NodePort. So I would say that it is a good practice. So what do you think that if I had everything in a single main.yaml file? So if I had a main.yaml file, main.yaml, and I can define everything, namespace, metadata of stateful set, and also NodePort, and also service in whole in one main.yaml file as well. It is possible, but it would be for beginners, for DevOps engineers like us, it would be some sort of overwhelming, and also it would get a bit difficult to understand. So that is the practice, and I hope that you are going to follow. Now let's see our YAML files in action on our Minikube cluster. The lab begins. Alright guys, now you can see that I have opened my Kubernetes by DevOps Molvi GitHub repository. By the way, I have been sharing this link in every Kubernetes tutorial on my channel, so you can navigate to this folder, okay? And it is my own cluster, Elasticsearch cluster. So I will click on it, and you can see there are a couple of YAML files. So first of all, if I open namespace.yaml, you will find each line with a brief explanation. For instance, now you can see API version specifies the API version. For the resource, kind is namespace, and metadata, the name of the namespace, which is DevOps Molvi Elasticsearch. Alright, so similarly, I have another YAML for Elasticsearch service, okay, that we have already discussed. And now you can see we have the kind as service, API version, metadata, the name of the service, ES cluster, the name of the namespace, labels, and specification for the service. Okay, so you can see that I have this selector and app ES cluster, and it matches pods with this label. Sorry, I have to zoom. Let me zoom it so that you can see it. Now I hope that you can see it. Specification for the service and selector and matches pods with this label, and this is the type of the service, NodePort. Okay, you can see it. And also I have defined all the ports, port 9200, target port, NodePort, the protocol, and the port number for external port for internal communication. Similarly, if I navigate to ES main cluster.yaml file, where I have all the specifications for my stateful set and every information, every configuration that is required for a stateful set to create a two replica stateful set. Now you can see I have this API version, the kind is stateful set, and the metadata and namespace. Now guys, you have to make sure that every component of your Kubernetes cluster is within that namespace, and the namespace is DevOps Molvi Elasticsearch. So you can see that I have been using this namespace in my service.yaml file, and also in my namespace.yaml file, and also in the main cluster.yaml file. So every resource that I'm going to create would be in that namespace. So you have to make sure that you're using the correct namespace within your whole Kubernetes cluster configuration. This is really important. Now you can see the specifications for this stateful set, the service name that I have used here in esservice.yaml. It is the same as elastic es cluster, and replicas with number of pod replicas. Okay, 2. If I am using 3, then there would be 3 identical pods, and similarly for 4, for 6. And you can see the selector here where my app is es cluster, the same app that I have defined in the service.yaml file. And also I have other metadata regarding my stateful set, and the most important part is the container. Okay, the Docker container that I would be running and its image. So you can see the name of the container is es container, and image that it will pull, this is actually a custom image, and I have created this custom image with all the prerequisites, with all the pre-configurations. So I've been using this Elasticsearch container image for creating my own containers, and the resources that I have given to this container. And also you can see that I have used all the ports for the containers. Now these ports are actually for the container, and also the volume mounts where my volumes would be mounted into the container, and its mount path to mount the volume. Okay, and after that there are a couple of other configurations that are relevant to the Elasticsearch cluster, like the cluster name and the network host. So you don't have to worry about it because I have explained each line with brief explanation, like this is cluster name and the name of the Elasticsearch cluster, this is the name, and also the network host binding, and I have bound it to all the network interfaces. 0.0.0.0 mean that bind to all network interfaces, and this is actually the name of our Elasticsearch node, and also the value from delivered dynamically, and all the lines, all the configuration, each line is explained so that you have a better idea what's going on. So these are actually the values regarding my Elasticsearch cluster. Since it's a stateful set, I have to define the persistent storage for each pod. And you can see that I have volume claim templates here, and I have this metadata, and also I've told you that we are using the storage class as standard, and the each pod will get 5 GB of disk space. So I have defined the volume claim templates here, and now let me open, and I have pasted all the configuration YAML configurations here in my Elasticsearch cluster. So it is my mini cube Elasticsearch cluster. And guys, first of all, let me tell you that kube control get namespaces, and you can see that I don't have any namespace with DevOps Molvi Elasticsearch. So first of all, I will run kube control. Let me clear the screen. Kube control apply -f and namespace.yaml, and now you can see that my namespace has been created. Okay, so if I open this file namespace.yaml, I have copied all the file, all the content from my GitHub repository, and you just have to take the clone and you can run. These files are fully functional. You won't face any issues configuring your own Elasticsearch cluster with a stateful set of replicas as 2. Okay, and if I search again, I will run kube control get namespaces. Get namespaces, and now I should see my new namespace as DevOps Molvi Elasticsearch, and it has been created and active 44 seconds ago. Right now, if I open ES service, and you can see I have this kind as service and name as Elasticsearch ES cluster, the namespace and all the ports. So again I will clear kube control get services -a all namespaces. So these are the services that have been created earlier when I run the Minikube cluster. Now I will create my own Elasticsearch cluster service. So I will run kube control apply -f es service.yaml. All right, we have this service in my namespace DevOps Molvi Elasticsearch. So I will run kube control get svc. We can also run svc. It stands for service, and namespace name -n, and I will run DevOps Molvi Elasticsearch. And okay, we can see that our Elasticsearch cluster service with type as NodePort has been created, and it is running on these ports. Okay, all the ports information you can find it here. And after that, now I will run kube control get statefulset -a, and there are no resources. And if I run as DevOps Molvi Elasticsearch in namespace, there are no stateful sets in this namespace as well. So I will, first of all, let me show you what do I have in this ESSTS stateful set. It is actually ES main cluster. Okay, I have renamed it here, and you can see I have every information regarding my stateful set with volumes, etc. Everything is given here, and every line is explained briefly so that you can clear your concept. What is that line doing here? Okay, so first of all, by the way, kube control get pv persistent volume -n DevOps Molvi Elasticsearch. There are no persistent volumes, and also there are no persistent volume claims in this namespace. Now if I run this stateful set YAML configuration file, you will find here that we have created persistent volumes in that namespace. So let me run it. Kube control apply -f ESSTS.yaml. All right, I have created my stateful set in this service. All right, now if I check kube control get stateful set -n DevOps Molvi Elasticsearch, and I should be able to see that I have created this stateful set with two pods, and they're actually in the initialization phase, and it will take a couple of moments. And if I run kube control get pods -n DevOps Molvi Elasticsearch, now you will find that my pods should be in the initialization state. Okay, now you must be surprised or thinking that from where I got this name and naming convention, etc. So I have already shared it here. That's why it is really important to understand the YAML. I have this name here. Okay, so these are the values. All the values have been given here, and I have these pod names accordingly. Okay, now you can find the difference that pod is initializing. Since it is downloading, it is pulling, the container is pulling the image, so that's why it takes a bit time. Okay, you don't have to worry. And now we are in the pod initialization phase. All right guys, finally my pods are now running, and you can see that after the initialization phase has been completed, now the pods are running. I'm sorry, you know that internet service is a bit sluggish in here in Pakistan, so that's why it took a little while. It took a little more time pulling images and then running my pods. Okay, now you can see that I have two pods, okay, because the stateful set has two replicas. And guys, if you're worried about the kube control commands, you know that I have already shared two lectures with you covering around 80 plus kube control commands. So I have these commands here on my GitHub repository. So if you want to know how I can see the number of pods, or if I want to update the number of replicas and how I can roll out changes, I've already shared all these commands about stateful sets, rolling out changes, deleting pods, and you can see kube control rollout status ES cluster. So you can follow this document and you can learn all these kube control commands. So finally, my stateful set is running, and I can also get into any pod. For instance, if I want to SSH, I want to connect with any pod, then I can run kube control exec. Make sure that you remember all the commands. Okay, it's a good practice. And minus IT interactive and the name of the pod. Okay, ES cluster 0 and minus N namespace name DevOps Molvi Elasticsearch, and the command that I would use to enter into the pod. Okay, bin bash. Alright, I am in the pod ES cluster 0. Okay, and similarly, if I want to see that if my Elasticsearch is running or not, I can run curl localhost, and the port is 9200. Make sure that you remember it. 9200 colon 9200, and you can see that my Elasticsearch is running. Similarly, if I want to see the Elasticsearch on my another pod, which is Elasticsearch ES cluster -1, okay, and I am in, now you can see that I am in ES cluster -1 or -1, which is my second replica, second pod in my stateful set. And I can see curl localhost colon 9200, and Elasticsearch should be running here as well. And you guys know that this is the mount path. Okay, so that was about the stateful set. And if I exit, you can run all these YAML files, you can execute, you must run these YAML files, you must learn the structure of YAML in Kubernetes cluster. So I have shared everything, every detail that has been possible for me in all these YAML files. And if you want to, if you are facing any confusion, you just see the comment. Okay, I have commented out each line one by one, and you can find brief description of each line in each YAML configuration. So I hope that it would be a big help for you to learn the YAML in Kubernetes. And it is a must to learn about YAML, because you are going to configure, you are going to build your Kubernetes cluster and the infrastructure like pods, deployments, replica sets, daemon sets, stateful sets in a Kubernetes cluster in your DevOps engineering position. So that is why, guys, I have tried my best to share each and every possible detail. And also, guys, I have tried my best to teach you the YAML line by line. Okay, I hope that you will like this lecture, and if so, make sure that you subscribe DevOps Molvi on YouTube and appreciate and support my channel. In the next lecture, we are going to have a quick discussion on the difference between daemon sets, replica sets, and stateful sets. It is also one of the important concepts and one of the best lectures that you will have on DevOps Molvi YouTube channel. I will see you in the next lecture. And once again, my apologies for being a little late in uploading this video. I will see you in the next video. Have a good one and bye. Hey guys, I hope you're doing great today. This is our chapter number 45, in which we are going to highlight the difference between a replica set, a daemon set, and a stateful set. Guys, I hope that you have heard their names and you might know their differences, but as a DevOps engineer, while we are studying about Kubernetes, we must know what is the difference between each of these sets. What is a replica set? What is a daemon set? And what is a stateful set? But before we get started, make sure that you have subscribed DevOps Molvi. So let's begin with their difference. What is the difference between a replica, daemon, and a stateful set? But first, we must know what is a stateless application. Stateless app, and what is a stateful app? And the difference is literally super easy. The stateless applications are those applications which do not retain their data. It means that they do not need any database or any persistent storage. Whereas while talking about the stateful applications, these applications actually have to maintain, have to keep, have to store their data, and therefore stateful applications need a persistent data storage. So the stateless applications, these applications do not retain any information. They do not store any data. Whereas in stateful applications, the data is stored somewhere, like in Kubernetes. If we talk about Kubernetes, we have etcd where the data is stored, and etcd cluster is used as the database cluster in Kubernetes. So for stateful applications, we need a persistent volume, persistent storage, and in stateless applications, we do not store the data, and that's why these are known as stateless applications. Where the data storage is required, those applications are known as stateful applications. And in the light of their difference, guys, stateless versus stateful, now we use replica set and daemon set. Okay, both sets are used for stateless applications, and stateful set, as the name says, it is used for stateful applications. So while we create a stateful set, we are going to see in our lab session that we will need a PVC, persistent volume claim, and a PV attached to the pod. Whereas we do not need any persistent volume claims or persistent volumes while we create a replica set and a daemon set. So that is actually one of the biggest difference between a replica and a daemon set and a stateful set. These two sets do not need any data storage solution, okay, or they do not need any persistent storage, because they are mostly used for stateless applications, and stateless applications do not retain their data. So now we are talking about the stateful set. Stateful sets are for stateful applications. Now, as a DevOps engineer, you have to keep that in your mind, that if I am developing any application, whether it needs any data storage, if it needs data storage, then we have to create the stateful set. And if this application is just logging and for notifications, then we do not need any data storage, so we can use replica set or daemon set. Now there is also a difference between a replica and a daemon set that we are going to talk in this lecture. But first, I would like to highlight the key difference between stateless and stateful applications. Replica set and daemon sets are used for stateless applications, and stateful set, as the name says, it is mostly used for stateful applications. Stateless applications do not need any data storage, whereas we have to arrange data storage for stateful applications. Now proceeding further, I hope that you understand the key difference between stateless and stateful applications. Now guys, replica set, daemon set, and stateful set. First of all, we also know that these are known as Kubernetes objects. Okay, these are all known as Kubernetes objects. So someone talks about Kubernetes object, you must know that daemon set, replica set, stateful set are Kubernetes objects. They are also known as Kubernetes controllers. Okay, these are also controllers because they control how we deploy our pods, because the strategy in each of these set is different. And also these are known as Kubernetes workloads types. So these are also known as Kubernetes objects or controllers or workload types. Now we are going to discuss what is a replica set. Replica means a copy. This is the simplest definition of a replica. For instance, if I have this box, the replica would be the same box. And if we have 3 replicas, it means that we are going to have 3 same boxes. And in Kubernetes, a replica means that a same identical pod. This is the same pod, and this is also, for instance, this is Nginx, pod Nginx. And this is also pod Nginx. So guys, when we are using the replica set to deploy our applications, it means that the identical pods should run every time. This is actually a replica set. For instance, in my YAML, if I am using replicas as 3, so it means that there would be 3 identical pods that are always running to keep my applications up and running. So guys, we can also use replica sets directly in our Kubernetes YAML files, but the most recommended way is to use the deployment. Okay, when we use deployment to deploy replica sets, then we will have more features, we will have more control. So it is always recommended that we must use deployment for the replica sets. Now, if I want to show that how deployment works and how we can use the replicas, for instance, this is my deployment and I am using 3 replicas. This is deployment. We can also use replica set directly to deploy replicas, but the recommended approach is to use kind as deployment. I mean to say that when we use kind as deployment, then we will get more control, we will get more features, and we can roll out our updates using the deployment. And we can also use kind as replica set as well. But as far as experts' recommendation is concerned, we must use deployment as kind to deploy replica sets. Now this is a deployment, and if we have 3 replicas, it means that there would be 3 identical pods, Nginx, that are always running. And for instance, if I delete any of these pods, a new pod will be created automatically. Now this is actually a replica set, and there is no persistent volume claim or persistent volumes are involved or used in any replica set. So a replica set ensures that identical pods are always running on the worker nodes. And why I have used the example of Nginx, because replica sets are mostly recommended for stateless applications like web applications. Our web applications are stateless applications, and also we can use for stateless RESTful APIs as well. And guys, also replica sets are a best solution for upscaling or downscaling our applications depending on the load. For instance, if I need more pods, I can simply create more replicas. I can simply upgrade the number of replicas, and I can roll out the deployment again so that we will have more replicas created in that deployment. And when there is no peak time or our applications do not need additional pods, then we can also downscale our replicas and we can roll out the deployment again, and we will have only those pods running that can handle our application's workload. Now guys, talking about the daemon sets are also used for stateless applications. The difference between a replica set and a daemon set is that a daemon set always ensures that at least one pod should run on each worker node. For instance, if I have this is my Kubernetes cluster and I have 3 worker nodes. Okay, so this is my node 1, worker node 1, and this is my worker node 2, and this is worker node 3. So it means that when I use daemon set, there would be one pod, a copy of a pod will always run on each worker node when we use daemon set. So that is actually the simplest overview of a daemon set. A daemon set ensures that one pod should run on each worker node, and daemon sets are perfect for logging, monitoring, and also for security. And if we have any applications that we want to have monitored or secured, or if we want to have their logs, then we can use daemon set. A daemon set will ensure that that pod, now this is actually pod, same pods will be always running on each worker node. So for logging, we can deploy a FluentD pod. It can be FluentD on each worker node. For monitoring, we can deploy Prometheus, and for security, we can also deploy any security agent. So a daemon set will ensure that this pod should run on each worker node. If I'm using this for monitoring, so there would be a Prometheus pod running on each worker node. So that's why we use daemon sets for log collection, for monitoring, or for our security of the worker nodes. So finally guys, talking about the stateful sets are for those applications that need persistent storage. So if I'm using a stateful set, it means that I will have, for instance, this is my stateful set, this is pod 1, and this is pod 2, and this is pod 3. So each pod will need a persistent volume claim, PVC, and this also needs a PVC, and also for pod 3 a PVC, and there would be a persistent volume PV would be attached to each pod. And if you have watched my previous lecture on YAML, we have used stateful set, and we saw that we used stateful set to deploy our Elasticsearch cluster, and we used persistent volume claims for persistent data storage. So that is actually a stateful set. A stateful set is for stateful applications, for those applications that need a persistent volume. Just like we have used persistent volumes in Docker as well, we can use persistent volume claims in Kubernetes using stateful set. So a stateful set would be used, and each pod will get a persistent volume attached to it, and the data is going to be stored in these persistent volumes. So it means that if you are using any applications that is using MySQL or MongoDB, then we can use stateful sets to deploy our applications, and each stateful set will ensure that a persistent volume is attached to each pod. So guys, I hope that now you understand the key difference between a replica set, a daemon set, and a stateful set. A replica set ensures that identical number of pods are running at every time. If I'm using replicas as 3 or 2, it means that there would be 3 pods that are always running on my worker nodes. As far as daemon set is concerned, it ensures that one pod should run on each worker node, and it is best for log collection, for monitoring like Prometheus, and for also if we have any security agents. So a daemon set will ensure that each pod is running on each worker node. And for our stateful applications that need persistent data storage, we can use StatefulSet, and each pod will get a dedicated persistent volumes attached to it for data storage. And if we have applications that are using MySQL or MongoDB for data storage, then StatefulSet is the best solution. Alright guys, now let's check out the difference between replica, daemon, and StatefulSet in our lab session. Alright guys, this is my Kubernetes by DevOps Molvi repository. So I have told you that I will share this repository link in the description of each Kubernetes video. So far we have discussed everything about Kubernetes. We learned a lot of concepts, and I have been posting the YAML files. I have been uploading the data regarding Kubernetes cluster, how to install Minikube, Kubernetes kube control commands. So you can take the fork of this repository and you can save it, so that whenever you want to know about anything, I have shared it on my Kubernetes by DevOps Molvi repository. The Kubernetes lectures that we have covered so far, I have shared everything about it on my this repository. Okay, so there is the Google Docs, we have Google Docs as well, and Kubernetes, and also the YouTube video links. So guys, now I have opened my Minikube cluster. If you want to know how to install a Minikube cluster, I have this guide here as well, so you can use it, and it's a simple how to install Minikube, simple thing to do. And now I have these 3 YAML files. Okay, I will share them with you on my GitHub repository. So first of all is replica web.yaml. Now this is for creating replica sets, and if I open it, you can see that the kind is deployment. I can use kind as replica set, and the name is Nginx deployment of that deployment, and we have 2 replicas and we are using Nginx. So as I told you that replica set is best for using web applications, so I have used Nginx as the image, and it is running on port 80. So this is a simple YAML file, and you can just run kube control apply -f and your YAML file. So now kube control get deployments. You can see that we have this Nginx deployment that is running with 2 identical pods. Now I should have 2 pods running within this deployment kube control. By the way, I can also run kube control get replica sets, and you can see that we have 2 as desired replicas, and we have 2 as current and ready. So kube control get pods, and we have these Nginx deployment. We have these 2 pods that are running, and for instance, if I have to upscale my replica set, I can simply go into the deployment and I will have replicas as 3, and I will save it kube control apply -f so that our changes should reflect, and replica.yaml. So now we have configured. We have updated our replica, our deployment, by the way. And if I check kube control get deployments, now you can see we have 3 replicas. And kube control get replica sets, we have 3 as ready, and that was quick. So kube control get pods, now we should have 3 pods running, and now you can see. And if I want to downscale, similarly I will use replica, and I will have as replicas as 1. So I will have only 1 replica set in this deployment. Kube control apply -f replica.yaml, and now kube control get deployment. I can run deployment or deployments, both commands work. And now you can see we have only 1 deployment, and we should have only 1 replica or 1 pod. Kube control get replica sets, and similarly if I want to run kube control get pods, we have only 1 pod now. So that's how, guys, replica sets work. That's how we can roll out our changes in our YAML file, and this is pretty easy. Now talking about the daemon sets, we have this as daemon.yaml file. Now there are no replicas because daemon set ensures that 1 pod should run on each worker node. And now I am using FluentD. FluentD is used to collect the logs, and it is used to process the logs. So it ensures that daemon set will ensure that 1 pod of FluentD should run on each worker node. So for instance, if we have 12 worker nodes, so there would be 1 pod running on each worker node with FluentD, okay? So that we can get the logs from each worker node. So that is the YAML file, and now you can see the kind is daemon set, and this is the metadata and specifications. I am using FluentD latest image from Docker Hub, and here I am using the volume mounts, and I am using the mount path where our logs would be collected, okay? And this is the simple YAML file, and I can see the pods as well, and I can see the FluentD pod. Kube control get daemon sets. Now you can see we have 1 daemon set, and also kube control get pods. I can see this pod as running. So that's how we can use the daemon set, and it will ensure that 1 pod of FluentD should run on each worker node. So alright guys, now finally talking about the stateful set. Stateful set is used for stateful applications, and I have shared a complete YAML lecture in which we have already discussed stateful set in detail in this lecture, in which ES service, ES main cluster, okay? And we have this stateful set, and we deployed a replica, stateful set replica with 2 pods for our Elasticsearch cluster. So this is also on my GitHub repository. I would strongly recommend that you should run, you should practice, you should see how these YAML files work and how we are creating stateful sets. You can see we have volume claim templates, okay? And this is actually for stateful applications. We need the storage, we need persistent volumes, we need persistent volume claims, and I have given 5 gigabytes for each pod. This is the storage for each pod to store its data. That's why it is known as a stateful set. And here in this example, I have used stateful for MySQL database, and you can see I am using 3 replicas. I should have 3 pods, and I'm using this image. So this is the metadata for MySQL server, MySQL containers. And now kube control, okay, I will clear it. Kube control get stateful set. You can see we have three MySQL instance. We have three MySQL stateful sets, and similarly Kube-Control get pods, and I have three pods of MySQL that are running on my Kubernetes cluster. But if you want to learn more about stateful set, I would recommend that you must try out this Elasticsearch cluster on your Minikube cluster. You will have a better understanding, a deep understanding of stateful sets on Kubernetes cluster. So that's it, guys, for today's lecture. We uncovered the difference between replica, daemon, and stateful set. I hope that you will rock, you will answer this question whenever asked in any of your interviews, and it is also one of the most important interview questions and answers relevant to Kubernetes. So we must know the difference. These are workloads, these are Kubernetes controllers, or we can say these are Kubernetes objects that are used to deploy applications. A replica set ensures that identical number of pods are always running on our worker nodes. A daemon set ensures that one pod should run on each worker node, and a stateful set ensures that each pod should get persistent volumes for their storage. Replica sets and daemon sets are used for stateless applications, whereas stateful sets are used for stateful applications. If you still have any questions, I would be happy to answer them for you. Make sure that you subscribe DevOps Molvi. I will watch you in the next lecture. Have a good one and bye. Hey guys, I hope you're doing great today. This is our chapter number 46 of our DevOps Roadmap. And we are going to talk about a service in Kubernetes. What is a service in Kubernetes? And this would be around 12th or 13th chapter of our Kubernetes tutorial for beginners series. I have created a dedicated playlist for our Kubernetes tutorial for beginners. You can watch out all the Kubernetes related tutorials in this playlist. I would be creating a full-fledged course on Kubernetes. So guys, I think that this is my opinion that the service in Kubernetes is one of the most easiest and simplest concept in Kubernetes. If you have watched my previous lectures, you know that we created stateful sets. And in our YAML deep dive lecture, we also created a service, if you remember. So what is a service in Kubernetes? Before getting started, make sure that you have subscribed DevOps Molvi. So let's begin with the concept of service in Kubernetes. Guys, a service is used to expose our application internally or externally. That is actually the core concept of a service. For instance, in my Kubernetes cluster, I have one master node and three worker nodes. Let's suppose, okay? So every worker node is running pods, and my web application is running on all these pods. So I want my application, I want to test it internally on my worker nodes, and also I want to access my web application externally, let's say on a web browser over the internet. So how can I do that? My web application is running on all the pods, and I want to access my application, whether I want to access it internally or externally. I have to use service. A service actually groups the pods into sets, a logical group. So if you want to search out on Google, you may find a number of definitions of a service. But guys, let me explain it to you in really simple words. A service means to combine pods into a single resource, to group pods into a single resource. How? For instance, this is my worker node. I have three pods and I'm running a web application. So to access all my pods via a single endpoint. That single endpoint is known as a service. I hope that now you get it. This is pod 1, this is pod 2, this is pod 3. So typically a service is used to access what is running on our pods. We can use a service to access our application that is running on our pods internally or externally. So that is actually the core concept of a service. So for instance, you have a Kubernetes cluster with 3 master nodes and 12 worker nodes for high availability. And there are pods running on each worker node. And you have a web application running on all the pods on each worker node. And you want to test your service, so you want to access it internally on the cluster or externally on the web browser like Chrome. So what would be the mechanism that you can access your web application that is running on all the pods or any kind of service? We can have multiple microservices that are running on all those pods, and you want to test your services, whether you want to test them internally or externally. You need a mechanism. You need a service. A service is used to give you an endpoint, a stable network connection. So in case 2 of your pods are failed on one of the worker nodes and one of the pods on this node has changed its IP address. So what would happen? That is the responsibility of the service, so that it gives you a stable endpoint, a constant endpoint, so that you don't get any disruption accessing your service. So you don't have to worry about your pods, whether they scale up or scale down, whether the IP address of all the pods gets changed. You will get a constant endpoint, and that is actually the service. So let me write what I have told you, that a service is an endpoint. Okay, whatever runs on pods, you can access your app which runs on the pods, running on pods both internally and externally. I hope that now you get it. So if my pods have changed the IP address, but I will have a stable, just like we have a static IP address of the service. So we don't have to worry about our pods changing the IP address. And also you get a stable and permanent network, regardless of the pods changing their IP addresses. So you will get a static IP address in your service. And also a service is used for internal and external routing. So these are the 4 key points of using a service in Kubernetes. Service is an endpoint where users like me or you access their applications which run on pods. Okay. Number 2, access your applications running on pods internally and externally. Whether we want to access our applications within the cluster, we can use a service type known as ClusterIP. And if I want to access my applications externally over the internet, I can use a service type known as a load balancer. And also we get a stable permanent network. Our IP address would be static and it will never change, regardless of the pod's IP addresses. If they keep changing, we will get a static IP address using the service. Okay. And also for internal and external routing, we can also use service. So these are the key features of using a service, and the core concept is to access your applications internally or externally. We use service. Okay, I hope that now the concept of service is clear. Now let's move ahead and discuss the types of service in Kubernetes. There are ideally 5 major types of service in Kubernetes, but we are going to discuss the 3 most important and most frequently used services in our DevOps journey. So the first type of service in Kubernetes is ClusterIP. IP, and this is actually the default service. When we run kubecontrol get svc or get service, we get a cluster IP service already created. So what is cluster IP? This type of service is used for internal communication, right? For instance, this is my K8s cluster, Kubernetes cluster, and I have a namespace, and my namespace is ES, okay, Elasticsearch. Since my demo is related to Elasticsearch, so the name of my namespace is Elasticsearch. So I will be creating my service and my pods in this namespace, and I have 3 pods that are running. This is pod 1, this is pod 2, and this is pod 3. And here, this is my service. Okay, this is my service, and all these pods are logically grouped into this service. Okay, so the service port is 9200 and the target port is 9200 as well. So we will have target port running on our pods. Okay, this would be 9200 target port. Okay, TP, and this would be our service port. This port will also be 9200. This is my service port. And finally, this is my browser, and I will not have any external access while I'm using cluster IP as a service. Okay, so there would be no external access. My service would be only accessible internally on this service port 9200, and this is the same target port on all of these ports. Now if I run kubecontrol get service command, we will get a service that is created on our Kubernetes cluster. We are going to do it in our lab, but the core concept is that in cluster IP we don't have any external access. This would be our service that has grouped pods into a single endpoint. Okay, and I am using only 2 ports. This port means that the service port, which also runs on 9200, and target port is also the same, which is 9200, that each pod is using. So this is the simplest illustration, you can say, or explanation of a cluster IP, which is used for only the internal communication in a Kubernetes cluster. Now talking about the node port, I will modify this diagram, and this would be the node port, second service in a Kubernetes cluster, and it is used for external access. First of all, we should know that a node port exposes our application externally. Now I would be able to access my service using the node port. So I will add the node port here. Now we will have an addition here. So we need to update our YAML accordingly. Node port. And what would be that addition in our YAML file? I will add the node port here. Okay, I hope that now it is clear. Node port can be 30,007 or so on. Any node port that you want to expose. So my application would be externally accessible on this port. So I'm using 30,007 as my node port. So it means that on this port, my application would be accessible externally. So that is actually the purpose of node port. If you want to expose your application for the external users, you have to use the node port. And if you don't want to expose your application and you just want to test it locally or internally, you can use cluster IP. So how can I check that my application Elasticsearch is accessible externally? I can use the worker node's IP address. Okay, worker node IP address, and I can use curl command as curl node IP. Okay, this is my node IP colon node port. So that's how I can check that my application is accessible externally using a NodePort. Don't worry guys, we are going to have a practical lab session on all of these services as well. And finally, let me tell you that we don't use NodePort in production environments because there are no load balancing features that we get in NodePort. So that is one of the biggest shortcoming, or you can say that NodePort lacks in load balancing. We cannot balance our traffic using the NodePort. So what service should I use if I want to balance my traffic and route my traffic equally on all the worker nodes and all the pods? So for that purpose, we have to use load balancer. Okay, now I will again modify it, and this third type is, sorry, I have to update. Third type is load balancer. And now I will have to add this load balancer here, load balancer, and I will remove my NodePort because we are not using NodePort for our production environment, and this load balancer directly communicates with our service. Okay, so whatever, now also I will remove the NodePort from here as well. So we can use the load balancer of any cloud platform like AWS or GCP or Azure. Okay, we will have to use load balancer of a cloud platform, and with the help of load balancer we can equally distribute our traffic on all of our worker nodes and also on our pods. So guys, not only load balancer facilitates the external access of our applications, we can access our applications externally over the internet on our devices. Also, load balancer service provisions automatically an external load balancer on our cloud provider. So now you should have a question in your mind that how load balancer service works. So when we use load balancer as a service in our Kubernetes cluster, the load balancer service assigns a public IP address or a full quality domain name to our service, and we can use this public IP address or the domain to externally access our service on our web browsers. That's how load balancer service works. So this load balancer service assigns a public IP address to the service, and we can use this public IP address to access our application on our devices. So finally, for production environments, we use load balancer so that we can externally access our applications, and also load balancer service equally distributes the traffic among the pods on the worker nodes. So finally, a cluster IP is used for internal communication. A NodePort is a service that exposes our application externally but not recommended for production use. And we can use load balancer as a service for our application to be exposed externally and also for load balancing our traffic. So everyone would recommend to use load balancer for production environments as a service. Now let's start our lab session and see each service in action. Alright guys, I'm on my Minikube cluster and I have created a couple of YAML files. And now we have a ClusterIP.yaml, we have a load balancer, and also we have a StatefulSet.yaml file. And also I have a NodePort.yaml file created. So each file is a bit different. In each file, we are going to create the respective service. So first of all, and also by the way, for your convenience, I have all these YAML files on my Kubernetes by DevOps Molvi repository, and I will definitely share the link of my repository. So make sure that you copy it, and you can execute these YAML files on your local Minikube cluster. So it is my Minikube cluster, and you can see that it is running. All right. Now, first of all, kube control get pods -n and this is my namespace. Okay, so I have a replica, a stateful set of 2 pods. Okay, this is my YAML files. I have been using these files again and again in all my demos, so you can get all these files from here. Okay, and it is my own cluster to create an Elasticsearch cluster on our Minikube cluster. Now you can see it is a stateful set. The kind is stateful set, and I have the metadata as name is Elasticsearch ES cluster. This is my namespace, and replicas are 2, and rest of the information, everything, configuration and persistent volume claims and the disk space for each volume, it is given in volume claim templates. Okay, so now first of all, let me go through the ClusterIP.yaml file, and we have this YAML file in which you can see the type is ClusterIP. Now this is, by the way, it is a default type of service. For instance, if I run kubecontrol get svc, now you can see that this is a default service created in the default namespace. And if I run kubecontrol get svc -n, so I have created a load balancer type of service. So first of all, let me remove it. I can delete kubecontrol delete svc, and I can give the name as Elasticsearch es dash cluster and my namespace. Now the load balancer service should have been deleted. If I run, now you can see I don't have any service created. So first of all, nano cluster IP. Okay, you can see this is the type of service, cluster IP, and this service is used for internal communication, and the port is 9200, and the target port on the pods is also 9200, and this is for, I've also briefly explained that this port is used for inter-node communication. Now I have only Minikube, so I have only one worker node. So if I have multiple worker nodes, this port would be used for inter-node communication. So each node can talk to the other node on this port. Okay, and rest of the data, metadata is same. The name is ES cluster, namespace name, and label. The label would also group the pods. Okay, the group of pods will have this label as ES cluster. Okay, so now I will run kubecontrol apply -f and cluster IP. Now my cluster IP service should have been created. Now you can see that the service has been created and the type is cluster IP, and this is the port information that we have. Now guys, I cannot access my service from my Minikube host. Now this is my actually the Minikube host, so it means that I am outside of my Kubernetes cluster. Okay, I'm not inside, and cluster IP is actually for inter-cluster communication, for internal communication. So that is why I cannot use my Minikube IP or the cluster IP to communicate with the Elasticsearch that is running on my pods. So what I have to do is I will use port forwarding option. So we will have 9200 as our local machine port, and we will forward this port to our Kubernetes service port. So both ports are same. This is the command and I will run it. Now I am using port forwarding. Now this is my local machine. Okay, and I will forward it to the service that is running on our Minikube cluster. Now I should be able to curl on localhost as localhost colon 9200. Okay, now you can see that I can listen to what is running on 9200 port inside our Kubernetes cluster. Actually, we have to use port forwarding so that we can forward our local port to the port of the Kubernetes service. Now guys, after that, in order to resolve this problem, if I want to externally access my service, so I can use the NodePort, okay? And in NodePort, we will have an additional external NodePort, and I will open it. And this is the addition, guys, okay? Rest of the stuff is same, just as ClusterIP. So I have added this port, and this would be my external port, node port. So I will run kube control apply -f node port, and now you can see that I should have kube control get svc -n and my namespace name Elasticsearch, and I have this node port. So now if I want to access it externally from my Minikube host machine, I should know the Minikube IP. I can find it with this command. And now if I run curl IP address, this is the Minikube IP address colon. Now here is the question, which port should I use here? I have to use the external port, node port. I cannot use 9200 port, okay? You can see that it is not accessible. So for external communication, I have to use the node port, and I have this node port as 30315. Now my service can be accessed externally from my Minikube host machine. I hope that you get it. So that's how, guys, we can access our service externally using the node port, okay? And if I show you again node port, this is actually the addition. So node port to access the service on cluster nodes. Now finally, guys, we have the LoadBalancer.yaml. Since I'm using my Minikube cluster, so it means that I don't have a public IP address at the moment. So what would be the solution in order to clear our concept regarding load balancer? First of all, we can see that the type is load balancer, and also there is a brief explanation that this exposes the service externally via a cloud load balancer. So first of all, I will create this service -f and load balancer. Now, okay, I will ignore it. Kube control get svc -n and my namespace name. Now you can see I have an external IP address as well. So it means that my load balancer service is working perfectly fine, and I have got the external IP. Okay, so that would be actually our AWS cloud or GCP cloud IP address. Okay, but for this, this is my local setup, right? I will use Minikube tunnel. Minikube tunnel will create a route between my local machine and my load balancer service. So I will run Minikube tunnel since it has been already running. Now, if I check my Minikube IP, I will use this IP address and curl localhost, this IP address colon and the node port 30315. So you can see that my load balancer service is perfectly working fine. Alright, guys, just winding up this lecture, you saw that we have three major types of services in a Kubernetes cluster: ClusterIP for internal communication, NodePort if we want to expose our application to the external user, and load balancer service for our production environments where we expose our applications to the external users, and also with load balancing our traffic and equally distributing our traffic on all the worker nodes and the pods. I will share all these YAMLs on my GitHub repository, so make sure that you go through each YAML file, you run it on your Minikube cluster, and in case of any issues or questions, you can ask me in the comments. I will watch you in the next lecture of our Kubernetes free course series. Have a good one, and bye. Hey guys, I hope you're doing great today. This is our chapter number 47 in which we are going to discuss one of the most important concepts in Kubernetes, and it is Kubernetes security. Guys, you know that every IT company or every IT organization is concerned a lot about the security of its infrastructure, the security of its users, the security of its data and servers and storage, etc. So, security is one of the most common concerns in every IT company around the world. So, therefore, when we are talking about Kubernetes, after all, we have discussed a lot of stuff in this Kubernetes playlist. We have discussed Kubernetes core components, kubectl, minikube cluster, cluster architecture, and now how can we forget about the security in Kubernetes? How can we secure our production Kubernetes clusters with every possible security practice? So first of all, let's talk about the security measures that we can take in Kubernetes. Okay, so what should be the security measures or the security mechanisms that we should observe while securing our Kubernetes cluster? So before getting started, make sure that you have subscribed DevOps Molvi. We are on the road to complete our Kubernetes course for beginners. So let's get started. So guys, mark my words, you are going to be asked about the security in Kubernetes. You are going to be asked that how you can secure your Kubernetes infrastructure, how you can secure your Kubernetes clusters, okay? When we are running Kubernetes in production, what should be the security measures that we can use so that we can secure our Kubernetes clusters as much as possible. So I'm going to share the 9 security hardening tips, or you can say that the 9 security processes that we can implement to secure our Kubernetes cluster. And the first one is rollback access, RBAC. Guys, RBAC stands for role-based access. Okay, role-based access. And if you remember my Google Cloud Platform lectures where we learned IAM, Identity and Access Management. We have discussed the IAM policies, we have discussed the IAM roles, we have discussed how we can implement any IAM policy or any IAM role, identity and access management role, on a user or a service account. And literally it is the same case here as well in RBAC, role-based access in Kubernetes. We can implement, we can create our policies, and we can create roles, and those roles can be bound to the service accounts in a Kubernetes cluster. And from service account, I mean the user. So role-based access is used to limit the permissions, okay? So each service account or each user will have a specific set of permissions attached to its account, attached to that specific user. So it is a must practice to create roles, and those roles can have the permissions, and those rules can be directly attached to any service account in Kubernetes. The second point is network policy. Network policies. We can have network policies to limit the pods communication. To limit the pods communication. Limit pod communication. And what is the purpose of using network policies? The core purpose of using a network policy is to control the traffic on any pod. And number 3 is secret management. Secret management. Guys, this would be simple and easy to understand. And what do we mean by secret management? Secret management means to store our passwords and Kubernetes API keys using Kubernetes secrets. So I will write here that we can store sensitive data using Kubernetes K8s secrets. And now number 4 is Kube-API server security. Kube-API server security. Guys, we know that Kube-API server is one of the most important component in a Kubernetes cluster because it manages the whole Kubernetes cluster. So we must secure Kube-API server using certificates or TLS encryption. I will write here certs using certs, certificates and TLS encryption. That's how we can secure our Kube-API server. After that, guys, number 5th point is container image security. Container image security. And why it's important to have our container images secure? Because after all, our applications run inside the containers, and those containers run on our pods, on the worker nodes. So it is really important to use those container images that are malware free, and those images should not have any vulnerabilities. So we must use updated and verified images from verified publishers like Docker Hub. And those container images should not have any vulnerabilities. So I will write that use trusted images. Trusted images which are malware free, and those container images should not have any vulnerabilities. So these are actually the 5 core practices to secure our Kubernetes cluster. Okay, we can use role-based access to limit the access for the service accounts for the users. Every user or a service account should have least privileges for our Kubernetes cluster. The second one is to use network policies, and it limits the pod communication, and this practice is used to control the traffic in a production environment. And number 3rd is secret management. From secret management, I mean to say that we should store our sensitive data and API keys using Kubernetes secrets. Just like we use secrets in GitLab CI or GitHub Actions, we can use Kubernetes secrets to store our sensitive data, and that sensitive data can be passwords or API keys in the encrypted format, not in any plain text format, okay? And number 4 is Kube-API server security. Since we know that Kube-API server is the core component of any Kubernetes cluster, so we have to secure it as much as possible, because the Kube-API server it manages the whole Kubernetes cluster, and therefore we must use certificates and TLS encryption for authentication to our Kube-API server. And number 5, best security practice is to use the container images which are malware free. Those images must be pulled from trusted registries like Docker Hub. And those container images should be up to date. I mean, they should not have any outdated libraries or plugins. So we must use trusted images for running our applications into the containers on our pods. So these are actually the 5 core and best security practices that we must use to secure our Kubernetes cluster. Now the rest of the 4 practices, because I told you that I will share the 9 best practices to secure our Kubernetes cluster. These are 5, and the rest of the 4 are related to monitoring, auditing and logging. So let's discuss those 4 practices as well. So the number 6th point is to use monitoring and detection. Monitoring and detection. And in order to monitor our Kubernetes cluster, we can use the trending monitoring tools like Grafana and Prometheus for the continuous monitoring of our cluster's activities. Number 7th point is audit logging. Audit logging. Let me explain it briefly as well. And for monitoring and detection, I will write to monitor using Grafana and Prometheus. And number 7 is audit logging. From audit logging, I mean to say that we can use this practice to secure our Kubernetes cluster, because the audit logs keep tracking our cluster's activity, keep tracking clusters activities. So we will have each and every activity that is going on with our Kubernetes cluster. And where we can find those audit logs, we can have those audit logs in var log Kubernetes K8s Kubernetes audit and audit.log file. So this file will contain each and every activity that is going on within our Kubernetes cluster, and we should keep checking out and auditing our Kubernetes cluster for any potential threats. And number 8 and second last point for our Kubernetes security practices is least privilege principle. Privilege principle. And from least privilege principle, I mean to say that to grant a user only those permissions that he or she needs to perform any certain task. And in IT companies, this is actually the most common practice, to give the least privileges to any user so that he or she can perform the required tasks. So I will write here that granting only required permissions, all right, so that the user can perform her or his tasks. And the last point is database or etcd security. Etcd security. And just like we secure our Kube-API server, which is the main component, and we have etcd, which is the database of a Kubernetes cluster. It contains every data regarding our Kubernetes cluster. So our data is actually stored in etcd. Therefore, we must also secure our etcd cluster or etcd database. And we can use the same practice to use TLS encryption or SSL certificates. Okay, SSL certs. All right, guys, in total we have discussed the 9 points. I have already repeated the 5 points that we discussed earlier, and these are more 4 points. I hope that you will remember at least 4 or 5 for your interview. So we can use monitoring and detection tools like Grafana and Prometheus to monitor our Kubernetes clusters in production. We can use the audit logs, which are stored in var log Kubernetes audit, and this file, it actually logs each and every activity. It tracks each and every activity that is going on within our Kubernetes cluster. So in case of any suspicious one, we can quickly go through the audit log and find and track what's going on, anything wrong with our Kubernetes cluster. So audit logging is one of the most important practices so that we can track each and every activity. And also, guys, second last point is least privilege principle. And this is one of the most common practices in any IT organization, to grant the user least permissions so that he or she can perform his or her task. So that's what about least privilege principle, giving any certain users only those permissions that the given user needs to perform the tasks. And finally, the database security. etcd means the database. It contains every data of our Kubernetes cluster, and just like we used to secure our Kube-API server using SSL certificates and TLS encryption, we must secure our etcd clusters using the same practice so that our data is encrypted, so that our data is secure in our etcd clusters. So guys, these are the 9 best practices. And if you are asked about how you can manage your Kubernetes cluster, I would recommend that you must learn these 9 practices, and these are the usual and most common security mechanisms that are observed to secure our Kubernetes cluster. Alright guys, now let's talk about RBAC, role-based access, a little bit more, okay? So what is RBAC? RBAC stands for role-based access. Okay, role-based access, RBAC. And it contains, actually, RBAC contains roles. Okay, and we have actually 2 major types of roles. I will break them down as role, and we have cluster role. Okay. Now, a role means the set of permissions. Okay. Role means set of permissions. And if we are using role, it means that this set of permission is for any user. So a role is actually attached to a user. Attached to a user. And now what is the difference between a cluster role and role? A role is set of permission. Similarly, cluster role is also the set of permission. So what's the difference? A role is attached to a user and the cluster role is attached to the entire cluster. Attached, I will write here, attached to the entire cluster. That is actually the key difference between role and a cluster role. Both are actually the set of permissions, and a role is attached to a single user, whereas a cluster role is attached to the entire Kubernetes cluster. Now in Kubernetes, we must learn that how we can associate any role or a cluster role to a given user or the entire cluster. So in order to associate, or I mean to say, in order to attach any role with a certain user, we have to use role binding in Kubernetes. We can use kind as role binding. Kind, role binding. And for cluster role, we can use cluster role binding. Okay, so this is actually how we can associate any role to a user. We have to use the role binding, and when we use role binding, it will associate a role to a user. Okay, now I hope that you are getting my point, that how we can attach a role to a user. We have to use the role binding, and when we use a role binding as kind in our YAML file, a certain role is going to be attached with a user. So similar is the case with the cluster role. In cluster role, we have to use cluster role binding. Cluster role binding as the kind, okay? And when we associate a cluster role binding to any user, that user will have the set of permissions for the entire cluster. Okay, so being a Kubernetes administrator, if you are the cluster administrator, you can create users and you can attach roles using role bindings to any given users, and that user will have only specific set of permissions to him. And similar is the case with cluster role. We can also attach a cluster role using cluster role binding, and that user will have the permissions for the entire cluster. So guys, you must be thinking that what could be the roles in any Kubernetes cluster and what are the responsibilities of that role. So I would highlight major roles in a Kubernetes cluster like cluster admin. Okay. Just like we have the root user on any Linux server, a root user is the most powerful user and can do anything, right? So we have a cluster admin role. And for instance, if there is a user like me, DevOps Molvi, okay, this is user. And for instance, if I attach cluster admin role to the DevOps Molvi user, it means that DevOps Molvi user can manage the entire cluster, and he has the full power just like any administrator or a root user has in any Linux server. So this is actually the most responsible role. If you are going to give any user cluster admin role, it means that he or she can modify the resources, and that given user with cluster admin role can modify, update, or delete. He or she can delete the resources in a Kubernetes cluster. So you have to be very careful while assigning any cluster admin role to a user for a production Kubernetes cluster. So in order to limit any user for a namespace, for instance, we use namespace and we create resources in any given namespace. So if I want DevOps Molvi user to manage all the resources in any given namespace, I can use the namespace role, and it is actually namespace admin. So when I attach this namespace admin role to DevOps Molvi user, he will be able to manage resources in a given namespace. So that is actually the namespace admin. And now we are limiting the privileges. After that, guys, we have developer role. Okay, developer. And in this role, a developer or a DevOps engineer is able to deploy the applications with limited cluster-wide configurations, can deploy applications with limited access. And after that, we have number 4th, operator. And this role is used for CRDs, custom resource definition. If you want to understand it, for instance, if I have a database in my Kubernetes cluster, so I can assign the operator role to a given user to manage my database. An operator role is used for custom resources in Kubernetes, custom resources. And finally, we have the most least privileged role, and it is read only. Read only, as the name says. So in this role, a user can only view the resources, can view. So it's just like a read-only access. And that user with this role, read-only role, can only view the pods, view the services, but that user, he or she will not be able to modify, update, or delete the resources in Kubernetes cluster. So these are actually the 5 major roles in any Kubernetes cluster. Cluster admin role, just like we have root user in Linux or administrator user in Windows, we have the cluster admin role. And when this role is attached to any given user like DevOps Molvi, it means that DevOps Molvi can manage the entire cluster. And after that, if I want to attach this role, namespace admin role, to the DevOps Molvi user, so it means that DevOps Molvi user will be able to manage the resources in any given namespace. Okay, so after that, we have developer, and in the developer role, only limited access is granted to that user to deploy the applications. And after that, we have the operator role for custom resources in Kubernetes, just like I have shared the example of database. If I want any user to manage the database in my Kubernetes cluster, I can create an operator role and assign it to that user. And after that, guys, we have the least privileged role, and it is read-only role, in which any user can only view the resources. That user cannot modify, update, or delete our resources in any given namespace in our Kubernetes cluster. So now I'm pretty sure that you must have a great idea about security in Kubernetes. We discussed the 9 best practices to secure our Kubernetes cluster. And after that, we discussed the difference between a role and a cluster role in Kubernetes, and what is a role binding and what is a cluster role binding in Kubernetes. And after that, we discussed these 5 major types of roles in role-based access in Kubernetes. Now let's do some practical work in our lab session. Alright guys, now you can see that I have logged into my Minikube cluster, and my Minikube cluster is running, we can see, with Minikube status command. Okay, and it will show us that our Kubernetes cluster is running. So I have these YAML files, and I have created these YAML files to create a role and a cluster role and a role binding and a cluster role binding. So first of all, we can see that we have kubectl get cluster roles. Okay, and now you can see that these are all cluster roles that have been created in our Kubernetes cluster. And you can see this is admin role, cluster admin role, and I have created this cluster role. This is a customized cluster role. And after that, you can see that there are a lot of cluster roles that have been created when this Minikube cluster was configured, or when we set up the Minikube cluster, these roles have been created. And now if I want to see the roles on my default namespace, this is, by the way, the default namespace, and I can run kubectl get roles. So you can see that I have this role 1, that is a role, not a cluster role. Okay, you have to keep in mind that there is a difference between a role and a cluster role. A role consists of permissions that can be applied to a given resource, like pods, like services, like deployments, whereas a cluster role consists of permissions that are applied when it is attached to any given user. It means that this user will have that set of permissions for the entire cluster. So a role is actually limited to a specific user to have that permission, and a cluster role will give a given user set of permissions for the entire cluster. So that is actually the key difference between a role and a cluster role. So now this is a custom role that I have created using the YAML files. I will show you. So for instance, now again, kubectl get cluster roles. And now for instance, if I want to see what any role can do, so for instance, I have this cluster admin role. I will clear the screen. Kubectl describe and cluster role. This is the command and the name of the cluster role. And now you can see that under resources, this status dot status. Now this means the all resources in that cluster, everything in that cluster, pods, services, deployments, StatefulSets, DaemonSets, every kind, every resource. Now this cluster admin role will have those permissions. And now for instance, if I have a DevOps Molvi user and I associate this cluster admin role to the DevOps Molvi user, what it means? It means that DevOps Molvi will have the ability, will have the permissions to update, modify, delete, or whatever he or she wants to do with the cluster, because all the permissions are attached, all the permissions will be associated using the cluster admin role. Now guys, I have a couple of YAML files, and starting from role 1, if I edit it, I will share these YAML files on my GitHub repository. Now you can see the kind is role. For cluster role, the kind would be cluster role. And this is the API version. Namespace would be default. The name of the role, like my role or my default role or role 1, I have given the name as role 1. Now from rules, we mean the permissions. And now this role 1 will have the permissions only on pods. And what kind of permissions? That the user will be able to see the pods, get, watch, and list. So this is actually the basic roles to view or to list the pods, like kubectl get pods. So that user can only view the pods running in the default namespace. Okay, so that's how we can create a really basic role in Kubernetes. Now after that, we can use the role binding .yaml role binding. And now in role binding, you can see that kind is role binding. And what is the purpose of a role binding? A role binding is used to associate a role with a user. Now how? We can see that the name of the role binding is role binding 1, namespace is default, and now we have to share, we have to give the user so that we can associate the role with it. And I have created a user like this is actually the service account, DevOps Molvi 1. And now from here, role reference, you can see that we are attaching role 1 with this DevOps Molvi 1 user. So that's how we can bind any role with any given user. Now, for instance, if I kubectl get role binding, and in role binding, you can see I have this role binding. So for instance, if I run kubectl describe role binding and the name of the role binding, and now you can see the output of this command that role1 is associated with service account and the name of the service account is DevOps Molvi. So that's how we can get the information about any role binding. And similarly, guys, we have other YAML files for cluster roles. So for instance, if I open cluster role1.yaml, and you can see that this role is applicable for the entire cluster. So you can see in this cluster role, we have this rule that is defined that the user can get, watch, and list the pods. So similarly, we have a cluster role binding, and in this we have bound this cluster role with the same service account, which is DevOps Molvi 1. And you can see the role is referenced here, and I have defined that the kind is cluster role and the name of the cluster role is cluster role 1 that we have created earlier. So these are a couple of YAML files. And finally, in the service account, that's how we can bind any role with a service account. And if I run kubectl kubecontrol get service account, in the default namespace, you can see I have two. This is the one I have created for my demo. And now finally, if I want to see what do we have in any role, I can run kubectl describe and the name of the role, which is role1. And now you can see that in this role, there is only one policy rule, and that policy rules describe that the user can get, watch, and list the pods in the default namespace. And similarly, if I want to see the cluster roles, cluster role and cluster role 1 that I created, and you can see that this role is almost the same, and in this role the user can get, watch, and list the pods in the entire cluster. So these are actually the sample files, guys. Now we can modify, we can enhance, and we can add more rules, and the syntax would be almost the same. And now I hope that you have a pretty good idea about how we can manage security in Kubernetes, what is a role-based access, how we can create roles, and also we have discussed about the major types of roles in a Kubernetes cluster. And now I'm pretty sure that we have some basic knowledge of security in Kubernetes. And that's it for today's lecture, guys. I will watch you in the next lecture. Make sure to subscribe DevOps Molvi. Have a good one. Hey ChatGPT, you know that there are over 30 plus DevOps tools. But if I ask you that which tool would you choose for 2025, what would be your choice?
Choosing a DevOps tool for 2025 depends on your specific needs, but Kubernetes is likely to remain a key player. It's versatile, well supported, and continues to evolve. If you're looking for something specific, I can offer a more tailored recommendation.
Nope, thank you. I just wanted to know the tool that you recommend for 2025. So guys, you got the answer, right? Kubernetes is the player. And if you want to learn Kubernetes, I have started Kubernetes tutorials for beginners on my YouTube channel, DevOps Molvi. So make sure to subscribe. Hey ChatGPT, I'm really low on budget and I want to have a small Kubernetes cluster. What is the simplest process to have a Kubernetes cluster of my own?
For a budget-friendly setup, you can start with a local Kubernetes cluster using Minikube or K3s. Minikube, it's an easy-to-use tool for running Kubernetes locally. It supports various hypervisors like VirtualBox or Docker. K3s, a lightweight Kubernetes distribution, perfect for low-resource environments. You can run it on a single node or even on a Raspberry Pi. For cloud-based options, you could look into free tiers from cloud providers like Google Kubernetes Engine, GKE, or Amazon EKS, though these may have limitations. Would you prefer a local setup or a cloud solution?
Yeah, thank you. I think I should start with Minikube.
Great choice. Minikube is straightforward to set up and perfect for learning. If you need any help getting started, just let me know.
Thank you. Have a good one. Hey guys, I hope you're doing great today. this is our first video on Kubernetes interview questions and answers. Guys, I'm super excited to share an update with you that we are going to cover a lot of Kubernetes concepts in this video series. So you can expect hundreds of Kubernetes concepts that we are going to learn together. And to be really honest, guys, if I am asked about the most trending DevOps tool for 2025, the answer is simple. It is Kubernetes. So if you want to excel in your DevOps career, make sure that you are going to learn Kubernetes from the very beginning. And don't worry, DevOps Molvi has got your back. We are going to start with really basic Kubernetes concepts and every Kubernetes terminology. And I hope that you will agree with me that Kubernetes is a whole universe. And the next video would be our first Kubernetes concept, or you can say it would be our first Kubernetes interview question and answer. So stay tuned. Kubernetes knowledge is on your way. Have a good one. What is Kubernetes? Try to explain Kubernetes in really simple words. So Kubernetes is an open source DevOps tool that is used for container orchestration. Kubernetes is one of the most trending DevOps tools that is used to deploy, scale, manage containerized applications. The meaning of Kubernetes is captain. And if I want to quote the example of a captain who is managing the ship which is loaded with thousands of containers. And similarly, Kubernetes is also the captain that manages, monitors, scale thousands or millions or even billions of containers. Okay. Back in 2014, Kubernetes was developed in Google. So we can say that it was a Google's product. But now it is open source and Google was using Kubernetes to manage billions of containers each week. But now Kubernetes is open source platform and the core purpose of Kubernetes is to scale, manage or deploy containerized applications. So when we have millions or billions of containers, we definitely need Kubernetes to watch them out. So the simplest definition of Kubernetes is an open source tool that is used to deploy, scale, and manage containerized applications. Got it. Alright, you have used the term container orchestration. I want to know more about it. What is container orchestration? Since we know that Kubernetes is used to provision, deploy, manage, scale containerized applications, and if we automate these processes, it is known as container orchestration. So the simple concept of container orchestration is the process of automating the management of containerized applications. It is known as orchestration. So if I want to share more details of container orchestration, it is the process which automates the life cycle of containers. It automates the provisioning, scheduling, scaling, deploying, and deleting the containerized applications. All right. And Kubernetes is one of the best open source tools which is used for container orchestration. So we should not be confused with the word container orchestration, and it is an automatic process of provisioning, deploying and scaling applications in containers. And it is known as container orchestration. Okay. Alright, so you told me that Kubernetes is used to manage and deploy containerized applications. Now I want to know which containerization tools Kubernetes works with. Sir, since Kubernetes is an open source tool, that is why it is really compatible with a number of containerization tools. Like for instance, Kubernetes works perfectly with Docker. It also works with Podman, Containerd, and Kubernetes itself has a container runtime, which is known as Kubernetes CLI, which stands for Container Runtime Interface. So it means that Kubernetes supports all these container runtimes, and it is totally our choice to use the container runtime that we like. And most of the times people prefer to use Docker. Yeah, I just wanted this list. Thank you. Hey guys, I hope you're doing great today. Well, I was just randomly searching Google and I found an interesting question. And people were asking about the difference between Kubernetes and Docker, whether they are same. So what do you think? Kubernetes and Docker are the same? And the answer is no. Both tools are different. Kubernetes is different and Docker is also a different tool. But the beautiful fact is that they work together. So the point is now clear that Docker and Kubernetes are not the same, but together they are used to deploy and manage applications in containers. So the key difference that I wanted to share with you guys is that Docker is used to create the containers and Kubernetes is used to manage the containers. That is actually the key difference between Docker and Kubernetes. And it is one of the basic differences of Docker and Kubernetes. We use Docker to create millions of containers, and at the same time we use Kubernetes to manage and watch all those millions of containers. I hope that it is now clear that Docker and Kubernetes are not the same tools, but they work together to manage and deploy applications that are running in containers. What is self-healing in Kubernetes? After container orchestration, I was expecting this question. In simple words, self-healing means to restart the failed containers automatically. So self-healing is a feature in Kubernetes which allows the system to automatically detect and recover from the failures. So when Kubernetes detects that one or more containers are failing, Kubernetes will automatically restart those failed containers. Kubernetes also replaces the containers that are running outdated version. Not only that, Kubernetes also updates the containers automatically if there is an updated version of that software is available. If some containers are not passing the certain health checks, Kubernetes will disable those containers. And last but not the least, if a pod goes down, Kubernetes will automatically deploy a new pod according to the desired state. So all of that process is known as self-healing. And the core purpose of self-healing is to run our containerized applications without any downtime. So in short, restarting a pod, restarting a failed container, disabling a container that is no longer used, or updating containers with the newest version, it is known as self-healing. Okay, well that would be a simple question. What is a Kubernetes cluster? Sir, a Kubernetes cluster is a group of nodes to run containerized applications. And from node, I mean to say a physical server or a virtual machine over the cloud. Sir, ideally in a Kubernetes cluster, there is at least one master node, which is also known as the control plane. And there can be one or more than one worker nodes, which are used to run our workloads. Okay. And the master node or the control plane manages and controls the whole cluster's activities. Sir, a Kubernetes cluster can have a range of nodes. The minimum number is 1 and the maximum number is 5,000. So we can say that a Kubernetes cluster can have up to 5,000 nodes. But for students or DevOps engineers like me, we can use a single node Kubernetes cluster to get our hands on Kubernetes. Got it. What is a master node in Kubernetes? Also, please tell me the components of a master node. Sir, a master node in Kubernetes is also known as the control plane. So we don't have to confuse with the master node or the control plane. They are actually the same thing. Sir, if I want to explain it in more simple words, Kubernetes master node or the control plane is the big guy which controls the small guys which are worker nodes. Okay. So in a Kubernetes cluster, we must have a master node or the control plane to control and manage and watch all the worker nodes. So the master node is responsible for the cluster's management, and it also provides the API, which is known as the Kube-API server, which allows users to configure and manage their resources in a Kubernetes cluster. And there are actually 4 components of a master node: Kube-API server, Kube-Scheduler, Kube-Controller-Manager, and etcd. Alright, so what is a worker node then? Sir, the the worker node is where our containerized applications run. So we have pods that run on worker nodes, and these pods contain containers which are loaded with our applications. So in short, I would say that worker nodes are responsible for running our containerized workloads, and they are also responsible for networking, and at the same time they are in touch with the master node. Okay, and also tell me the components of a worker node. And as far as the components of worker nodes are concerned, there are actually three major components of a worker node. Number one, Kubelet. Number two, Kube-Proxy. And number three, container runtime, which can be containered or Docker or Podman. So briefly explain me what would happen if my master node goes down. Sir, if the master node goes down, all the components of the master node like Kube-API server, Kube-Scheduler, Kube-Controller-Manager and etcd will go down, and it is actually a disaster in the production environment. However, the failing of master nodes will not affect the worker nodes, but as we know that worker nodes communicate with the master node, and therefore all those worker nodes will not be able to serve the traffic. Okay, and eventually if master nodes fail, there would be no traffic served by the worker nodes, and our users will not be able to access our applications. Therefore, it is really important to recover the master node as soon as possible. Thank you. Hey guys, I hope you're doing great today. There are actually four core components of a master node or the control plane. As you know that master node is also known as the control plane in Kubernetes. So what are the four core components of a master node? Number one, Kube-API server. Number two, Kube-Scheduler. Number three, Kube-Controller-Manager. And number four, etcd. So these are the four core components of a master node or the control plane, and I will explain each component in a separate video, so stay tuned. So what is a Kube-API server? So the Kube-API server is the most responsible and the primary component of a Kubernetes cluster. And in simple words, I would like to say that it is the gateway of our Kubernetes cluster. Every request has to process or pass through the Kube-API server. So the Kube-API server validates all the requests. It processes each and every request after its validation. It also authenticates the users. It also retrieves the information from the users and update accordingly. And in other words, I would like to say that Kube-API server is the entry point for all the commands. It is the front end of our Kubernetes cluster. Okay. And there is a beautiful fact about the Kube-API server is that all the components of the master node as well as the worker nodes communicate directly with the Kube-API server. So in short, Kube-API server is the component that manages the whole cluster. Thank you. So how should I avoid the failing of master node in Kubernetes? Explain the brief steps. Sir, earlier you asked me about the failing of master node, so I was expecting this question: how should we avoid master node getting failed? And the answer is simple and straightforward. We can avoid the failing of master node by implementing redundancy. And from redundancy, I mean to say that we must have at least 3 master nodes in our Kubernetes cluster. And we must have a load balancer on top of these master nodes. With the help of load balancer, the traffic is equally distributed among the multiple master nodes. So in case of any failure, for instance, if one of our master node goes down, the traffic should be routed to the working and healthy master nodes. So we must have multiple master nodes to avoid single point of failure. And the recommended number of master nodes is 3 to 5. It is an odd number. I mean to say we must have at least 3 or maximum 5 master nodes in a highly available Kubernetes cluster. So what is a Kube-Scheduler? Explain it with a simple scenario. Sir, it is obvious that as soon as our applications start growing, there are more users, there is more traffic, we have to create new pods so that our users do not face any disruption and our applications run like a charm. So that is the situation where Kube-Scheduler plays a critical role. Kube-Scheduler is one of the important control planes component which is used to schedule new pods on the worker nodes. And a great fact that I like about Kube-Scheduler is that it does not schedule the pods blindly. It finds a node which is the most suitable for running or scheduling new pods according to a certain criteria. Okay. So in order to schedule new pods, Kube-Scheduler makes decisions on certain criteria like resource requirement, hardware constraints, and node selector. So if a worker node meets all the requirements, Kube-Scheduler schedules new pods on that worker node. So what is actually the goal of Kube-Scheduler? Explain it briefly. So we know that Kube-Scheduler is control plane's important component which is used to schedule pods on the worker nodes. And the goal of Kube-Scheduler is to optimize workload distributions. The major goal of Kube-Scheduler is to avoid the worker nodes getting overloaded. Kube-Scheduler ensures that each worker node is running equal number of pods. Okay, and that phenomenon improves the cluster performance and fault tolerance. So we don't have to worry that we are going to abuse one worker node. And we have Kube-Scheduler which is used to schedule pods equally on each worker node. Alright, I just want to know the third component of the master node or the control plane. What is Kube-Controller-Manager? So the Kube-Controller-Manager is a daemon, or we can say that it is a process which manages the collection of controllers. And those controllers are used to maintain the state of the cluster. So the shortest definition or the shortest explanation of Kube-Controller-Manager is that it is a daemon or a process which maintains the cluster's current state. And in case of any changes that happen inside the cluster, the Kube-Controller-Manager tries or makes sure that the cluster is back to its desired state. So the Kube-Controller-Manager watches all the objects inside a cluster, and the Kube-Controller-Manager makes sure that the cluster should be in its desired state. And it is known as Kube-Controller-Manager because it manages a couple of controllers in a Kubernetes cluster. Okay. Alright, so what are the types of the controllers that Kube-Controller-Manager manages? So there are a number of controllers that Kube-Controller-Manager manages, like replication controller, endpoint controllers, namespace controller, service account controllers, node controller, statefulset controller, deployment controller, etc. All these controller types are managed and monitored by the Kube-Controller-Manager. Can you briefly explain how Kube-Controller-Manager works in a Kubernetes cluster? Sure, sir, why not? Sir, we know that the API server is the core component of a Kubernetes cluster, which also manages all the other components of a control plane. And therefore, the Kube-Controller-Manager monitors the cluster state via calling the API server. And after it gets a response from the Kube-API server, the Kube-Controller-Manager changes the state to match the desired state. And by desired state, I mean to say the state that is defined in the cluster's configuration. So whatever state is defined in the cluster's configuration, Kube-Controller-Manager makes sure that the cluster remains in that state at all times. So you told me that the Kube-Controller-Manager makes sure that the cluster remains in the desired state, right? Now I just want to know, what do you mean by the desired state? Sir, from the desired state, I mean to say that state in which the user wants its cluster to be in. And the desired state can be the number of replicas that are needed, the applications should run all the time, and the workloads should also keep running, and the resources that our applications need should be provided to them. Okay, so collectively it becomes the desired state of the cluster, and that state is predefined in the Kubernetes manifests. Hey ChatGPT, you know that there are actually 4 components in the master node or the control plane in Kubernetes. Which one of these components, if in case anyone gets failed, what would be that component if it fails but our cluster remains operational?
In Kubernetes, if the scheduler fails, the cluster can still function with existing pods, but new pods won't be scheduled. This means current workloads continue, but scaling or new deployments are affected.
Alright, but what about the controller-manager? If it fails, will our cluster be operational?
Yes, if the controller-manager fails, the cluster will still be operational for running workloads. However, tasks like node management, endpoint updates, and some automated repair actions won't occur until it's restored.
And what if a Kube-API server gets failed? I think that our cluster will not work properly, right?
That's correct. If the Kube-API server fails, the cluster won't work properly. Existing workloads will keep running, but you won't be able to interact with the cluster, deploy new applications, or make changes.
Alright, thank you. So guys, you got the answer, okay? If Kube-Scheduler gets failed, it means that our new pods cannot be scheduled, but however, our cluster will remain operational. And similar is the case with the Kube-Controller-Manager. If it is not working properly, our cluster will remain operational. However, as a DevOps engineer, we have to make sure that our whole cluster's component, especially the control planes or the master nodes components, are operational and fully functional all the time. And I was thinking that for the last couple of days, and I thought that I should ask AI to get the answer, and I have shared the answer with you guys as well. Have a good one. Hey ChatGPT, would you mind to share how Kube-API server works in Kubernetes?
Sure, the Kube-API server is the central management entity in Kubernetes. It exposes the Kubernetes API, which is used to manage all the resources. The Kube-API server processes REST requests, validates them, and updates the corresponding objects in etcd, which is the cluster's backing store. It also serves as the front end for the cluster's shared state. Anything you want to do in Kubernetes typically goes through the Kube-API server.
So guys, I have explained the same thing to you in my previous video, that every request has to pass through the Kube-API server. So Kube-API server is the primary component. And if you are asked about the Kube-API server in any Kubernetes interview question, you can simply answer that it is the gateway of a Kubernetes cluster. It processes, it validates, it configures each and every request and updates the data in etcd, which is the database of a Kubernetes cluster, accordingly. And I hope that this answers your question. Hey ChatGPT, I want to have all my applications highly available. So what is an ideal Kubernetes cluster that should I have to have my applications highly available, scalable, and flexible?
For high availability, scalability, and flexibility, an ideal Kubernetes cluster setup includes 1. Multiple master nodes. To ensure high availability, have at least 3 master nodes. This provides redundancy and avoids a single point of failure. 2. Multiple worker nodes. Distribute your applications across several worker nodes to handle load and provide redundancy. 3. Load balancer. Use a load balancer to distribute traffic evenly across your nodes, ensuring no single node is overwhelmed. 4. Persistent storage. Implement persistent storage solutions like Ceph or cloud-based storage to ensure data availability and durability. 5. Automated scaling. Use horizontal pod autoscaler, HPA, and cluster autoscaler to automatically adjust the number of pods and nodes based on demand. 6. Monitoring and logging. Integrate tools like Prometheus and Grafana for monitoring, and EFK Stack, Elasticsearch, FluentD, and Kibana for logging. Setting up a cluster with these components ensures your applications are robust and resilient. Do you have any specific requirements in mind?
Yeah, I want to know the minimum number of master nodes and the minimum number of worker nodes according to that situation.
For a highly available Kubernetes cluster, master nodes, a minimum of 3 master nodes is recommended to ensure redundancy and maintain quorum in case one goes down. Worker nodes, at least 2 worker nodes are suggested to distribute the workload and provide redundancy for your applications.
Why 3 master nodes and 2 worker nodes?
3 master nodes ensure high availability and fault tolerance. If one master fails, the cluster can still function with the remaining 2, maintaining quorum. 2 worker nodes help balance the application load, providing redundancy and ensuring your apps remain available if one node goes down. This setup offers a good balance between cost and resilience.
Okay, thank you so much.
You're welcome. If you have any more questions, feel free to ask.
Not at the moment. Hey ChatGPT, what is Kubernetes? Would you please explain it in simple words?
Absolutely. Kubernetes is a system that helps manage applications by organizing them into containers, which are like little packages that hold everything an application needs to run. These containers are spread across different machines, and Kubernetes makes sure they have the right resources like memory and processing power. It also handles tasks like scaling applications up or down based on demand, and recovering from failures to keep everything running smoothly.
Is it Kubernetes or Kubernetes?
It's pronounced Kubernetes.
Okay.
The name comes from the Greek word for helmsman or pilot, which is fitting since Kubernetes helps steer and manage application.
Okay, it means that it is Kubernetes.
Yes, that's right. Kubernetes is how you say it.
Hey ChatGPT, if Kube-API server in my Kubernetes cluster is not working properly, will my cluster work efficiently?
If the Kube-API server isn't working properly, your cluster's functionality will be severely affected.
Yeah.
Since the Kube-API server is the core component that handles all API requests, if it goes down or isn't functioning correctly, you won't be able to manage your cluster resources effectively. Operations like scheduling, scaling, and updating resources depend on it. So maintaining a healthy Kube-API server is crucial for your cluster to work efficiently.
Is there any other way around if my Kube-API server is failing? How can I maintain cluster's functionality?
To maintain your cluster's functionality, if the Kube-API server fails, you can set up high availability. This involves running multiple instances of the Kube-API server across different nodes.
What are you up to, man? I'm just preparing for Kubernetes interview questions and answers. Wow, Kubernetes! Are you going to upload Kubernetes videos? Yeah, there would be a lot of interview questions and answers covering all the Kubernetes concepts. Man, that is awesome! Yeah, man, you can follow me on TikTok and you can subscribe my DevOps Molvi YouTube channel. Wow! It means that I would have to follow you on TikTok and I will subscribe your DevOps Molvi YouTube channel. Yeah, I have already uploaded what is Kubernetes and how Kubernetes works in detail on my YouTube channel. And I will cover all the Kubernetes concepts, and there would be tons of Kubernetes concepts that we will together cover them. Yeah, man, I'm looking forward to learn a lot about Kubernetes. Thanks, man. I will watch those lectures. We are going to become Kubernetes experts. So what is a pod in Kubernetes? So in Kubernetes, a pod is the smallest deployment unit. A pod consists of multiple containers that are tightly coupled together. A pod is a point where our applications run. All the containers in a single pod share the same network, same storage, and they are co-located on the same worker node. So in short, we can also say that a pod is the basic building block of a Kubernetes cluster.